is Matt Klassen. I'm the Executive Director of TMA BlueTech. I'm really happy to welcome you all today. Sorry. Is that better? Testing? Okay, that works. All right, yes. So we're going to start the day. Well, it'll be a relaxed start just because we will, still waiting for a couple of speakers to show up for the first panel. But yes, Matt Klassen, TMA BlueTech. I'm the Executive Director since about 14 months ago. I first joined TMA BlueTech as a member back in 2019, and BlueTech Week was my first experience with TMA, and that year it was mind-blowing, I should say. It was really inspiring to know that the kinds of technologies that are out there that have real-world impacts on ocean and water health and sustainability are not just conceptual, but actually, in many cases, in practice. And there's a whole model behind it as well, and it's only growing now as ocean and water issues become more and more exacerbated. So it's a wonderful time to be in the sector right now. We have some fantastic speakers as well to show you what they're doing in individual spaces. We also have some featured speakers as well. A lot of people have flown in from around the country. A couple of people have flown in from around the world to be here. And so welcome them, welcome everybody here. A little bit of the run of show. Carl Goldman from NOAA is here, and he will be the MC for the day. He will be the moderator, and he's well experienced in this particular task, and so he will do it very well, I'm sure. A little bit about tomorrow as well. So we're here for today, but we also have tomorrow and Thursday will be additional BlueTech days. Those are the BlueTech Summit and Expos, which will be at Liberty Station for both Wednesday and Thursday. I don't believe that there will be any striking there, and I do know that the parking is much more advantageous than here. Wonderful location. Liberty Station is known for its restaurants and places to walk and stroll and just to enjoy the scenery. The one disadvantage we have with this wonderful location is that it's on the flight path of outgoing planes. And so when we're on the inside, the room is soundproofed. Proofed. It's just lessened. But we'll deal with that. Apparently with the sound system, it minimizes it as much as possible. I only tell you this in advance because you will want to go outside at some point because it's a nice place to be. And you'll just have to take like the 5 to 10 second pause in your conversations when you're outside. So just have fun with it. Look at each other like, here we go, another 5 or 10 seconds. It's just how it is here in San Diego. But I do want to tell you about the programming tomorrow as well, just so you're aware. We have decided this year to focus on 2 particular areas that we find are making significant strides or have the potential to be game changers in the sectors, their individual sectors. So on the first day, in the main hall, we're going to have the offshore renewable energy sector. And we've got people from around the world and around the U.S. Speaking on 6 different panels to talk about exactly what is happening in different aspects of that particular sector in the California and West Coast markets. Very, very exciting content. We also have something that's quite fascinating as well in a separate breakout room, which is going to be a smaller room. It's just right across from the main entrance of the main hall. It's called the New Space Economy, and where that has to do with Earth observation, where ocean and water observation are involved. This is just a fascinating space to be in, and we have some incredible speakers talking about different aspects of what the new space economy is. It's just a sampling of what that is, but it's all just amazing. That really, I'm looking forward to be able to listen to as many of these as possible. But that is going to be on Wednesday. Then on Thursday, in the main hall, we have sustainable commercial shipping. Now, I hadn't heard about sustainable commercial shipping being even a thing. Like you just see like commercial shipping, and you see these massive ships transporting massive amounts of goods and services. You hear about the carbon imprint and everything else. Like, so what's actually happening? But at the UN Ocean Conference in Portugal of this year, one of the gentlemen who's actually with the International Windship Association, Gavin Allwright, he'll provide a video address tomorrow. He's all about wind energy propulsion for ships. And he was telling me that there is a massive shift towards sustainability in the commercial shipping sector as we speak, and it's happening very, very quickly. And so We have some people coming in also from around the country, around the world, to talk about what they're doing in individual ways with commercial shipping or sustainable commercial shipping. It's going to be fascinating. It's, change is happening right now without us really even being aware of it in many cases. So again, it's an exciting time to be alive. The fourth panel is going to be advanced water technologies. So as you know, we live in Southern California, and we have quite a few very advanced water technologies companies because of, water issues we have down here, whether it be freshwater production, desalination, how to recover water, wastewater, brown water, as well as what's going to be interesting is we're actually going to start to talk about we'll have a couple of panels that will talk about what the trends are, and how we might be able to change the model for how water is even valued. Like, how do you monetize water? And we're going to delve into what I've been told is maybe into a little bit more of the politically risky realm because of a very, very scarce resource, and of course there's going to be politics around that. So how do we navigate that successfully, as well as just to maybe plant some new ideas about how it could be done differently, as well as how to actually make San Diego or make it even greater than it has been in the water tech sector. So that's going to be a really fantastic panel as well. That's going to be on Thursday. So that's it for me for now. I'll have more to say as we go along over the next couple of days. But just thank you so much for coming. Enjoy yourselves. Be friendly. This is a friendly event. I know a lot of times and I'll say this again over the next couple of days, we come and we want to conduct business. We want to be able to justify the expense to come out here. We all get that, right? But this is what we call a blue family. We're all here on this pale blue dot together. And the ocean and water health is increasingly important, and we're seeing that now. There's more money going into this now. We're getting more concerned, but also great things are on the horizon. So we're the big blue family. Go say hi to people whom you don't know. Feel free to, maybe take a risk, because I'm always nervous to go meet people I don't know. Shake a hand. Be friendly. You'll see each other again at these types of events in the future. I know that I have in my my first 14 months here, and it's fun. I get to see people like, hey, what are you doing here? Usual suspects. I've said it about 5 times today with different people, right? And it's always fun. One final thing I'll say, because this is also one of the fun things, is that we'll have a reception today after the last presentation ends, and it is going to be of special magnificence. If you guys know the Hobbit, that's been used in the Hobbit before, of special magnificence. Blue Robotics has actually brought in some specially made beer for them. It's called Blue Rover. I believe it's some sort of a blueberry sour beer. So that'll be on offer, and make sure to raise a glass and to be extremely merry. And we also we'll have some red wine and some white wine as well on offer. So that'll last until about 7. So we have a beautiful atmosphere, fantastic content, inspiring speakers. It's got all the makings of a wonderful day. So just thank you so much for being here. I will pass it off to the MC for the day, Carl Goldman. Thank you very much.
Hello, everyone. Thank you, Matt. My name is Carl Goldman. I am the director of the U.S. Integrated Ocean Observing System Office within the National Ocean Service, part of NOAA, the National Oceanic and Atmospheric Administration. We have lots of acronyms. I'll try not to use them all. I'll try to spell them out and say the actual words. I've been coming to BlueTech Week since as long as I can remember, maybe 10 years or so now. This day at the forum at Scripps, thank you so much for Scripps for hosting. This setting is unbelievable. The Connect, Influence, and Accelerate as the tagline. Be friendly, meet people. I challenge you also to do a little work. Ask people, what are you trying to achieve? What's hard? What are your challenges? What do I do that's related to that? How do we do things together? That's what the networking piece of this is that's interesting to me. So from a government program, I fund ocean observing systems that are intended to apply to issues and provide decision support tools and information for management, for commerce, for safety. So I'm on the applied side of ocean technology, and I'm blown away by the brilliant scientists and technologists that bring those capabilities to bear to meet societal needs. And so I have the benefit of having 11 regions in the U.S. that get funding from our office to do the applied side work. Clarissa Anderson in the audience here is from the Southern California Ocean Observing System Director, and she's located here on a regular basis. And so we often talk about what's the next thing we can do, what's the next gap in our capabilities, how do we get that thing funded, and all of that. And so I'm on a really practical level, program manager type person who has to work with scientists and technologists to try to figure out how to argue up in the halls of Congress for the resources we need to do this type of work. So I'm sort of all along that, and I try to describe the value chain of observations technologies to solutions. And we can't do that with government alone. We can't do that with private sector alone. We can't do that with academia alone. We can't do that with NGOs alone. So these types of events for me are of high value, where we try to figure out how do we do these things together. How do you figure out capability X, Y, Z? We can make a project to do PDQ. So projectizing work in units to make incremental progress to fill a gap in a capability and a need. That's the sort of thing I worry about every day. And so I'm really thrilled to be here this week and be a part of these proceedings. I will try to be a capable MC. If you have questions or challenges, ask me and I'll try to find someone who can answer. And I really look forward to making it through the day, and having the event on the veranda here at the end of the day is always a pleasure. So without further ado, let's get to it. First off, we're going to have our keynote speaker, Dr. Doug Bartlett, Deputy Director for Research and Associate Vice Chancellor for Marine Sciences at Scripps Institute of Oceanography. Dr. Bartlett received his PhD in microbial molecular biology at the University of Illinois in 1985 and assumed faculty position at Scripps Institute of Oceanography in 1989. Dr. Bartlett has extensive experience in analysis of extremophilic microbial life in the inner space of our oceans, and he'll tell you about that. His research group pursues studies of the adaptations that enable deep-sea microbes to live at great pressures, up to and beyond 15,000 pounds per square inch. Much of his work utilizes the tools of genetics, genomics, and functional genomics, as well as the use of autonomous sampling instruments to recover deep-sea samples. It is hoped that the future generations of these instruments will enable greater capabilities for exploration and sample recovery. Please welcome Dr. Doug Bartlett.
Thank you, Carl. But I'm not here to be a keynote speaker. I'm just here to really welcome you. Tom will take over that role. but I'm here representing SIO, and so Matt, Carl, whether you are from a industry, whether you're from a government agency, whether you're from academia, an NGO, it's really great to have you here at SIO. My understanding is that here at Scripps we've hosted the Tuesday portion of BlueTech Week for I think 7 times. I'm not sure if that's right. I think going back to 2016. So I hope this is a trend that will continue for a long time. Our participation solidifies our position as a liaison between scientific research, innovation, and the growth of the blue economy sector in San Diego. BlueTech Week is a valuable opportunity for Scripps research to be shared with those of you from industry and government agencies. It means a lot to our people here to be able to connect with all of you. We maintain a formal connection with BlueTech Week through Vanessa Scott, who will be a part of the program this afternoon. Vanessa is the SAO Director of Corporate Affiliates, Business Development, Industry Outreach, and Innovation. She's also a member of the board of TMA BlueTech. But there's much alignment between what you folks who are concerned with the blue economy and blue technology are trying to do and what we're trying to do here at SIO. Innovation that translates into applications is much of what we have done here and what we do now. I think it's safe to say that doing translational science is a growing part of what we do at Scripps. It's a growing part of what federal agencies are funding and private foundations are funding today. One example, and I want to give you a few examples of how we try and connect to blue technology, how we think about ocean engineering, and how we connect to ocean-related biotechnology. One example of that is our Start Blue Technology Company Formation Accelerator Program. This is a joint offering between Scripps Institution of Oceanography and another part of UCSD, the Rady School of Management. And so Rady takes care of the business part of this accelerator program. Scripps takes part in the technology part of it all. And we know that innovation networks like Start Blue, or another one that we have here in partnership with the Jacobs School of Engineering, which is called the Triton Innovation Challenge, we know they work. Scripps alumnus and polar oceanographer Dr. Jack Pan participated in the Triton Innovation Challenge while a student here, which helped launch his startup company, Ocean Motion Tech. This company uses technology to convert the power of the ocean into usable electricity for small-scale power needs at sea for scientific and maritime buoys and moorings, offshore aquaculture, and coastal security and defense. Some additional examples of the engineering part of Blue Technology are the wire walker. The wire walker is another example of an energy-efficient technology applied at sea. Wire walkers harness the energy of ocean waves to move sensors vertically through the water column, capturing detailed measurements of the physical environment during their ascent. SIO and mechanical and aerospace engineering professor Drew Lucas here is a project co-investigator and developer of the wire walker technology. The wire walker has numerous applications, for example, to provide information about the physical characteristics of seawater that coincide with harmful algal blooms. I suspect Clarissa will talk a little bit more about ocean monitoring as it relates to HABs or harmful algal blooms later today. And then another aspect of engineering that we are super excited about here at Scripps, and this is just something that's planned. It's not reality yet, but it could be a game changer, and that is our planned development of a hybrid research vessel. California legislators have allocated $35 million towards the design and the construction of a 120-foot long new research vessel to replace our aging vessel, the Robert Gordon Sproul, that has served us very well for many years. This new vessel will feature innovation hybrid propulsion systems that integrate hydrogen fuel cells alongside a conventional diesel propulsion system, diesel electric power plant, enabling zero-emission operations. As you know, emissions from diesel engines on ships contribute to both greenhouse gases and pollutants like NOx and SOx. This hybrid design will be scaled so the ship will be able to operate 75% of its time entirely using a non-fossil fuel, hydrogen, with only pure water and electricity as reaction products. The naval architecture and marine engineering company Gloston has been selected as the naval architect for the university's new research vessel. It will take about a year for design completion and then another 2 years for construction. But it will be very exciting and as I say, a game changer, I think, when it comes to research at sea. A few additional examples of how some of the engineering work can connect to our interest in biology and in biotechnology and in ecosystem monitoring. So SIO researcher Eric Terrell here at SIO and colleagues have used autonomous underwater vehicles equipped with side-scan sonar configured for wide area mapping to survey about 150 square kilometers between Palos Verdes and the Palos Verdes Peninsula and Catalina Island. So going from the LA Long Beach area out towards Catalina Island. This is where the San Pedro Basin is located, and they're monitoring the seafloor at and this is at water depths of 600 and 900 meters, where there was a dump site used by various industries and includes byproducts of petroleum, including the pesticide dichlorodiphenyl trichloroethane, or better known to all of us as DDT, a well-known insecticide and human carcinogen. The dumping took place between 1947 and 61. Industrial waste up to 2,000 barrels or barrel equivalents per month were reportedly dumped, resulting in an estimated 767 tons of DDT and other waste products. Eric's analyses have identified about 100,000 acoustic anomalies, and of those, about 27,000 have barrel-like characteristics that would be consistent with the barrels that were dumped at this location. So with ongoing support from NOAA, we will be assessing the extent and impact of DDT dumping and quantify the penetration of this and other toxins into marine food webs. This will include the use of our California Cooperative Oceanic Fisheries Investigations, or CalCOFFI, program samples. This is a program that goes back over 70 years of collecting fish and plankton. And we now are in a position to be able to go back through time, look at the bioaccumulation of toxin in these fish, and better quantify the presence and the accumulation and hopefully the loss of DDT in our ocean food webs. And then finally, just one more example. SIO is involved in blue technology as it relates to biotechnology. We are currently in discussions with Serenus, a marine-derived drug discovery pharmaceutical company in the area. This is led by Dr. Eduardo Esquenazi, a former Scripps PhD student who has been incredibly successful in biotech development. And Serenus is going to partner with our Center for Marine Biotechnology and Biomedicine for us to scale up our drug discovery programs here, and this would complement a gift of robotic liquid handling systems we have received from Illumina Corporation and our plans for a new building dedicated to these kinds of analyses. So that gives you a little flavor of some of the areas we're going into that relate to blue technology here at Scripps and why we really want to be partnering with all of you. So I'm really excited about this morning, and I hope you'll have a wonderful day. And just in an outline, maybe this is something that you'd want to mention, Carl. I was going to say next up is Tom Fu, Head Mission Capable Persistent and Survivable Naval Platforms Department, Office of Naval Research. And then we have another featured speaker, Amanda Netburn, who is I'm proud to say, a Scripps product, and she's the Deputy Division Chief for Science and Technology at NOAA's Office of Ocean Exploration and Research, and that's a program that I've long admired and I've also benefited from. And then we have 4 panels, technology from Teledyne and Kongsberg, as well as from our own Nathalie Zilberman, who will tell you all about the Argo program here. And then we have panels on workforce development, environmental monitoring, innovation, and blue technology. It all sounds super exciting. I hope you have a great meeting, and welcome.
Thank you. Any good moderator, any good master of ceremonies has folks in the audience helping them? I said Scripps, and I said the Institution of Oceanography, and I said it wrong before, so corrected I am. So one quick, just personal note. Yesterday I had the pleasure of getting to tour San Diego Bay with the port operations folks, Jason Giffen, I think? Yeah, Giffen. And his team, and it was just amazing to get to see the natural resources here, and then the commerce and the military assets in terms of everything that's there, and then the activities going on in terms of restoration project, aquaculture projects, all around the bay. And it was pretty thrilling to get to go in the interdiction boat that the harbor police have there with just a few horsepower on the back of that, and we got to go pretty fast. So that for me was a great introduction to town yesterday as I flew in, right after we flew in. So without further ado, now after our wonderful welcome speaker, I'm now shifting to our keynote speaker, Dr. Thomas Fu, Head of Mission Capable Persistent and Survivable Naval Platforms Department of Office of Naval Research. Dr. Fu is oversees a broad range of science and technology programs for Navy and the Marine Corps platforms and undersea weapons, and with an annual budget of over $500 million per year. And without further ado, take it away.
No, I'm good. Thank you. Anyway, thank you for the introduction. Thank you for attending. This will be a little bit of a broad swath because folks probably aren't, well, some of you are familiar with Office of Naval Research, some probably not. Some probably will be, again, based on the topic of translating science into solutions for BlueTech. This is, that is what the Office of Naval Research does. Am I forwarding? Do we know? I guess I can check.
So open it.
Okay, then I can just tab through. Okay, anyway, let's just get on with it. So this is preaching to the choir, obviously, right? So you're BlueTech, you're focused on the oceans, you're focused on water quality, you're focused on water safety. We're at Scripps. It is this piece, but I think it's sort of you can't say it enough how much the world depends on the oceans, right? That's whether it's weather, whether it's the technology, whether it's communication, right? People sort of lose track that 99% of the intercontinental communication is through undersea cables, right? So we're thinking that it's cool and it's satellites and all. It's undersea cables, right? So it's and that's kind of the driver. But again, so we're a water world. BlueTech's important because of that, and we're really driving all that as part of this week of what that means. But I bring it back all the time. We are a changing world, and if we haven't seen that over the past few years, you were not paying attention, right? So it's a changing world, whether it's just seasonal change, it's a changing world because of climate change, it's a changing world just because of everything else. But one of the things that people lose track of, and maybe folks that have been in the area for a while doing research for 30 plus years, as Doug and I have commiserated, it's changed, right? It used to be that the government was the largest federal, funding agency for source of R&D dollars. Well, you can look at it, and this is FY17, 108 billion in R&D from corporations. Department of the Navy budget 2.4 back then. I think it's close to 2.7 now. So you could argue that's not even inflation, NSF, but that's really what's happened, right? So you really are looking at it as a different world where it is going to be a startup commercialized world, but is that sufficient? Is that how it's going? And so that's why it is more and more important, the connect, influence, accelerate. You have to speak to each other. You've got to connect. It's going to be a different kind of world that we operate in. And for the Navy and Marine Corps, that's the same function that you're seeing. We'll talk about it. So the S&T R&D ecosystem, the research ecosystem, the technology development has fundamentally changed. But then there's other change, right? So there's Fukushima, there's Santa Rosa forest fires, there's 9/11. All those major changes to how we function, worked, dealt with things. And those changes are, just come out of nowhere. I don't think anybody was predicting them, though you could say forest fires, maybe that's something we should be paying attention to. But it functionally changed how the world worked. And then you said, okay, even more so right now in our last few years, right? COVID came along, January 6th came along, the Black Lives Matter. It actually changed how the world works and operates, we think of the world differently because of those. Again, those are somewhat external to our day-to-day world, I would say, our day-to-day operations, how we do things. But it's the change comes even when it is within our own realm. So interim national security strategic guidance, that is the strategic guidance that as part of the Department of the Navy that we're handed. That's a 2021 document. Just this year, 2022 became the real national defense strategy, not the interim one. But if you look at the interim strategy, it does say a dynamic, inclusive, innovative national economy. It does say equitable, clean, and resilient energy future. It does say that will deal with existential risk posed by climate, and will focus on sparking innovation, load into a carbon future. Those are all the things that this group should be focused on. It is fundamentally part of the nation's national defense strategy to start addressing those, because those are game changers. Then you look at, as you scroll down, if you're at Scripps, expand our science and technology workforce by investing in STEM education. Most of us that are cynical would say, okay, it's a sentence in a national defense strategy, and I'll make my PowerPoints just like this and say, hey, look, we're doing these things. No, we're talking about $100 million of O&R funding going to 6-1 research, basic research. It is not a trivial amount. Our current budget out of that $2.7 billion is about $600 million. We're talking about an increase of $100 million. NSF going up to $2 more billion, something like that. I think they're talking about $10 billion up from their $8 billion. So this is putting money where the strategy thinks it needs to go to look to the future. So this is S&T 6-1 dollars. This is grad students and postdocs. So this is looking towards the future. So here's the problem. This came out of Steve Blank's book a while ago up at Stanford on in the innovation startup space. The problem is you've got to keep working faster and harder just to keep pace. And at the same time, you've got this, Darwin problem of the world's, as I just said, the world is changing. How do you keep pace? And it's not enough to keep pace. If you don't constantly adapt, evolve, and proliferate, you're not just doing that for an advantage. You have to do that to not get left behind. And so that's a different mindset for people to really think about. We'd like to think that we could come into our little lives, careers, companies, and do these things and have 30 years of evolution and the world will pass you by. And so how do you keep doing that in a world that's constantly changing? And so it's not enough to just say it's business as usual. It is a looking forward, and again, it's all the running you can do just to stay in place. So what's happening? So we're all very proud. We all studied technology and science, and we said we've done all these things. So this chart, which says here's the Human Social Development Index, which is a combination of a number of factors based on our health, social status, wealth, quality of life, and then there's population. Well, what you look at it is when you plot the two against each other, you see, wait, our human social development just tracks population growth. It's mostly because we have more people, so we do better, except for a few little bumps. And the major bump is really the steam engine, right? It's really the Industrial Revolution. You don't see a bump, even though we'd be very proud of, hey, computers and the internet and all this information age stuff. It's not really changing our quality of life. We're not that much, we all have our smartphones. We all sit in front of a computer and answer emails all day long. Has that actually made us more productive? The reality is the data says no, it hasn't, right? We spend more time, I have a friend, we kid about this. We spend more time trying to debate what colors to choose in PowerPoint than actually thinking about what's on our slide, right? That's the question. So steam engine made a bump in our quality of life. The rest of it, maybe not. So what is there that's going to make that bump? And again, we're at 8 billion people now. So you can look at it and say, okay, Moore's Law, the computing piece, I argue all the time with the CFD folks out there that they haven't gotten any better. The computers have gotten a lot better. Their algorithms not much since I was in school and Numerical Recipes was published. But somewhere around 2045, there's more compute power in the world than there is brain power in the world. So what does that fundamentally mean? We're looking at an AI, scientific AI ML world where, they can map protein, structure. They can map matrix multiplication algorithm. The AI is developing algorithms to do matrix multiplication that are more efficient than the human ones and more efficient than the brute force one. That matters. That's an AI figuring that out by just trying on its own. So something may happen. That's the theory, that eventually this compute power is going to mean something. What that is, we don't know. But that's kind of where things are headed. So that kind of change is coming, right? So there's a singularity, technology singularity that's coming. what happens. But then I bring this back to the Navy side, right? So you look down there and you say, hey, we keep aircraft carriers for 50 years plus. We keep, our submarine force for, even though they're designed for 30-ish, we keep them for 40-ish if we refuel them. Okay, go back in time 30, 40, 50 years and imagine what your cars were like. Imagine if you had we didn't have personal computers 50 years ago sitting on our desks probably, right? But that's how the Navy operates, right? These are long-term investments, long-term platforms, right? So it's a different strategy. The question is that the right strategy? Maybe that's fundamentally going to change. But what does that mean? That's my job. Are we really going to keep Navy platforms that long? So you can go read the book, Second Machine Age, 3 Conclusions. We're living in a time of astonishing progress. Digital technologies are changing how we work and how we live. It also asserts, so it's not a depressing book, that it is going to be profoundly beneficial, that it is better. It is better that I can Uber. It's better that I can, coordinate. We waste less time, right? But it's going to present some societal and cultural challenges. It is going to leave some people behind. We are seeing that now. Again, there's never been a better time to be the worker, the person with that skill set, the organization, the company that has that special skill set that can be applied to these problems. But there has never been a worse time because those digital tools will pass you by, right? They are doing things that have never been done before that most people can't do. And what does that mean for the industry? So this is it, right? This was Kennedy's quote from the convention back in 1960 about for space. But this is our digital energy climate frontier. This is a chance to actually define what that is. You can look at the agenda for the next couple days. You can look. These are the topics. But I'm saying it's not just the topics for the next couple days. You need to think beyond that. You better have the vision for where those pieces are going. Again, because it's not the strongest or the most intelligent that survives. It's the one who's most adaptable. So you better be paying attention to what that means. So the challenge, translating science into solutions. So there's San Diego and there's Florence. And you're going, why is Florence, Italy on here? Because a couple of years ago, there was a book written by Franz Johansson called The Medici Effect about Florence in the 14th and 15th century, where, again, the assertion is the Medicis were able to bring artists, scientists, poets, architects, theologians, and philosophers to Florence, and Florence flourished as a center for culture and advancement. That's what this opportunity is. That's what TMA provides you. You have a chance to connect with a broad range of areas, technologies. It's not just going to be, engineering and science. It's going to be broader than that. It's going to be societal. It's going to be business. It's going to be policy, right? But that's where you're going to get new ideas. That's where you're going to come through there. And again, it is the metaphor for bringing a diverse group together to go do these problems. Not the evolutionary, not your next step, but what is going to be the big win in this space. So it is how ONR is moving in that thing. It is a mindset. It is behaviors. It's really looking at the power of diversity and including a wide range of groups. That's how you succeed. It is going to be about information and performance and skills and leveraging everybody's specialized skills in that way. It is going to be what you see across the board. It is about experimentation, which is, trying things and learning fast and trying to do things in executable steps, not these giant. It's not going to be give me $20 million and I'll go start a new program. It's going to be learning as you go and evolving in time. That's that constant reframing. You're going to have to evolve and adapt, and you're going to have to dynamically allocate resources. People hate that. I'm a funding agency. I'm going to say, no. I'm going to give you a little chunk of money right now, and if it works, I'll give you the next chunk, and I'll give you the chunk after that. But if it doesn't work, we're going to move on. Or again, there's students involved. The students will get funded, but the big projects have to keep changing and evolve to move things forward. And that's what you're going to see going forward. There are already things happening in that piece, right? Purdue University's put together a consortium of activities they're really looking at how to grow the STEM workforce, and they're really challenging that STEM workforce to be a group for the future, right? They're really looking at how do you solve the big challenges of tomorrow. So not O&R 3-year grant challenges, full on, how are you going to solve the power and energy piece? How are you really going to go to zero emission, right? What is the renewable space we're going to play in? So there's a chance, right? And so those are the opportunities that are being funded, is place bets and go for the big wins. So why? Because it matters, right? So this is a slide I show at the end of most of my talks for the Navy, which we're the Office of Naval Research. You know, I'm not fielding anything that's going to get out there in the next, closest thing might be 5 years. Most of the 6-1 basic applied research is 10, 20 years out there. It is babies, right? It's my grandson. He's 2.5. That's the stuff that's going to be fielded when he's 18, right? That's why it matters. It's the grad students, it's the postdocs, and it does matter because there are sailors and Marines out there right now, you know, in harm's way. We've got to protect them. And so when you look at, hey, what is Scripps doing in the oceanography space for undersea, studies, even Eric's stuff that you mentioned, right? So I can say it. Eric's UUV is all funded originally by O&R under Terry Palukas's Plus program, right? So those are O&R 6-1 activities that go onto these broader capabilities, right? That's where it matters. That's where it shows up. Again, people will say, you know, I will say it all the time. What is that real product coming out of O&R? It's people. It's grad students and postdocs. It's PhDs. That's what happens. Why does it matter? Because again, this is about the future. This is about dreaming what the future is, and this is about creating it. And that's why the BlueTech space is so exciting. That'll take some questions.
Anybody with questions?
As a startup BlueTech space, does your program solely what you sponsor have to have a military application?
So it depends. If you look in the basic and applied research side of the house, no, it doesn't. I mean, ultimately it does, but I would argue all oceanography, ultimately all METOC has a military application. In the more applied space, it is really up to the program officers to look at that. So for the startups really looking at things, there is, not my department, but you know, there is NavalX, which is an organization under O&R, which is really investing in startups, commercialization of those activities. Now, I will also be, and for the people that have heard me speak before, I will argue that whoever cracks the clean energy space, you know, the real zero emission, there will be a huge economic, again, it's in one of the slides, economic advantage is a huge national security advantage, right? So whoever cracks some of these questions about clean water, renewable energy, zero emission energy, there will be a huge economic advantage that immediately becomes a national security advantage. If you actually read, I pulled the slide, I think, the O&R mandate is not about capability or military capability. It is really about there's a military advantage to having a strong S&T enterprise within the United States, and there's a huge national security advantage. It's not about specific activities. It is growing that ecosystem. Now, there's lots of people that will disagree with me now, but I'm like, that's what the congressional language says. And so what you got was, those are probably some reasonably smart people back in the day.
All right, let's do one more question.
What do you, I'm Scott Longer from Kongsberg. What do you see as some of the biggest impediments to some of these technological advances?
Short-sightedness, how about that? you know, I live it every day now, right? I live in a world where I've got to propose an annual budget. I've got to propose a budget for, I'm doing it right now for FY24. We just started FY23, and I'm laying in the arguments for FY25. That's all the Pentagon and the Congress cares about, but every investment I'm looking at is way beyond that. And so I just live in a world where those arguments are just disconnected, and that's hard. Sure.
Yeah.
Is the Navy actually preparing for the singularity, or how are you? I mean, it sounds we do what we best we can for 20 years, and then who knows what's going to happen?
I think with the Navy, okay, so again, if you look at, you know, Navy's budget, $700 billion, something like that. You know, ONR's budget, 2.7, so it ends up being 1.7%. ONR is very much interested in what does all this compute power bring, right, to research technologies. There is a hard look at, you know, what does that actually mean for decision making, and I think it's, you know, you can already see pieces of it. So is the Navy worried about it? Is the Navy doing things about it? Yes. Again, when does it become, you know, integrated in everything we do? That's a long time. It's a different question, you know.
I think we have time for one more if there's any other questions.
I know that's a broad question. I apologize. I would say it's the same, right? Actually, it's us. It's our own bias. It's our own beliefs. It's everything. We get in our way more than we'd like to acknowledge, right? So when I say that, you know, the short-sightedness on the technology is the same short-sightedness on our ability to actually crack through that. We have way too many biases and beliefs that are just untrue, and we get in our way, and we can't get around that for whatever reason. So I would say, you know, it's, you know, like it or not, we all have to look in the mirror and say, I'm not doing enough.
Why don't you come on up? We're going to have our first panel, Ocean Data 2.0, the journey from abstract science to powerful solutions. And our order of speakers, we're going to have Dr. Nathalie Zilberman. Did I say that right? Good. And then Yi Chow. And then Paul, are you here? Yes. Paul. Very good to see you again. And Leif will follow that. And I've got Nathalie, go ahead and come on up here. Nathalie's a researcher from the Integrated Oceanography Division and Climate Atmospheric Science and Physical Oceanography Division here at Scripps Institution of Oceanography. Your slides are there. And I will sit down here with the panel. Take it away.
Okay, thanks you all for being here today. So in this presentation, I'm just going to give an introduction of the transition and evolution of ocean observing system. I will then talk about the Argo program and planned expansions of Argo, and then I will finish off with the summaries of Argo's keys to success. So in this slide, I'm showing a few things. First, the bottom panel is showing a summary of all the observations that are currently available for studying ocean observing. And you can see that it's a blend of remotely sensed observation and in-situ observations. Some of them are floats or gliders, buoys, and ships. And what's interesting is that in the evolution of the ocean observing is this transition from observations that were collected mostly from ships to autonomous robots that you can just deploy and they do their thing for up to 10 years, collect data and transmit data to satellite. Most of the observations that are currently available, and you can see this strong increase in the observations available in the top right panel is coming from Argo floats and ocean gliders. The top left panel is showing another interesting fact is that you can see a transition from blue to red in the upper 2,000 meters, and that's largely contributed for by Argo. But underneath, below 2,000 meters, it's mostly blue, indicating that there's not much observations and that the deep ocean is largely unmeasured. So the Argo data set is the main source for subsurface ocean observation and is routinely used in weather and climate prediction. This map is showing the current locations of the floats that are active. They are color-coded by countries. There are 30 nations that are currently contributing to Argo. Argo is an international program. So the bottom figure is showing a typical cycle from an Argo float. The float descends to parking depth, where it drifts for about 9 days. Then it descends to maximum depth, that is either 2,000 meters or 4,000 to 6,000 meters for the deep floats. And then measure temperature and salinity on the way up, transmits to satellite, and then start a new cycle. So something that is very important for Argo is that the data is available without any restrictions. And I'm not only talking about temperature and salinity data, but also engineering data and metadata so that you know how good the data is and how well the float is doing. And because of this availability of the Argo data set, there's a very high number of publications every year. There's a science article using the Argo data set that's published every 16 hours. This is gigantic. Over 5,000 research papers and over 400 PhD theses have been published since 2002. So in the next few slides, I'm just going to talk about the value of the Argo data set and the use of it and why it's important. So this figure is showing an example of the use of Argo in ocean models. So the OSSIS, the Observing System Simulation Experiment, is just a way of assessing how important an ocean observation is and how much of an improvement it leads to in the results of the simulations. So this is showing two things. In the right panel, this is showing that if you if you compare assimilating Argo data that's the green line, to not assimilating any data at all, there's a very strong difference, and there's a large improvement in the simulations, in the predictions of temperature and salinity variability. But that's at large scale for looking at features that are evolving pretty slowly. And then the other result that is interesting is that when you're assimilating data, satellite data, you get to something that is highly complementary with the better simulations, but at this time for features that are faster at intermediate spatial scales. So another application of Argo is to look at how much of the ocean is warming. We all know that the ocean is warming, something that is pretty understood. And this top left panel is illustrating it. It's showing from the blue to the red the temperature anomaly of the global ocean from the 2000 to 2020. What we didn't know so far is how much of this ocean warming is actually extending to the ocean bottom depth. But we, thanks to the deep Argo floats that are capable of measuring temperature and salinity from the sea surface to the ocean bottom depth that can reach to 4,000 to 6,000 meters, this is now feasible. And these results are showing temperature record from deep Argo data collected in regional pilot arrays that had a lot of data collected in. And that's for the case of the Brazil, Argentine, and Southwest Pacific Basin, and all agree that ocean warming does extend to the ocean bottom depth. The last case here is showing the impact of ocean warming of sea level. So there's two facts that contribute to sea level rise, either, and actually the contribution of both, the expansion of the ocean volume, and that's from ocean warming, or an ice melt. And what you can see here in the top left panel is a pretty nice closure of the observed sea level in black and the estimated sea level in purple up to 2015. But what's interesting is that starting in 2015, there was a misclosure of the sea level budget that has been observed. What are the causes for it? Well, the fast answer, the quick answer is that we don't know yet. A better answer is that different factors could contribute to it. There could be errors in satellite measurements, or there could be uncertainties in the way that we assess change in the ocean volume due to ocean warming. So a smart team from France looked at, okay, so let's assume for 1 second that the satellites are measuring sea level change correctly. And then let's estimate how much the deep ocean could contribute to increase of the ocean volume if we were to infer it from ocean satellites and Argo data sets in the upper 2,000 meters, and that's the blue line. And then the orange line is what's directly estimating from deep Argo data. And if you compare the blue and the orange line, you see a very nice consistency between the two lines. So this is only based on 2 deep Argo floats, so it's limited to a very small amount of data set, but this is very encouraging. And that tells us 2 things. First, that deep Argo is the technology that is capable of resolving deep ocean change in ocean temperature. And the second one is that if we were to increase deep ocean sampling, we would come to a better closure of the sea level budget. So I've talked about the value of Argo. Well, let's talk about plans for the future. So the expansions of one Argo are threefold. The first one, and I've talked about it, is to expand Argo profiles to the ocean bottom depth. The second one is to assess the productivity and the changes in the ecosystems, largely due to climate change, and that's by measuring biogeochemical variables from Argo floats. And the third is to expand Argo profiling to high latitudes in regions that are seasonally covered by ice, but also to double profiling in regions that are highly variable, including western boundary currents, equatorial regions, and marginal seas. So for that, we need 4,700 floats. 1,200 of them would be deep floats, 1,000 BGC floats, and 2,500 would be core floats that would only measure temperature and salinity in the upper 2,000 meters. So where are we at right now? Well, let's go back in time just a little bit. In 2019, the One Argo design was articulated at Oceanops, and it was approved by GCOS and GOOS. Between 2015 and 2022, there were implementation of regional pilot arrays, deep floats and BGC floats, to define the capabilities and the performances of the floats and the sensor. So when will One Argo be implemented? That is the big question. So to fully implement One Argo, it is required 120 million per year, and that's at the international level. Well, that can seem like a lot, but actually it's not. It's actually comparable to the cost of a single sensor on a satellite Earth observing. So it is actually quite reasonable when you think of it and you realize that it provides you with the means of monitoring the ocean from top to bottom in real time. And given the strong impact that One Argo could have on improving climate and weather forecasting, it is urgent that One Argo is implemented globally. So As I mentioned earlier at the beginning of my talk, I think it's useful to think of what made Argo successful. And the answer is actually quite simple. The Argo program is successful because it is international. Thinking for 1 second that Argo could be implemented just by one country is unrealistic. The Argo partnership plays a key role in the implementation and the sustainability of the global Deep Argo array, and it plays also a key role in the quality control of the data set. I talked about this earlier too, but I just have to insist on the fact that Argo's value is highly dependable on the unrestricted availability of the global Argo data set to the public, to the scientific community internationally. And then the third reason is that Argo is highly dependable on the strong connection between the academia and the industry. Academic scientists provide a fair assessment, unbiased assessment of how well the sensors and the floats are doing. They have the resources, the scientists that have the technological knowledge, but mostly the knowledge about ocean dynamics, ocean water masses, and can detect when the sensors are starting to misbehave. They also can provide supply for funding resources for Argo development and innovations. Those are resources that are not necessarily available to the industry. On the other hand, the industry covers the large-scale production of Argo floats and sensors, and also resolve the technological issues that are reported by the academic scientists. And then finally, a priority is for Argo to diversify the float and the sensor providers, because delays or interruptions in the production would have a very negative impact on the global array, because deployment opportunities are not necessarily, and most of the time, not available every year. So these are Argo's keys to success. I'm happy to take any questions.
Thank you, Nathalie. I'm going to hold questions until the end. We're planning on having the panel come up and do a joint Q&A session. So next up, Dr. Yi Chao.
Thank you for the opportunity to present here in the TMA event. And thanks, Natalie, for this really nice summary for the Argo program. So my transition from academic researcher to startup company is really motivated by the Argo, as I working for NASA Jet Propulsion Lab, launching satellites, and I have been seeing the evolution, accompanying evolution of Argo with altimetry satellites, measuring sea level from space. Argo take the third dimension and provide that missing piece of the subsea measurements. So I started my career as an ocean modeler at Jet Propulsion Lab, and then I worked 20 years and developed a particular technology, tried to enhance an Argo program, make them extend their lifetime, have more capability, carry more sensors, and then profile frequently to sample more synoptic evolution. So really transitioning my 20 years of research career as a scientist to a startup company, try to commercialize this technology, and motivated by this, the successful Argo program. Continue to get funding from NASA, ONR, NOAA, partner with industry, as a previous speaker talked about, take public-private partnership to make a successful transition. So I'll walk you through a couple of key points, and then where we are in terms of we're still early stage a company, try to bring this technology to commercial application. Hopefully we'll benefit Argo and beyond. So as I said, I started with an ocean modeler. I continue to, I spent more than a decade working with IUs and SCUs and SENCUs and then AUs as providing forecasting models. And I officially retired October last month. Turn off my model has been running for 30 years, and now now take over as operational system, working with the ROMS model. So that's kind of first chapter of my career as an ocean modeler. I spent 15 years to help launch the salinity satellite Aquarius. That's my kind of second highlight of my career. And I realized as study ocean from space, you can only catch the surface. And then wonderful Argo platform can really give us the full three-dimensional ocean information. As a modeler, I realized without data, a model is just a computer simulated numbers, right? So deeply realized the impact of the data, and Natalie showed a similar graph, so the evolution of robotic and ocean application, and then really showed the takeoff of the ocean data from Argo, from gliders, from AUVs. Now we see this dramatic increase, order magnitude increase over the last decade or two, and I can see that increase is going to continue to increase in the next decade, take another one order, maybe even two order magnitude increase of data in order to have the sufficient data to constrain the models, making an accurate prediction from climate to the synoptic weather time scales and the ecosystem in the ocean as well. And Natalie showed this very nice program of the Argo. If not among the successful program, in my mind is the most successful international partnership to bring this global observing system into bear. This is a summary of the challenges I started to get involved in this about 10 years ago, is how to extend the capacity of the profiling float as a good platforms. And then all these float are driven by batteries and with a limited storage. Once you launch the float as autonomous systems, and then you use the float to the energy to profiles, to collect sensor data, communicate with satellites. All of these every profile you make, you consume finite amount of energy, and then with a limited supply of the storage on board, and then basically have limited lifetime of the profile. So if you take the number of profiles of the percentage Argo over 10,000 float being deployed, and then majority of these profile about 300, 200, 300 range. And basically the right-hand side show you the green dots is the float reporting data today, and then the red dots are showing the end of life of the Argo, because it's just because the battery are running out of power. So that's really the challenge we try to address, is to ask the question, can we recharge this battery in the ocean, take advantage of the infinite amount of thermal energy associated with temperature difference? Over 3/4 of the global ocean have this thermocline, have a sufficient temperature gradient, is warm at the surface, cold at depth. Henry Stommel proposed this 30 years ago in the Oceanographic article, saying the gliders and the float, at that time, the Slocum should be powered by the renewable source of energy, so they can profile as frequent as you needed to monitor the weather. You can carry as many sensors as you want, and then process the data, and then send the information back to the command center to be assimilated into models. So CTRAC has been working with a number of those pioneers, and then taking Henry Stommel's idea, work with Ross Davis, Doug Webb, and then try to take advantage of these concept using phase-changing materials. When they go through these profiles, you basically melt this solid material, which is solid in cold water at depth. You melt this material, expand in volume, and that's create a hydraulic pressure. If you put in the contained volume in the right-hand side, and then you create this very high pressure hydraulic force, and then you can spin the motor, generate electricity, you can recharge the battery. So every time you profile, not only you're not depleting your battery, but you're generating net positive energy. You can accumulate and then store those energy, and you can carry more sensors and doing additional computing. So it's really an energy neutral platforms. And then we started this almost 10 years ago, collaboration with Ross Davis at Scripps. I take the moment to acknowledge the contribution of his team, develop the float, and help us using Solo platform to do our first demonstration. So Kyle here, and Ross engineer at that time, and help us to construct a prototype. And this is the first 3 Solo float Ross built. And then this one of us customized with the thermal engine or the thin tube around the floats. And this is funded by Office of Naval Research, Autonomous Systems. And then really demonstrated for the first time the hypothesis can be realized in the ocean. You can deploy the ocean to profile, generate more energy than you need, and then to carry out the mission. So C-Track kind of spin off after that demonstration as a startup company to commercialize this, go through the licensing with Caltech, and then start raising money, try to write SBR proposals funded by NOAA, by ONR, and try to mature this technology, make it ocean worthy. And then eventually we deploy about a dozen of these floats in this middle column configuration, work with Seabird, Navis float in the middle, and then we provide this commercial grade energy power harvesting system attached to the third party floats. And then we're in the process developing a fully integrated float with based on the feedback from Argo, from the float customers. And they really want to miniaturize them and then create a cost-effective platforms with unlimited energy to not only to carry CTD and the biogeochemical sensors, we are starting to integrate active acoustic echo sounders to map the bathymetry, work with Seabed 2030 to map the 80% gap of the global seafloor. And we just to kick off a project with Naval Postgraduate School to carry hydrophones. And now we have unlimited power is scalable. The more material we carry, the more energy we can produce. Now we can carry a Linux computer, try to process those acoustic data people can collect in the listening, and then try to distinguish the natural sound versus man-made sources. So a number of applications. We also talk about potential other sensors we can carry on this platform. We're looking forward to hearing your ideas and input. And I think the potential is unlimited. In addition to ocean mapping, there are potential to carry sensors to benefit a number of different blue economies, ranging from shipping to offshore operation to the wind farms, aquaculture moving offshore, carbon sequestration, and understand the ecosystem, the environmental impact of the operations at sea. So there's a number of different applications we have done so far. I'm looking for opportunities talking to you to learn about your ideas, what your unmet need. If the energy is not a limitation, what you can do with underwater platform like a profiling float. Thank you very much.
Thank you. And next up, Paul Devine, Product Line Sales and Applications Manager from Teledyne Marine. And I can't wait for the Q&A, just like you.
The one with Paul Devine, that one. Yeah. Thank you. Can't really see anything. Okay. Hey, thank you, Carl. And thank you, BlueTech, for the opportunity to speak. Thank you very much. I've been thought a while about how to actually to make this correlation between abstract science and powerful solutions. And my experience at Teledyne over the last 20 years, I really have seen a difference between the access to the raw data that's required for the academic versus the powerful solution where someone is really just looking for an answer. Give me the number. Is it green or red? And, my name's Paul Devine, and I'm a member at Teledyne. I don't have a pointer here, do I? It's okay. So we provide solutions to a number of major markets. Energy, aquaculture, oceanography, water resources, civil engineering, hydrography, navigation, defense. We have a bunch of different product delineations. I'm actually associated with the imaging, acoustic imaging, bathymetry, and for the bottom classification, water column classification, and then the instruments. Is Shannon here? We have a member of the vehicles group here who's responsible for the unmanned and autonomous systems. But the way Teledyne, and just as a point of reference, the way that as we have acquired companies over the time, we've been acquiring technology, we've also been developing technology. But we've separated ourselves internally into 3 different main businesses. The business on the left is for connectors, cables, which are very important. All instruments need them, all vehicles need them. I'm a member of the instruments group where we're selling sensors, sensor solutions. There's also a vehicles group that's put together a package. We put the Argo floats into the vehicles group because it's a sensor delivery package. So I'm going to talk a little bit about the products that are made in San Diego and the products that are made in North Falmouth. But Teledyne's got a bunch of offices all over the world. Teledyne Marine is based in Daytona Beach. Teledyne Corporate is in Thousand Oaks, right? So Teledyne's much more, Teledyne Marine is only a small portion of Teledyne as a whole. But I personally sit in San Diego. Teledyne RDI makes the DVLs, Doppler velocity logs, and acoustic Doppler current profilers. We're in Poway, which is the city in the country, about a half an hour from here. If anyone wants to come up and take a tour, if you're here on Friday and you want to, I can let you in the back door and take you through manufacturing. But the application, from the first transition from abstract science to a powerful solution is I picked this example of the Oleander project. Has anyone seen The Day After Tomorrow, that movie? Anyone? Right? So the Gulf Stream, the theory was the Gulf Stream was going to be diverted over to Spain and the North Atlantic was going to freeze and send the climate into crisis. Well, back in 1990, early 90s, Stony Brook, University of Rhode Island, and the Bermuda Container Line, funded by ONR and NOAA and NSF, put one of our Dopplers onto a container ship that was doing weekly transects back and forth to Bermuda and measured, this is satellite altimetry, or satellite ocean temperature, and on top of that, they have overlaid, those are velocity vectors. The length of the vector is the speed of the current, the direction is the direction the current's going, and you can see the warm, dark Gulf Stream, that's New York, New Jersey. Anyone from New York? No? Nobody? Jersey? Anyone? No way. You're from Jersey? Okay. All right, so Charlie Flagg and Tom Rosby, I don't know, they took this on and they have weekly measurements of Gulf Stream transport, how much water is going from the equator to the North Atlantic, how much heat, they're doing XBT casts along the way, how much heat is being transported from the south to the north. And they were trying to answer the question, is the Gulf Stream going to shut down? How is the climate changing, affecting the Gulf Stream transport? And that line over there, it looks like the trend line is downward, but they said that wasn't statistically significant. But they were able to take all this data where they had asked us for access to all of the raw data, and they got into the nitty-gritty of the performance of the ADSP, because this container ship's going 20 knots. It's like trying to measure the current it's like trying to measure the wind speed and direction with your head hanging out of the window. You measure the speed of the boat. You measure the speed of the car. So, we worked with URI and Stony Brook, and they got a good system running. But it was for academic purposes, and they really wanted access to all of the raw data. Then we get to a powerful solution. Not that understanding the Gulf Stream wasn't a powerful solution, but we took this same concept of the Doppler measuring depth, speed over ground, and current from near surface to near bottom. You can calculate how much water is flowing down a river. It's a transport measurement of river discharge. And we've taken the ADCPs, we've made them smaller, and we've worked with Teledyne Ocean Science to provide packages, floats, and boats to deliver these ADCPs and get them across the river. Now to autonomous systems, bottom right, so that you can do a survey without having to put a person on the water and endangering them during a full flood. And what they're really interested in is this one answer, right? They hit the green button, they get a discharge, they go on to this next site. They're not really interested in all of the raw data that produced the answer of how much water is flowing down the river. And I think that, for all of you BlueTech startup, you're going to transition. Has anyone read Crossing the Chasm? Anyone? You read? So initially, right, you need to provide the scientists and the wizards of the world with access to all of the raw data so that they can work with you and develop a solution. And then you hide all the knobs. You hide the majority of the knobs. And you give the broad community the ability to hit the green button and get the answer. And that's to take it from, we saw a slide earlier, vessel-mounted ADCP, or vessel-mounted surveys are going down as the autonomy increases. But as we go to more and more autonomous systems, we're going to need answers coming out of the instruments and the systems, not all the raw data, because telemetry systems are limited. Next example from abstract science, we mentioned Doug Webb. Doug Webb sold Webb to Teledyne in 2008. And this was a Lifetime Achievement Award, I believe, from Hui, as he was an engineer, an ocean engineer at Hui before he started Webb. He still comes into the office. I was lucky enough to meet him. But he worked initially with Russ Davis to develop, it was mentioned earlier, to develop the first floats. And we have sold, I'm not personally in the vehicles group, so I don't deal with this product on a day-to-day basis, but I understand that we've sold 10,000 Apex floats. And there's only been 10,500 used in the Argo float program. I think we've sold a lot of these to commercial firms. There are a lot of oil and gas contractors that deploy these for commercial applications, and the data doesn't go to the Argo database because they're commercial firms and they paid for it, and they don't want to, they're not data socialists like the rest of us. But 1,000 Slocum gliders as well, which was an offspring, an offshoot from the float program. But the big focus recently, as we saw, is the biogeochemical floats, and that's a lot of the development of the biogeochemical float was really funded internally by Teledyne. The money, the seed money that we got from the federal agencies and was small compared to the time and the effort it took to develop it internally. So, we appreciate. I guess Carl, or the speaker from the Navy, Al, mentioned that the commercial firms have really invested more than the federal funding, which I was shocked. RD Instruments' initial funding came from Office of Naval Research and NOAA. But this was recent developments at Teledyne RDI and at Teledyne Webb have all been internally really IR&D funded. So they're always asking the question, how many of these are you going to sell? I don't know, at least 10,000. So recently, the same group, the vehicles group, has put together this deep water AUV for surveying. It's the deep water AUV kind of came out of the deep tow, right? So if someone wanted to search for a downed aircraft or do a deep water survey for resources, previously it was a towed fish with a cabled connection to the surface. And people want to cut the cables. They want autonomy. They want to be able to let the vehicle go and have it survey while they come over here and do something else and then pick up the vehicle at the end of the day and change the battery. But more importantly, they want a solution, right? I want a bathymetric map. I don't care about individual pings from a multi-beam. What I want is how deep is the bottom, and if I put an environmental sensor on there, where did I see the spike in the fluorometer? So we've come to a full solution with the software solution as well. You download the data from the instrument, you get all the data with all the metadata, but then you also get a bathymetric chart at the end of the day. And I'm Paul Devine. There's my number if you want to call me. If anyone wants a tour of RDI, I'll pick you up and drive you up to Poway, the city in the country, on Friday. How'd I do on time?
Good.
Thank you.
Thanks. Next up, Leif Bildoy, Product Manager for Blue Insight Ocean Science from Kongsberg Maritime. Did I get your name close?
You did. Very good. This one. All right. My name is Leif Bildoy. I'm the product manager for Blue Insight, and we will do our little thing to get to the singularity. Maybe not today, but we'll provide some insights, I guess, over time. Most of you probably know Kongsberg. We are in 3 business areas: maritime, defense, digital, and one of the things is that we often find ourselves working across these areas, which makes it a very interesting place to be. So we operate from deep sea to outer space. And Kongsberg Maritime, we have 4 business areas here that kind of points straight back to the management of sustainable oceans. And myself and my colleagues here, we are in sensor robotics. So that's where we build the Hugiens and the EK80s and all the good sensors. We are about 7,000 people globally, and a whole number of countries. So, Blue Insight. Let's put these up. The new blue economy. End users, societies, we have some needs and some requirements related to ocean. And there needs to be a mechanism then, some services that will fulfill those and realize those needs. So how do you go about that? You start usually with observing technology, sensors, platforms, systems, navigation. Kongsberg Maritime is very known for operating in these, building world-class sensors and so on. But you need a little bit more. Around observations, we start talking about measurements, operations, deployments. I mean, you're probably doing a survey. You need some field services. And out of that comes data and data management. You need to think about how you handle the data, the types of data. You need to think about visualization, storage, etc., etc., and probably also sharing, because you're going to work in a community, maybe internally in your organization, and also probably with externals. So there's got to be some way of sharing. There's got to be some mechanisms around that, ensuring that all the security-related issues are covered. And in the end here, we end up with information delivery. We end up with predictions. We end up with analysis. We use machine learning, AI, not entirely to the level of the singularity, but we're getting there. And in the end, you get products, service deliveries that will help you then close these original needs and requirements that we had. And Blue Insight is complementing the very strong world-class sensors that we have from Kongsberg here. We are more in the information level, data and information, and managing data. So we're trying to figure out good ways of managing data, depending on what data you have. So if you just look a little bit on some trends in ocean observation, because it's kind of important. There are some drivers that drive us in what we're doing. So what we are saying is that there are more and more instruments, and customers typically need to operate a cluster of instruments, and together they will do the measurements, provide the measurements that they seek, and they do so with more and more vessels. So Armada is suddenly becoming a reality, concept of reality, and requires interoperability. And you need to start thinking about fleet management with more vessels. And they're often also smaller, USVs, AUVs, etc. Timeline becomes a issue. So we're moving from doing a sample, single sample in time, to more continuous mode of measurements. And those factors, well, they generate more data and higher volumes of data. And we need to think about how do we organize data, how do we collaborate, and how do we share. And one observation we see, of course, in Kongsberg, is a huge demands of AUVs, USVs, and in general, the expectation is that they're behaving and operating with a higher degree of autonomy. We're not fully autonomous yet. Mostly, you will see that there will be requirements around ROCs, remote operation centers, and so on. But it's definitely moving towards more autonomous vessels. And then time to market, it's important, and the requirements for time to market will basically challenge us on tech stacks. How do we build these information systems? Because we've got to be able to deliver fast, deliver value fast to the customers. So the one big challenge here is to make the right ocean data available to the right people at the right time. Maybe it sounds a bit convoluted, but there are certainly some points here worth mentioning. So when we talk about data, we could maybe divide it up in two types. The data you have, the existing data, and the data you don't have, the non-existent data that you're actually going to collect on a survey. Because managing those things are slightly different. And here we're trying to point out how do we collect real-time data and so on. There are some problems in doing so. It's very complicated setting up robust data paths from a sensor at the ocean. And collaboration, we know it's hard. We often find siloed data and many proprietary formats. The analysis of those data is manual, and that means it's time-consuming, requires specialist skills, and it's expensive also to put specialists out at sea in a research vessel. And now, as we said, there are more AUVs and USVs, and what you then find as a challenge is actually how do you remotely manage the sensor payload. And also you need to start thinking about the software on board those vessels. They might be running machine learning models, and how do you update those? That's all very complicated. So we set out, I think it was last year, we launched Blue Insight. So that's a platform to manage ocean data and offers key value to a number of stakeholders. You might initially think that all of these are quite different and would have very different needs, but there is actually a common set of needs that basically span these, whether it's aquaculture, and we certainly see a lot of that aquaculture interest up in Norway, fisheries and same, energy production, could be oil and gas, but it could also be offshore wind, more and more so. We work with government authorities and researchers as well. So it was pointed out here earlier that there sort of might be a little difference in how you use a product in this space if you're academia, researcher, or an industrial player, and you might want to do some research post-mission, but there could be also use cases where you're doing decision-making on the spot out in the ocean. So it's quite a span. So that leads to what are the jobs to be done in ocean observation, and how does Blue Insight try to support that? So you may want to collect some sensor data and transfer it securely to a cloud. You may want to integrate third-party data, and you want to effectively increase the understanding of the ocean space by then using third-party data. You may want to manage sensors and data flows, important as well, and to ensure efficient processes. You may want to analyze data in real time at the edge or post-mission in the cloud. It could be a mix of this or either or. We see different use cases around analysis. And further to that, you may want to predict relevant variables in an aquatic ecosystem, and you might be on the fly to guide business decisions. Most likely, you would want to visualize data and insights, and you might think about 2D or 3D, and you may also want to require customizable dashboards because we probably have all different needs. And you may want to contextualize the visualizations with application-specific content and mission-relevant references. And finally, you may want to share in blue here your blue data and insights, or simply distribute raw data under FAIR principles. So sometimes you have some of these areas, Blue Insight, or you have all of them, and Blue Insight try to accommodate as much as possible around that. So here's a little diagram about the system overview. And you can see in the bottom here, there's some different vessels, drakes, sounder, a research boat. You may have some Kongsberg Maritime sensors. There might be a third-party sensor. There might be a KM database, third-party database, depends how you're set up. And generally, you want to have a data acquisition layer as the first thing you think about. How do you collect the sensor data and make them ready to be pushed up into the cloud in a secure way? So then you got a cloud service. You may want to visualize some of that data. You may want to run some analysis and straight on share it. It could be simple as a forwarder, forwarding data to a third-party database. But you might also want then to run a remote control of the sensors. And I called out also here, one thing we see a lot is edge classification use cases. So we basically built an edge compute capability around Kubernetes and Docker containers, same as running in the cloud, which makes it very easy to push workloads where you need them. So if you need to do a compute job processing on the edge node, you can do that. You're closer to the raw data and higher quality data. So if you have bandwidth constraints, it might be very wise to classify data closer to the sensor. So then I'm going to show you some screenshots here of the environment of Blue Insight visualization here. We see some ice cap marked out. It might be interesting if you're operating a USV to know where there is ice. This is the oil field Ekofisk with some security zones. There is a AIS management bounding box rectangle there. You can choose which vessels you track. We can visualize underwater environmental measurements and biomass classification. So we see some ecograms as 3D curtains zooming in and applied with the classification. Believe it's plankton here in blue. And then short little video of the 3D rendering. You will see a sailboy. There's a lot of tracks you see in the ocean here. There are some boxes which represents the measurements that's taken. We get to go and see the Ekofisk oil installation, and I believe we jump over to high wind, see some wind turbines, etc., etc. So very powerful 3D rendering engine. I said earlier we work across the different business areas. This is actually a capability that is built by Kongsberg Digital that we're using in Kongsberg Maritime for Blue Insight. So that's very helpful for us. And then last slide. So a little bit about the benefits in Blue Insight. We improve the efficiency. We try to help in collaboration between colleagues and communities. And Blue Insight is an open ecosystem, no vendor lock-in. Parts of this is open source, other parts are not. But that's decisions we take when we build products, etc. So that's all. Thank you.
Sorry, speakers, could you come up to the panel, please? And I think, let me get the mics turned on. So, Nathalie has to leave within 15 minutes, so I have so many questions for the panelists. So we're talking about the research to operations chain of events, the taking technology and observations and moving them towards societal benefit. And we've heard 4 very interesting talks in various different points of the scale. I've got lots of questions myself, but I'm sure you do too. I guess please maybe come to the mic if you have a question, or raise your hand and we'll try to bring a mic to you, or I'll call on you and repeat the question. Does anybody have any to kick us off, or do you want me to get this going? Yeah. And maybe introduce yourself when you before you ask the question. Just tap it once on the bottom.
Got it. Okay, so I guess the question is to, so I described Argo's key to success, and the question was how to apply it to other observing system, or was it how is Argo planning to go about with the expansions? I'm not sure.
Yeah, how has the research been accomplished with so many different researchers working in many different countries to bring together a whole program, and how can we replicate that through the other technologies that would benefit from those international collaborations to all do something great together?
Requires a lot of work and patience. I guess is the short answer. So I think an important point is that it's just unrealistic to think for 1 second that you can implement a global observing system with just one nation. And I think the contributions of the different international partners has been implemented quite organically based on the fact that people tend to deploy floats close to home and when they have opportunities for deploying them. So, and it's not necessarily close to home, but it happens in most cases. And I guess there are some exceptions to it. So, for instance, for Scripps, we have strong ties with New Zealand. And so a lot of the Scripps floats deployed are from New Zealand ships, and for that reason are deployed in South Pacific and the Indian Ocean. So, so yeah, and I think in terms of research, I think that was another part of the question. So it's just a matter of just collaborating, you know, and then having the tools for maintaining an efficient and friendly communications between the different partners. And then for doing that, the Argo program has multiple and very regular meetings every year. We have the Argo steering meeting, we have the Argo data management meeting, we have Argo science workshop. So I would say that communication is key.
Natalie, can you say a little bit about the change management with that community? Because there's an agreement on a standard set of instruments and processes that's internationally agreed to. So how do you take advantage of what the companies may bring in terms of technology advancements that we heard from today, and all three types that we just heard from, with regard to that being a program that everyone's agreed to internationally?
Okay, so and I think I speak for all the industries that have the that are interacting with us. I think we're a friendly bunch, but we also have requirements that are very well defined. And there are, I think the requirements for the floats and the sensors are very well documented. And it's something that is, I think, very useful to have, to be very clear about the accuracy of and the performances that you need from the industries for the floats and the sensors. And during the meetings that I talked about, both the data management team meetings and the Argo steering team meetings, we make sure to have specific days that are attributed to collaborating and talking with the industry and making sure that we can communicate our requirements well and they are well understood. We also make sure that we maintain the communication for telling them about when floats or sensors are starting to not behave well. I think that I mentioned that at the talk. And so that's coming from academia to the industry. And then from the industry, I think we are very lucky to contribute with industrial partners that maintains transparency. They let us know, and they are, I think, quite honest about limitations of the floats and the sensors, and letting us know of ways that they could be improved. And I think projects like the NOPS, the partnerships projects for innovating and improving the sensors, and something that academia can help the industry with, to have those resources and those funds for doing it, is playing a key role in it.
Thank you. So I was going to ask Yi Chao a question, and then maybe also Paul and Leif, in terms of joining the activities of programs that exist and building capabilities to bring new technologies to bear. So sort of along the lines of that question for you, Yi, your years of experience on your slides, how is that going in terms of trying to build and bring in change to something that's already extant, already in existence? And for Paul and Leif, as a public good funder from NOAA who's trying to provide services for societal benefit and open data, how do we meld and blend with your companies to allow you to have competitive markets that you're trying to fill, but also open source data is something that has to be in the mix from my perspective. So how do we mix those together? Go ahead, Yi.
Yeah, I just want to summarize, and then I certainly is challenging. I think if you need one word reply, is that spend 20 years as a scientist now thinking about cash flows and then product market fit. Do you have the right team, and then how do you raise the next round and so forth? When I started, kind of very little help available in the community, but I think now we are really fortunate to have this event like this, TMA. We joined TMA 2019, shortly before the pandemic, and there's a CDL in Canada focused on the ocean. There's multiple incubators in Start Blue, in Scripps, in Mississippi, Boston. So now you have a lot of groups and then organizations helping people like me to transition. I wish those organizations have a strong presence 5 years ago when I started. So that's point number one. Point number two, there's a lot of resources available from both government and foundations. So we are very fortunate to get philanthropic support early on, both from Thiel Foundation and the Schmidt Foundation. SBR from NOAA, from ONR are instrumental to help us to pay the R&D costs, so we don't have to raise a lot of private capital to cover our operational R&D budget. And then you have to go out to raise money to do the commercial, because the government money cannot be used for the commercial activities. So a lot of multitasking, but it's really exciting. I think I can write 50 more papers before I retire, but I think I can make a bigger impact by serving in the middle to transition from academic to commercial applications.
And audience, please keep bringing questions if you want, but I asked the daisy chain one to keep the conversation going. So Paul, how do you make your private sector meet your profit motives within that realm, and what are the recipes for success for partnering with us in the public sector with open source data from the capabilities you're bringing to bear?
So in terms of the profitability, right? Is that
well, how do you meld the two for those? As I watched your talks, I was struggling with a constant challenge I face in this world as a public servant. We're trying to provide public services that are, in essence, equitable services across societal needs, and not just those who are able to pay. And so if a for-profit institution organization needs operational support for oceanographic data and information, and you can provide that to them and make profit, that's good. And I guess and we are funding with government resources some of your products and your capabilities to be in the mix with us, with partners who are deploying them and gathering data and making the data and information, as you mentioned, trying to get to that red or green button or go or no go. And some of those are profit-based opportunities for you, and some are non-profit.
Yeah, we are a commercial entity, and we do have stockholders, and who has a retirement fund, right? Who's a retirement account, right? So everyone wants the return on their investment. And it's a challenge when the oceanographic industry is very conservative and slow to change, where our initial products that we provided in the 80s are still working, and people don't want to change. They don't want the new product. So the return on investment for our R&D is always a lot longer than the stockholders are interested in waiting. So it's been a problem when you invest in a new product and you release it, and your old product continues to outsell it 3 years later, because NOAA doesn't want to change, right? Because the NAVO is happy with what they have. It ain't broke. So a lot of just getting back to data, then it was a two-tiered question. The goal is to always store all of the raw data to satisfy the academics and the wizards that are looking at the data. And the challenge is to provide meaningful summary output for transmission in real time to shore. So that's the challenge, is to provide meaningful answers in real time, because everyone wants it now. They don't want to wait for 6 months to download the data anymore. That's a big change in the last 20 years.
And I didn't mean to make a hot seat if I did, and thank you for that answer, but that's part of what I think through this is how do we innovate faster towards the solutions, and it's how to use the tried and true without breaking it, and then enable the new at the same time.
Yeah, and it's I was amazed at how conservative this industry is in terms of not wanting to adopt newer technology, because what you have already is almost good enough. You need someone like the funding agent to say, "Thou shalt produce data results in real time," to force people to deliver the data back to the beach and to force them to adopt the new technology. I'm not going to fund you unless you provide a better solution or a better answer.
Leif, do you want to weigh in or offer?
I see some of the same things as Paul talked about here, but I think in the end it depends. And because are you going to collect all the raw data, or are you just going to take the classified data, which is much simpler and push it up, less bandwidth? The answer will not be the same for everyone. And I think what we need to do then is to provide frameworks, tools that can cover a huge span of use cases for this. And so I'm thinking in terms of collaboration, to help in collaboration, tools like APIs. We know how to pick up a phone and call each other, but how do you make the systems connect? There are established paradigms for that around APIs. in Kongsberg, we think about APIs everywhere as a mantra. Everyone should do that. We see ourselves as helping with the tools for collecting and managing data. We do not gobble up the data as if it were a Kongsberg Google for the oceans. We believe that our customers decide who they share with, when and at what time and what type of data to share, because it's very important that all data is not equal. Some should probably not be shared.
Yeah.
It's not real time.
Right. So I had another question from the audience.
I think I'm also fine. I have a teacher's voice as well. A follow-up to the comment from the speaker from Teledyne. You said that some of your customers have reticence to produce data in real time. They don't want to invest. They don't want to do it. Can I ask why? Is it a concern about data integrity, cost, or something else?
I think the degree of difficulty goes up and the cost goes up if you want the information at your desk in real time. It's much more expensive, and the number of points for potential failure along the way increase.
I presume, though, that Teledyne provides an economic analysis along with this. The benefits of data are so great. I would think that they would often outweigh the cost or something like that, particularly real-time data.
Well, I mean, and a lot of times we're just providing a sensor that's part of a network. And we provide sensors only to groups that will deploy it in the ocean autonomously on batteries and then visit the site 18 months from now and download the data. And so I think it's about a 10x increase in cost to get the information back to your desk in real time, to get it to a satellite and back to the beach. You know, from the sensor through the data logger to the satellite and back, as opposed to just residing inside of the sensor.
I think there's another point to it, is that when you return data, you have to make sure that it's actually acceptable. And it's a lot more difficult to provide data in near real time that is quality control partially, that has an automated system to make sure that the data that you send and share with the community can be used and is valuable. When you have 6 to 12 months to have a look at it, you know, it's much easier. I'm not saying that it doesn't take a lot of time. It takes a humongous amount of time, and it takes resources, personnel. What I mentioned during my talk, people have knowledge about ocean dynamics, who have knowledge about water masses, you know, to make sure that the data is actually good. But in near real time, you have to have an automated system that does it very quickly to filter out what data should not be used and should not be shared.
Was it? Go ahead, Clarissa, and then maybe. Yeah.
First of all, I want to say 4 fantastic presentations, all well organized and very, very informative. I want to make my own ocean observation that in 1973, I was at University of Hawaii getting my first master's in an oceanographic study of the University National Oceanographic Fleet needs for 1990. And I predicted at that time that professors would be at their desk, have global communications to what was equivalent of an IBM 360 on board the ship, and there would be a tethered down manned vehicle, and there would be a pilot that would take readings and make observations and then send them back to the professor in real time. And I had another professor that said you could spend your entire career using today's technology to solve yesterday's problems. That was 50 years ago. Think about where you're going to be 50 years from now, and just remember that lesson. Look to the past and predict the future.
Clarissa, did you have a question?
Thank you, Carl. Hi, Clarissa Anderson, the Southern California Coastal Ocean Observing System. I I was just thinking about what you were just saying about how it costs 10 times more to do real time. If that's the case, I am not charging enough through the IU system. We do this on a daily basis. We do everything from real time to delayed mode at an incredibly low cost, end to end, to the cloud, to the products, to the visualization. So I just want to push back on this idea that this is so costly because we're doing it at just bottom of the barrel prices through IUs. And to the point about delayed mode, this is very important. We actually apply all of the flags in real time to our data they're going through. They're not perfect. We then put QC'd versions out in delayed mode. Sometimes it takes 6 months, sometimes a year. We have plenty of caveats on our websites explaining that there are going to be spurious results, say in chlorophyll, because of biofouling, et cetera. So I'm just not yet understanding the grand challenge here, because somehow we've managed through the government funding that we get, which is quite low compared to what you see in the private sector, to do this stuff and to do it at climate quality scales. So I don't know if I have a question. I'm just a little confused about this metric of 10 times more, because somehow that's not translating to the sensors we have at Piers, our glider work that we're doing fully through satellite telemetry, our radar work. We do not have that kind of a cost difference between all of these things. And I don't know, maybe you know my system. Maybe you can speak to this, because I think you have insights from both sides.
Yeah, I think some of this real-time. Hello? Yeah, some of the real-time transmission, because of the platform intrinsically is not in the upper ocean. Like glider and float, they can easily come to the surface, get the data through Iridium network. A lot of the, deep ocean platforms, they are anchored, they sit on the bottom, and they have no easy mechanism to transmit data, because the tripod cannot rise to the surface, and then it's done, right? So you have to sit there for 6 months or 12, 18 months, and then when the ship next cruise go there, retrieve the data. I think we need to look for new technology to reduce that 10x cost, and there are many ways to send bubbles in the messengers to the surface, data messengers. We talk about marine geologists at Scripps, using our, profiling float tethered to the, you can rise to the surface and then go give you every week, and then before you lost the instrument, you lost the data. So I think when you talk about 10x cost increase, it's time to look at new technology, new innovation to solve that problem.
And I'm going to pass it to Leif, and then I might go back to you, Clarissa, with the challenge question. For me, when we're talking about these things, I'm trying to identify what are the barriers to success for collaboration across to accelerate the solutions. And so maybe it's in what I think exists in uptake of new is the people time to come up with a level of QA/QC that's acceptable at first, to name it, call it with the caveats, and then move to a new version and identify that gap as a skill gap right now that you want to improve. And you can react to that after I hand it to you.
Yeah, so just a comment on this. I mean, on the bandwidth thing. Satellite communication is expensive and the coverage is poor. Now, it's not, we challenged here to think about what happens in 50 years' time. 20 years ago, I worked in Nokia Research Center and tried to implement real one player into the Symbian platform. That was painful. At the time, telecommunication operators would pick the 5 MTV videos you were allowed to see on your phone, and it barely worked. So we are making progress. It's evolution, and 20 years from now, I mean, we already see Starlink and things like that. There will be more of that, and that means costs will be coming down. You can transfer more data, etc. But it is a challenge today, for sure.
So we're about at time. Clarissa, did you want to make a final comment?
No, it's okay. We can have an offline chat.
Okay. So with that, one of the things TMA BlueTech does is give us long breaks. I've taken a little bit of ours because we started a little bit late. So I'd like to basically say, help me to give a big round of applause and thank you to our panelists. And we're going to a break, and I believe, Matt, do you want me to get us back on time and do 15 minutes, and we start back at 11? Yes, so 15-minute break, back here at 11. Thank you, everyone.
For you. All 11 came?
Yeah.
Cool. Did you get in the ocean?
I did. I got
Good.
it once.
I'm going to introduce myself, fellow Department of Commerce colleague.
Very good. Where's the music? Can you hear like music? Do we need to shut the door? Do you know how to do that? All right, everyone. Welcome back from the break. Our next panel will be to discuss the future of workforce development for the sustainable blue economy. I'd like to introduce our moderator for this panel, Dr. Cheryl Peach, Director, Scripps Educational Alliances here at Scripps Institution of Oceanography. As the Director of Scripps Educational Alliances, Dr. Peach is focused on supporting the integration of science and education at Scripps. Cheryl's primary role is to spearhead new initiatives in educational outreach, as well as incorporate aspects of Scripps research activities into high-quality educational programs locally, regionally, and nationally. Welcome, Dr. Cheryl Peach.
Good morning. Thank you all for joining us for what I think will be a very lively discussion about workforce development for a sustainable blue economy. It's really a pleasure to be here and to welcome our panel members who represent a broad cross-section of individuals and institutions who are doing this good work. I have to stop for a moment and just acknowledge the irony of talking about workforce development while the future ocean workforce is currently outside demonstrating for higher pay. So I just want to acknowledge that we do have that going on. But at the same time, I do want to take a few moments to actually talk about what is a very important endeavor here at Scripps, as you might imagine, and that is creating pathways into the blue workforce. We're well known for our research traineeships here, but there are a number of other things that I want to acknowledge, including many people, individuals, and teams who are contributing to workforce development at Scripps. And this spans everything from pre-college, STEM education and engagement, to successful careers. We now have a metaphor for this work that we're using, and that's a braided stream. So it's a little different from the pathways model, and it actually suits both the institution and the topic very well. There are multiple channels coming into that braided stream that individuals can navigate as they plot their course to a successful career as part of a growing blue economy. And then many exit points, not just traditional careers, but also an increasing array of careers within the blue economy that I think are well represented within this room. I want to start with acknowledging the Birch Aquarium at Scripps. That's the interpretive center for Scripps Institution of Oceanography, and they offer a wide array of programs, including things like single-day programs for school children, multi-day programs for summer camps, and then more recently a residential program, kind of a college introductory program that we just piloted for students that came here from a partner organization called Bridge Builders in LA. We also have a number of really interesting summer and academic year internship programs for undergraduates. I think the total is somewhere in the neighborhood of 5, and then if you include individual internships that our researchers and faculty members support, that's quite a bevy of undergraduate students that are supported in pursuing these pathways. One of these programs is new, another pilot. It's actually run by Dr. Margaret Leinen, and it's being funded by the Office of Naval Research. So it's quite interesting to hear the speaker this morning talking about ONR and how they're supporting the increased diversity of the workforce and trying to build that as one of their priorities. I think what they're feeling is what we're all feeling, is that we really need to tap into a much larger pool of students, especially perhaps from the Navy's perspective with advanced degrees, and that's exactly what that program intends to do. So just in brief, that program is a pilot, a small step where oceanographic research institutions, R1 institutions, partner with minority-serving institutions and naval labs, not just in education for students, not just bringing students for interns, but truly integrating and promoting research partnerships among the faculty and researchers, as well as student engagement. So that's something to keep your eye on, and really looking forward to that program advancing. And then, of course, we have a wide array of undergraduate majors and minors that are always increasing as the undergraduate population at UCSD increases, and a wonderful set of Masters of Advanced Studies programs that, again, are pathways into careers that are related to the blue economy and intersections with policy and other facets. So, without further delay, I'm truly delighted to welcome you and our panel and to examine the ecosystem of the blue economy and draw upon the expertise of our panel to engage in a discussion of strategies and opportunities to expand and support as well as diversify our blue tech workforce. And so I think this collective knowledge, the collective knowledge represented, well, shortly on the stage, but amongst our panel members is considerable. We're going to start with Linda Kurokawa. Linda is the Executive Director of Miracosta College's Community Education and Workforce Development. She's also the Director of the Technology Career Institute, the college's most successful program for providing accelerated certificate programs to train students in technical skills needed for high-demand industries in San Diego County. She's a winner of multiple awards, and she's brought her leadership and expertise to bear on San Diego's blue economy. She's an executive board member of the Maritime Alliance and has established the Technology Career Institute as a Maritime Center of Excellence initiative within the U.S. Department of Transportation Maritime Administration. This offers courses that prepare the next generation for blue technology jobs within the blue economy, and we're really fortunate to have Linda here to share her work and to have a discussion with you after we've heard from all of the panel members. So thank you, Linda.
Technology.
Okay, I'll turn it over to the experts.
There you are. You got it.
So, good morning. Good morning. So, let's go back to prehistoric times for a second and think about workforce development. The reason why it's so exciting and it's so mind-boggling and so important and critical is because without workforce development, we don't eat. We don't know how to survive as a tribe or a culture or even a family, because we have to divide our labor to get all the things done so we can eat and sleep and have safety and a place that's dry and warm. And that's why workforce development is a part of everything you all do. And it's thrilling to be part of that as an administrator at Miracosta College, because I'm breaking down all those walls and thinking about the future. And so today we're going to take a look at why the future thinking philosophies are so critical to where we're going in workforce development, which is an all-important thing to every single one of you in this room. And it's definitely important to those people out there with the bullhorns. Yeah. So I'm from Miracosta Community College up in North San Diego, and I opened up a training center for accelerated work skills training that gets people in and gets them trained and gets them jobs right away. Now, doesn't that sound like a great idea? Yeah, it's not even that novel of an idea, but it's not frequent. We don't find that kind of thing very often. And it's becoming more and more and more critical. So I want to talk about sustainable, industry-focused, accelerated work skills training and why that's so important to think about and to help acculturate a whole new generation of people to a new way of training us not our young people. I'm talking about lifelong learning, because that's what's changed. And there we go. So I have a wonderful college president. Her name is Dr. Sunny Cook. And she said, if we don't look further into the future, we're consistently going to be in crisis mode. We're always going to be one step behind responding to the world around us rather than being prepared for the future. Wow, what common sense, right? But how often do we actually structure our thinking and our meetings and what we do and our strategic planning around that concept? And she does, and I do, and we are rule breakers. And you know what they say? Well-behaved women rarely make history, right? So what's happened at Miracosta College, and I want to use us as an example, not as, hey, look to us, look all the great things we're doing, but as an example of how things are changing, where we're going, okay? So I stand up here representing change more than I am representing just Miracosta College. But Miracosta College president, board members, and administrators, faculty, staff, and students have recently taken part in a year-long expedition, several times a month, many hours every month, in doing a future thinking training. And it's meant to help us foresee long-term trends and also significant disruptors that are about to change the way we do things as a culture, as a society, globally, in fact. These are not trends. It's not what I'm wearing. And it's not, oh, I like this instead of that. This is a new kind of car, and it's cool. But it's a new kind of technology. It's a new way of thinking. It's a new way of financing, like when Bitcoin came around. That's a disruptor, things like that. And we have to assess the possible implications for our institutions and our companies and our industries. And students are going to be involved in that, and our neighboring communities, and in fact the whole world. So what does that mean? Well, it means that we all should and may want to explore the idea of having a future's intelligence about the way we move through our organizational structure, our culture, our planning. And future-related knowledge informs our decision-making and our strategies and our innovation. And it's easy to think about futures thinking or intelligence when we think about innovation. But is it easy to think about it when we're thinking about our budget? Or when we hire the right people? Or when we set up a curriculum for an English class? Those are kind of boring things. Sorry if you're involved in them. I really apologize. But, you know, those are everyday, got to do my budget, got to do my performance review, got to do my program review, got to do this, got to do that. How do we bring to bear futures intelligence and see the opportunities and the challenges involved in that? It provides us, though, with analytical knowledge about the changes, trends, larger trends I'm talking about, and their potential impacts. So one way to think about this is to look at the difference between waves and tides. Waves are what we see on the surface, and they come and they go, and you can see them, but they appear and then they disappear. But underneath the waves is the tide, and it's causing different kinds of disturbances which then affect the waves. And sometimes we don't even see the tide is changing. It reminds me of a little bit the recent hurricane in Florida, and they had some areas where they had tidal movements that brought the tide all the way out. That was a scary moment because they knew some way that water was going to come back. And it was going to be horrific. It was going to be life-changing for some of them. Think of it like that. What tide has gone out or has moved left or right and is going to come back with a new way of thinking, a new way of acting? So our work involves trying to understand the tides and the deeper forces underneath those waves. And believe it or not, we're doing that at the community college. And it's exciting because for education, that means signals that we see. These tides are signals. Like, where's digital technology taking us? Accelerated training. That's a thing. That's a thing right now. Huge. Industry is begging, I need somebody now. And I need them trained in these skills. And I don't even care what kind of degree they have in a lot of cases. So, skills over degrees. Students partnering with entrepreneurs. What does that look like? Where's that going? Public-private partnerships. How do we fund our educational system through public-private partnerships that we've never done before? That makes sense. That capitalizes on the money that's floating out there, putting diamonds in people's bathtubs instead of funding the next generation of knowledge and innovation and entrepreneurism. And also incorporating enterprise in our educational systems so that we are teaching students the very skills that they need to develop into CEOs and entrepreneurs. And so I call it growing up the community college, growing up our colleges. It's time that we grow up. Remember, community colleges used to be part of extension of high school. It's not that way anymore. So at MiraCosta, TCI, that's the Technology Career Institute, we are doing accelerated work skills programs, and because I get to lead the charge and I get to say what happens, it's nice to be queen, I get to decide that our sustainable ocean and waterways are the next critical thing that we must pay attention to. That's why you're all here today. It's really exciting. And so we are doing engineering technician, machining technology, unmanned systems, and aquaculture coming soon because we care about those things. And that's what we're accelerating into 1 semester of intensive training. 1 semester, 600, 700 hours of training. They go every day. And because of this chart, now just look at it for a second. Notice, we could think of more occupations and we could add to each one of these, but what has a really long list? Look at the educational requirements for that one. And if we don't have those, let's imagine we don't have those. What do all the people who have graduate degrees do for their technicians that support all the work that they're doing? Where do they find those people? So this is critical. And what's different about the way we educate them when we accelerate it? We treat them like they're in employment. There's a novel idea. Lots of communication with our instructor. Career readiness, job shadowing, tours, guest speakers, work experience programs, internships, apprenticeships. These are all part of, you can see how now industry and education are joining together. This is where it's always needed to be, and it used to be. And there was one magical event, when you think about systems, that pulled that apart. University for all mentality. That happened in the 1980s. So we need to get past that and get back to this. So in doing these kinds of accelerated work skills programs like we do at MiraCosta, we have 90 to 100% completion rates. You do not find that in credit programs. We have 90 to 94% 25% employment rates. They're down at 30 to 60% in credit programs. Students can expect to earn $20 to $38 coming out of a one-semester course, and that's just the start. And you can see the other figures there. So I wanted to share the exciting things that are happening at our community colleges. I'm excited that a colleague of mine, Ferris Kalar from Santa Monica College, is here because we're partnering on a grant for aquaculture. This is what we do. We connect, we innovate, and we think about the future. And so if you want to talk more about that with us, we're going to have lunch together, so you can join our table. And it's been a delight to be here with you today, and I hope that you'll look into and come and visit us at MiraCosta TCI. I'd love to give you a tour and show you how we make this all happen. Thank you.
I'm trying.
Which one's next? Who's next?
Paul. Looking for Paul or for Ira?
Paul.
We're looking for Paul. Paul? All right.
Thank you so much, Linda. That was quite provocative, and I look forward to the discussion around the topics that you raised. Our next speaker is Dr. Paul Brett. Paul is the acting vice president of the Fisheries and Marine Institute of Memorial University of Newfoundland. This is Canada's largest and most comprehensive post-secondary education, training, and research institute for the oceans industry. It's dedicated to advancing people, industry, and innovation. Paul not only leads the Institute's ocean research program, but has also facilitated growth and expansion of the Institute through new program development and delivery, including accreditation. He's also responsible for the Institute's establishment of the first Canada Research Chair in Ocean Mapping. Beyond his contributions to his home institution, Paul also lends his global industry experience as a board member of Oceans Advance, which is a Canadian ocean technology innovation organization dedicated to ocean leadership in the global blue economy, as well as the education-focused Ocean Learning Partnership in Newfoundland. He's a founding member and past chair of the Canadian Ocean Mapping Research and Education Network and a member of the National Council of Deans Apprenticeship, Trades and Technology, and a fellow of the Royal Canadian Geographical Society. And we're very grateful, Paul, for you bringing your expertise, experience, and passion for blue economy workforce development to the table, and we're looking forward to hearing from you.
Thanks so much, and I'm happy to be here in sunny Southern California, coming from cold Canada. But, fun fact, yesterday the temperature in my hometown was higher than that of sunny Southern California, so moderating force of the ocean. I was invited to come down and have a chat with you around workforce development, and something that's pretty passionate from my perspective, and have been involved with the Marine Institute for a lot of years, too many to talk about. My beard and haircut tells me a little bit about how long I've been around. We're an institute, and following on your talk, it gave me great pleasure to listen to your comments around the technician and technology and that workforce pathway, because it's really about what we've done as an institution. If you know a little bit about our geography, we're in Newfoundland and Labrador, Canada's easternmost province. It looks like it's in the far north, but if you look at a map, not the one we tend to look at North America, we're at a latitude of 47 degrees north, which is the same as that of Paris. And most of us who are geographers in the room believe that the boundary between Canada and the US is the 49th parallel. Well, that's true in Western Canada, but in Eastern Canada, we're far below that line. But even though that we're at 47 degrees north, we are a polar or subpolar climate, and we are an economy that's been built on and around the blue economy since the beginning. So the blue economy is not new to the institution. And if I know how to use this technology, I will not end my presentation, but go to the next slide. Hopefully, we'll see. I want to start with our mission, and this is the mission of the institution. And very few post-secondary institutions have in its mission a statement around economic development. I think it's fitting here from a blue economy perspective to think about economic development. So to foster economic development in strategic sectors of the Newfoundland and Labrador, substitute blue, I guess, economy, particularly the fishery and offshore, and these are two relevant, very relevant economies in Newfoundland and Labrador, and to enable Newfoundlanders and Labradorians to participate in these industries nationally and internationally. So if you think about this, it's been there since 1964. Fast forward 60 years, 1922, or 2022, and it's still very relevant today. So our goal is to provide pathways for people to reach into that blue economy. As an institution or as a campus of a larger comprehensive university, we had to struggle between that of a community college in the Canadian setting and a true university, providing higher order degrees, graduates, and PhDs. We joined Memorial as a campus in 1992, so 30 years ago this year. And in 2022, we convocated our first PhD deserving graduate. But we continue, and we have not lost focus on our technicians and our technologists and those who are entering that blue economy. They could be from a one-day course that breaks down a barrier to get into that blue economy in the fishing industry, or to a advanced degree. But all of our work is towards the mission of the institution: provide opportunities for Newfoundlanders and Labradorians, be it them, those of today or those of the future, into that economy. So from a program perspective, we are set up into 3 academic schools, or faculties, if you think about a traditional university. We have a School of Ocean Technology. I had to look at my slides because my glasses won't let me see the ones on the screen. A School of Fisheries and a School of Maritime Studies. So these schools, or academic silos, really set themselves up to create programming in each of their requisite fields. Fisheries and maritime studies, or marine transportation, was the key part to our organization for the first 60 years, understanding that the fishery is a key component of Newfoundland and Labrador's economy, and then maritime transportation, again, is a real testament to the type of people who love to work in and around the water. Back in 2008, through strategic initiatives of our government, they invested in us to create a School of Ocean Technology, something that I've been part of since the beginning and since moving on to new roles in the last couple of years. But technology as an enabler has been very important to attracting new people into the blue economy. We talked about diversity in the workforces that are allowing us to sustainably use our ocean resources. I worked in past years with companies around the world of ocean mapping. We all know the statistics: 23% of the globe, 23.4 I think is the most recent statistic, is mapped to modern day standards. So that means we have a lot of work to do. But how are we going to do that? We need some disruptors to allow us to get there. But we also need changes in the workforce and the habits of how we do those things. So if you think about traditional seagoing mapping individuals or hydrographers, it eliminated a huge proportion of our population from taking part in those careers. All right, you bring a challenge being a downturn in the economy, in the energy economy. You bring COVID on top of that. So what have we done? We actually now have people working from their dorm rooms, processing data that's being collected remotely. So those technology disruptors are here, and they're allowing new people to take part in this blue economy. So we want to keep that in consideration as we begin to develop new careers and new pathways. Another thing I'd like to talk briefly about is how do we attract students to blue economy careers. I see my friends from Blue Robotics here, and they're outside. Go visit them. So we've been involved in youth engagement activities as an institution for 2 reasons. One, it's the right thing to do to attract youth to our organizations and to the blue economy. And the other thing is for self-preservation. We need students to survive. And how do we attract students there? Well, you don't get them when they're 22. You get them when they're 12, and you get them when they're 10, and attract them to what careers might be in the blue economy. And when I was 10, I had no idea what an oceanographer was. I had no idea what a hydrographer was, or even a ship's captain, or a physical, a marine biologist. Maybe I knew marine biology because Flipper, I'll really date myself now, was a TV program probably from here in Southern California that told me marine biology was a real thing. But those things were few and far between, and TV was one of our motivators, I guess, or one of my abilities to gather information about what careers could be out there. But from a workforce development perspective, I think it's our collective responsibility to attract youth to careers that are new and they're exciting and they're not, oh, you might get seasick. That we need to dispel those myths of what it means to go to sea and be gone for 6 weeks. And even though we lived it, I know some of us with similar haircuts as mine have gone for 6 weeks when there was no communication. It's not like that today. Today you have probably better internet than you have at your hotel room on some of these ships. But we need to dispel the rumors of what it's like to work in the marine industry and get out there. Of interest to our connection to community and industry, all the sub-bullets on the Venn diagram are applied research and development centers within our institution. And I won't go into each one of them or we'll be here for the rest of the day, but we have centers for aquaculture and seafood development. We have this one in the top left, Seabed. It's the Center for Community-Based Education Delivery. And we're pretty proud of that in our institution because we're taking education to the community. And we're taking it through Canada's north. We talk about barriers to the blue economy. So in Canada's north, our Indigenous community face extreme food security problems. There's limited transportation infrastructure, there's limited developed fisheries, and how do we enable participants in that blue economy? So we create educational programming to remove some of those barriers. It could be pre-sea, they can be very short course programming, safety programming to allow people to take part in fisheries programs to create food security in those communities. But those are key barrier-breaking initiatives to allow people to get to the blue economy. So our institution is really based on three main pillars. Knowledge generation, that would be the top of the pyramid, as my predecessor would call it, or the top of your graph, Linda, where you said the high, the PhDs and the master programs. We have applied academics, and that would be our technicians and our technologists, and then we'd move down to our industrial solutions, and that's where we create solutions to industrial partnerships to help them solve problems, not only in technological problems, but also workforce problems. We have an aquaculture industry that's exploding in the Northeast, and we worked with one of our industry partners a few months ago, and they talked about the workforce needs in the coming decade. 3,000 to 5,000 workers in this small community that has less than 2,000 people in it now. And they're saying, where do we find the 3,000 to 5,000 people? Well, we're not going to find them in Newfoundland and Labrador, I'll guarantee you, but it will be part of our immigration program that will allow us to grow our communities and make our communities more sustainable. And we will attract people to work in those industries and train them to work in those industries. So our founding pieces of knowledge generation, applied academics, and solutions really built on people and technology. So how do we work with industry and technology to solve those problems? I'm going to leave 2 more slides. This one I don't know if it's going to, apparently it works. These lights, I'm not sure what they're supposed to mean, but it was supposed to be that relationship between industry, academia, and students and alumni. So really our future in workforce development is based on this thing working. It can't be the university for all, Linda, absolutely it can't be that. But it has to be that progression of the braided pathway, love that as well. I'm going to use all of these. I'm going to come see you in February when I come back to San Diego. Or you can come up to Newfoundland in February. Don't come in February. We'll come in July. But this relationship between the institute or the university, our industry partners, and our students and alumni, or future students and alumni, it's key. And I want to leave you with a comment about the obsolescence of universities. And universities will become obsolete. And I'll feed off Linda as well. It's almost like we planned it, and we talked about this yesterday, but we've never met. I've worked with students, many students in my career, and I look at how universities, how slow they are to react, how slow they are, we say they move at the speed of glaciers. And I'll use the reactive worlds of universities. So industry tells us, and they're telling us, we need people now, we need them trained in all these things now. And universities will go, yes, yes, and we will, and in 5 years adjust their curriculum. Universities, if we, and I can say it because I'm one, or part of one, if we don't become more reactive or more proactive in how we adopt new curriculum, then the industry will find us obsolete. They will say we'll train them ourselves. We'll design the training programs. Micro-credentialing now is taking the world by storm. I had a young man who I worked with in the MATE competition. He was a brilliant computer scientist. He could have taught the entire curriculum. Before he finished his degree, he said, I'm done. They're teaching me nothing here. I'm working internationally, doing very well. He's a brilliant programmer and will one day rule the world, I'm sure. But he left the university. It became obsolete to him because the university was very slow to react. So my parting message would be, let's embrace the technician, the technologist, the one-day class that community colleges or institutions like our own can create for industry and work with industry to create, to ensure that our workforce of the future actually does the best it can. And I'll end there. Thank you.
Thank you so much, Paul. I'm looking forward to the discussion, especially about the obsolescence of universities. That was, again, a provocative conversation to have around that topic, and looking forward to it. Our next speaker is Francis Lang, Program Officer for the Ocean Foundation. Francis is an ocean literacy specialist with 15 years of experience working to protect natural habitats and biodiversity in the U.S. and Mexico. She helped establish Ocean Connectors in 2007, a fiscal sponsorship project of the Ocean Foundation that uses migratory marine species to educate, inspire, and connect youth to the underserved Pacific coastal communities. As Executive Director of Ocean Connectors, Francis' responsibilities included, and this is quite an impressive list, program design, fundraising, staff and financial management, partner development, marketing, and operations. So pretty much a really wonderful job of doing everything that one needs for an organization, Francis. She became a program officer at the Ocean Foundation in 2022 and currently leads the Community Ocean Engagement Global Initiative focused on creating equitable access to marine education programs and careers throughout the world. So true international focus for that work. In addition, and you may see the booth outside of here, she's the project manager for Aqua Optimism, an online learning platform that promotes awareness, education, and hope about the resource that makes our planet special, water. So welcome, Francis. I also have to say she's a Scripps alumni of the master's degree in marine biodiversity and conservation here at Scripps. So thank you so much for being here, Francis.
Thank you so much, Cheryl, for that warm introduction. It's wonderful to be here with all of you today. My name is Frances Lang. I'm a program officer at the Ocean Foundation, and I'm based here in San Diego. And as Cheryl mentioned, did my master's degree right here at Scripps. And the Ocean Foundation has their headquarters in Washington, D.C., but our work really spans the entire globe. So we're working internationally all around the world. And I'll be sharing about the role of ocean education in the blue tech workforce and in the blue economy, and I think connecting some threads between the previous speakers. And, you know, of course, the planet that we live on, the ocean is just a critical part of all life on Earth, and, of course, critical to our economy as well. So there is a lot to share. I'll start with just giving a brief background on the work that we do at the Ocean Foundation. We've been in existence for 20 years, where we're celebrating our 20th anniversary this year, and we're dedicated to reversing the trend of destruction of ocean environments around the world. So we are truly a global organization. We have grantees, partners, and projects on all the world's continents, and a growing presence right here in San Diego, in fact. And we accomplish our mission primarily through fiscal sponsorship, program facilitation, grant making, and donor-advised funds. And the types of projects that we conduct include many things. We do coastal habitat restoration, scientific research, capacity building, youth education, ocean health monitoring, and much, much more. So it spans a lot within the field of ocean conservation. And these are the Ocean Foundation's 4 main program areas, which have been designed to strategically target the most pressing ocean issues of our time. And workforce development has always been a priority for the Ocean Foundation, because we know if we don't invest in the next generation of leaders, that ocean conservation can't truly succeed. So it's critical to be investing in these young people and to help them segue into viable, successful, rewarding careers. And just this year, we launched our newest initiative, the Community Ocean Engagement Global Initiative, which we're calling COGI for short. That's the initiative I'm managing at the Ocean Foundation, and it's dedicated to supporting the development of marine education, community leaders, and empowering students of all ages to translate ocean literacy into conservation action. And so this has always been an important part of our work, but this year we're really stepping up our game related to ocean literacy and workforce development, and just increasing our focus on education now and in the years to come. And we're very proud of all the partnerships we have at the Ocean Foundation. In particular, we're very proud of our partnership with TMA BlueTech. And one thing that the Ocean Foundation and TMA did together in 2021, we co-wrote a paper called the Blue Wave Paper. And this paper includes 7 key policy recommendations constituting a Blue Wave mission, where government action and federal investment can come together to support technological innovation to advance the blue economy. And the economic value of global ocean assets is around $24 trillion US, so just a huge, huge amount of value. And market opportunities from blue tech can contribute to workforce development and job creation. So these things, they go hand in hand. But people aren't necessarily aware of this, and this value is being threatened by human activities that deplete ocean resources and ultimately cost people jobs. So the blue economy aims to move away from destructive extraction-focused businesses towards sustainable ocean activities like blue carbon, ecotourism, and renewable energy. And so we have a display copy of the Blue Wave paper on our table right outside here at our exhibitor table. And also on our website, you can find the Blue Wave paper and a number of free resource pages on topics on a variety of things, including the blue economy. And those are all freely available, annotated bibliographies and academic articles that are available on our website, so you can learn more. Another active partnership we have with TMA BlueTech is Aqua Optimism. Aqua Optimism is an online learning platform that was created by TMA BlueTech and TMA Foundation in partnership with teachers from San Diego Unified School District. And the platform was designed to fill a gap in K through 12 public school curricula and to bring awareness to the incredible BlueTech career opportunities that exist locally in San Diego and all around the world. And so this platform, you know, it has a tremendous amount of power to bring awareness to the BlueTech sector. And I'm managing Aqua Optimism as part of my current portfolio at the Ocean Foundation. And what I love most about the platform is that it's really supportive of diverse student learning styles, and it's conducive to effective remote learning, which is critical in the times that we're living in. And so it's a project that I'm really enjoying being involved with. And teachers need these resources. Educators need tools that are inclusive, adaptable, and age appropriate to support their classroom lessons. And each unit within Aqua Optimism culminates with a call to action that activates student learning around a real world environmental issue related to ocean and freshwater stewardship. And BlueTech careers are especially relevant in places like San Diego, where we have a burgeoning BlueTech industry. There are over 4,000 maritime water and BlueTech businesses in San Diego County, and that accounts for 5% of total businesses in San Diego County and revenues of over $16 billion US. And that information was presented in the latest San Diego Maritime and BlueTech Economy Report. And of course, you're welcome to step outside and learn more about Aqua Optimism at our table right outside. So other aspects of our work at the Ocean Foundation include exploring how we can help create equitable access to marine education programs and careers. And in order to do this, we must understand the needs of that community. And so we want to know the needs, opportunities, and resources that support workforce development for educators, as well as the barriers that may hinder their career advancement in this field. So we started by conducting a community needs assessment of marine educators based in the Caribbean, which is where we're initially launching our COGI initiative. And the results were very informative for our work, but they also have really important implications for BlueTech education as well. So for one, we saw a really high degree of support for conference involvement. So events like this, which is something that TMA BlueTech understands clearly, and it was great to be able to extend an invitation to some of the early career professionals in our network to attend this conference today through an event sponsorship. So we're very happy to have some of those individuals here. We also learned that marine educators, they view minimal job opportunities as one of their greatest barriers into this field, along with financial hardship and lack of networking opportunities. And finally, educators are interested in free learning resources, training, and certification to help them advance. So all of this information was very compelling for us, and I'll actually share an even more surprising outcome in just a minute that was, I think, even more powerful. So the results of our assessment, as well as our global work working with coastal communities all around the world, have underscored the importance of community engagement as an essential path to workforce development. Our survey participants identified programs that are locally focused, culturally relevant, and community-led as essential to increasing diversity, equity, inclusion, and justice in this field. The community has to be a part of the planning process when carrying out programs like this. And we believe the community engagement process and exposure to BlueTech education needs to happen very, very young. So from the K through 12 grade levels or even in early childhood education, because that influence from a young age can lead to BlueTech careers as well as environmental decision making later in life. So it's just, again, very important to be starting young and engaging the community throughout that process. So this is something I've personally seen firsthand from almost 15 years working in the field of youth education during my previous role as executive director of Ocean Connectors, which is a local organization that uses migratory marine species to educate, inspire, and connect youth. It was a wonderful job that I enjoyed for a very, very long time. And there are almost too many fond memories to recount, but some of the highlights that I've got up on the screen here during field trips with these students. I remember with Brianna, we took her class to the Living Coast Discovery Center on the shores of Chula Vista around San Diego Bay. And she is an artist. And so she spent the day drawing the animals, observing the wildlife, and just documenting everything she saw in her journal, drawing everything. She's a young artist, and it was powerful to watch her participate in a way that resonated with her. And Yvette, I remember when we took her class whale watching, and she stepped off the boat and told me it was the best day of her life. And I'll never forget that. I mean, it was the most rewarding moment of my life. So it was very, very powerful to hear that from this young person. And, you know, oftentimes there's other challenges going on in their lives. So if you can take someone out of that for a moment and provide these experiences in nature and around BlueTech, it can shape their future. And Andrew, I remember during our 6th grade field trips to the San Diego Bay National Wildlife Refuge conducting habitat restoration, I remember his fascination with the bugs. And he was, you know, looking at the bees and picking up beetles and hung out with this snail for quite a while. And it was just, he loved the bugs. And it was just so great to see the different ways they connected with the environment. But what these stories all have in common is they illustrate the impactful nature of experiential education and community engagement for all ages. And that's something Aqua Optimism supports as well. And the current director of Ocean Connectors is, I think she's here today, and I'm sure she'd be happy to share more about what they're up to at Ocean Connectors. So I'd like to return to the findings of our community needs assessment. You'll see a short video here summarizing the results. In addition to what I shared previously, we saw huge support for mentorship. It was impressive to see that 92% of participants feel mentorship can help with career advancement, networking, building community, and pretty much everything else. So I found this somewhat surprising because the idea of mentorship can perhaps seem kind of like an antiquated, like old school concept when we're living in this digital world that we find ourselves in. But it's very important to workforce development. And I personally had several mentors early on in my career who shaped my life and helped me along on my career journey. So I'd like to invite the BlueTech Week attendees to try to find these opportunities within your businesses. Perhaps try to reach out and create these mentor opportunities within the structure of the work that you're doing because we know that it's impactful. And we're creating our own mentorship program for marine educators through Koji. And I'd be happy to chat with anyone about how we're constructing our mentorship program. And by the way, this photo was taken by a very good friend of mine, just a couple of miles from here for any visitors to San Diego. The harbor seals have their pupping season each spring. And so this photo was taken at La Jolla Cove, and just really incredible wildlife we have here in San Diego. And here, another beautiful wildlife photo of another amazing species in San Diego, the Eastern Pacific green sea turtle, which for me kind of like started it all for me in education. So I guess to summarize, my main recommendations for building the future of workforce for the blue economy are to really listen to the needs of the local communities that stand to be impacted, and really to do whatever it takes to understand the barriers and opportunities that exist for local community members that are working alongside you. And two, to provide experiential opportunities for young people to really get a taste of what it's like to work in this field, and starting from a very young age. You know, they can be taking this all in much younger than I think we previously realized. And think about how you can be a mentor for others, formally or informally, because we know those experiences are powerful, they're valuable, and they change lives. So please think about how you can reach out and provide a mentorship experience for someone in your life. And please feel free to reach out to me via email if we don't have a chance to connect in person this week at the conference. And thank you so much.
Thank you, Francis. Before you sit down, I'm going to invite our panel members to please join us at the front of the room. And we're going to open the floor to questions for our panel members. You heard 3 different but still related perspectives on building the blue economy workforce. And I hope that you, as participants in the blue economy, have questions for them and can ask perhaps some challenging questions about what we need to do as a community focused on the ocean, on ocean education, and on ocean careers to perhaps approach some of those disruptive strategies that we've heard referenced here today.
I can start.
Please.
Wow. Have it? Hello? I'll just speak like this. Can everybody hear me? Yes. Lovely. Is Michael Jones here? No, it's in here. Okay, good. I'm going to give him some crap for this effort. He didn't attend my event, right? I think the reason why I asked is because I want to give him a fact straight on this one. He said, and I'll preface this first, we are so excited at TMA BlueTech about the potential of the workforce development, especially for underserved communities. I mean, we have underserved communities here in San Diego, mostly coming from Hispanic backgrounds. And I was going to ask Michael the question, because I've heard him say this before, is that there's a significant portion of Latino, Latinx, I mean, however you want to say it, we know what they're talking about, who have never even been to the ocean, even though they live maybe just a couple miles inland. Like, they've never been to the ocean, and they're just a couple miles inland, which is really quite fascinating to know about. And so how do you develop an appreciation for, the sea if you haven't even been to it before? And so he says when kids actually come, and they don't want to, like, for an ocean cleanup type of an event, they don't want to clean up the ocean, they just want to put their feet in the sand, right, and just enjoy it as kids. So, as I'm hearing you guys talk, and Cheryl, just great job moderating that, just really appreciate the energy. Thank you so much.
Thank you for asking me.
So as I'm sitting here thinking, and we're involved in this somehow, I'm curious, like the value chain, right? Because you're K through 12, and Linda has got the college aspect of it, and I know that Sandy Naranjo, she's one of the commissioners at the port. She's very passionate about this because she comes from Chula Vista. It's a little bit south of San Diego. So I'm curious about the value chain that we can build, right? And how to integrate this in our overall strategy, and not just to be able to say, like, I've been curious, how we're actually going to do this. We talk about it, and individually we're doing something about it, but what is the overall value proposition that we can deliver? What kind of an overall solution just for this area can we create? So this is just an open-ended question, an idea generation thing that I thought maybe even the audience could participate in if necessary. Thank you.
I'm happy to take a stab at that.
Top to bottom.
Top to bottom. Is it working? Okay, great. So I think that from my perspective and what I've seen is one of the first barriers to making underrepresented and underserved individuals welcome in the outdoors is making them feel safe. Because for many of these communities, there are perceived dangers to being near the ocean, and you have to overcome first making them feel that they're in a safe space and that it's culturally relevant for them. I mean, sometimes the messaging is all in English, and that's not their first language, and so there are huge issues with diverse communities being excluded from outdoor recreation and outdoor careers because it's not welcoming for them. And in fact, when we were taking students whale watching, you had to first confirm that they were safe and that it was okay and that we were going to take care of them on these boats. And so I found that to be just kind of like step one, at least for the younger audiences, is that you have to make them feel like these spaces and these careers are there for them and that you're going to meet them kind of where they are with their exposure to that, because sometimes they've never done it before. And their first reaction is, are there snakes? Are there piranhas? Like they're scared. Yeah, so that's something I experienced.
There is one other aspect that comes to mind, and I see it all the time. We have this notion that once we kickstart a new instructor for K through 12, that they somehow know about all the occupations and all the various fields. And the second most influential person in a child's life is going to be, besides their mom and dad, is going to be their instructors. If the instructors don't know anything but a marine biologist, because everybody knows a marine biologist, then we have done a terrible job of relating to any diverse group, no matter where they come from or what communities they come from, about the multitude of exciting jobs there are in blue technology and in the ocean economy and waterways. And so we at the university level can also do a better job of reaching out to our partners in the K-12 system to offer seminars and summer workshops and help educate instructors who have to do units every year to keep up with the times. Why don't some of those units be around blue tech and about the jobs that are available and help them inform the children? And this is why I like aqua optimism. It needs to be a global, I was going to say nationwide, but come on, let's think big. A global initiative to teach younger children and help teach the teachers who teach the younger children even better. So.
I'm going to give a bit of a global perspective, just being a little bit further north, but one thing that you hit on, and that's the mentor. And we work a lot to try to equip mentors, to equip our youth to take part in the blue economy or blue tech. But quite often those mentors are pulled 27 ways to do all the extracurricular pieces. And a lot of our work, I believe, will need to happen above the mentorship level at the administrative level to ensure that the supports are there for those mentors, to ensure that they have the right motivators to get to some of these students. Thinking about the underrepresented in our neck of the woods in Canada, and quite often their only opportunity is at school. So there's no after-school programming. So we want to ensure that we reach the educators to help provide as much we can things to break down the barriers. I'll leave with you one comment. We work with a group that does some work in Canada's North, and I'll use Canada's North quite a bit, but where they were looking at underrepresented youth entering a blue tech type industry, and their only requirement for the individual to come to work was a pair of steel toe boots, a pair of safety shoes to work in their fabrication plant. And right away it eliminated the young man from going to work there because he could not get those steel toe shoes, and he lived in a remote community and it could be weeks to get those steel toe shoes. So first blush was, oh, there was no barrier, but there was a huge barrier to allow somebody to get there. So starting to think differently about what barriers might exist. They may not seem like barriers to us, but they are there.
Yeah. I completely agree with looking at the barriers that are faced, and in some of the communities where we work, they don't have computers and they don't have internet, and so that's, I think, in the United States and other developed nations, that's just our starting point, is just to do everything through the computer. And I've worked in schools where there was not a computer, there was not a projector, there was no internet. So just imagine all of those barriers and how we have to meet them there.
Yes, a question in the back. Yes.
Yes, I just wanted to share, I have a model that I think that if other communities pick up this type of model, then we can diversify the work staff in the blue industry. So I got a state grant, luckily, and proposed a diving program in my part of town. Thank you. So I proposed a diving program in the Watts community, which is in the 15th District, 2nd County District. And the diving program, when I did it, I proposed the suits because we can't expect to teach the kids in underserviced communities without realistic tools. And I made sure to include all those tools. So I'll train them in the Watts community and get them jobs in the Port of Los Angeles. That's people working together to diversify. And so I just want to share our model with you, and maybe next year I'll let you know how it worked out.
Yeah, would love to hear about that. Thank you.
I'm with the Entrepreneur Educational Center in Los Angeles.
Excellent, thank you. I'm sure you have a lot of good advice for us beyond the DIVE program. I'm looking forward to talking to you at the break. I think this brings up another question. I'm so sorry. Which is, I think we brought up mentoring, which is near and dear to my heart, and I think is an essential part of success for any individual, and that we should all be mindful of not just being a mentor, but being a good mentor. I mean, you know, there are mentors that do an excellent job and others that sometimes fall a little short. But I want to get to this issue of networking and entrepreneurs interacting with students, which Linda brought up. And I think that this ability to connect with professionals, with people who could potentially help people along academic and career pathways is so essential. So I want to just quickly ask the panel for their input on their experience with how networking can impact success in students that are seeking pathways within the blue economy.
Well, I'll take it. It's absolutely everything. It's absolutely everything. Because you will have a few students who are go-getters, and come hell or high water, they will get the job of their dreams, whether they're a technical or they continue on and get the bachelor's, the master's, and the doctorate. They will go after it. But by and large, you have a much larger population that needs that networking and that needs that integration. So we do it through a lot of ways. We do it through speakers. We do it through internships. Mandatory internships, like the German model, where they go to class and then they go off to the workplace when they get enough skills to be of help. This is huge, and so that's another connectivity. And then we do it through inviting our business partners to participate as mentors to our students. And so there's a connectedness there, and especially entrepreneurs who are starting businesses, to have the students help them with projects or do back burner projects and make that part of their applied instruction. So all of those are so key, because it takes up the other 50% who are shy, who are afraid, who have never been successful, and it propels them at warp speed. And I love that.
Thank you.
Thank you. Yeah, I really appreciate that perspective. And I would just add that I remember needing help networking. And I didn't know how to show up at an event like this and confidently go up and introduce myself and speak about the work that we do. And so I had a wonderful mentor who taught me how to conduct myself at these events. And it's still lessons I use today, you know, and it was just, you know, how do you go in and walk up and introduce yourself? And it probably seems easy to all of us now, but it wasn't always. And I think that's another way we can support one another, you know, bring a young person with you to an event like this and be with them and bring them up and introduce them and show them how they can have talking points ready to speak confidently on the work that they're doing. Because that, I really needed that help in the beginning and still maybe do.
I'm just going to follow on the same theme, and, you know, reducing the barriers and hurdles to get youth at events like this or trade shows. When you're hosting one in your community, $0 for students to register. Just use that as a key, because institutions, they can find money, sure, to get people there, but it takes somebody a significant amount of work to get that money to get them there. But if it's easy, if institutions or events are saying free for students, or even have them volunteering, because they bring so much life to the events. We've held a number of events in our backyard, and I always advocate to have students there as volunteers and free to the events, and they bring new life. They bring new life and new perspective and a sense of excitement to the show. And your points on having them prepared. So we have experiential learning built into our programs at the Institute, where it's mandatory. You must have a work term to graduate. So they work with professionals in the institution to prepare them to network, to prepare them to search for that job, to prepare them to go to the job, and if the job is not going well, how to work and how to react in that environment. But it brings, I've heard many times anecdotally about the student that leaves after semester 4 for their experiential learning piece and returns for semester 5. They're different individuals. They're different because they've grown, and they've worked in industry. And providing those opportunities is so important to the future workforce. So if there's any companies out there that hire interns or bring them for free, if you do that, do them earlier. Do them at first year, do them in high school, because what's going to happen, and we're seeing it happening in industries in Canada now, is that our students are getting to graduation and there's 5 companies who want to hire them. Now, if you've been interning with a company for 3 years or 4 years, they're going to choose you. So take that as a piece of advice from an old university administrator. Attach to students early, intern them, pay them for their internships.
Yes, thank you.
Pay them for their internships. Too often I've seen in our federal government organizations where it was too much trouble to fill out the application for the money. And then 3 years later, they can't get any students and they wonder why. Well, if you paid them 3 years ago, you would have got them. So pay your internship, attach early, even when they don't know how to do anything. They will learn how to do things. So.
And I want to say one thing about internships. We have a grant from our assemblywoman to do paid internships from TCI, and it has been a bear. Okay, so we go to a company and say, we will pay you to have free help, and it doesn't fly. We are not accultured to have the apprenticeship internship model here in at least San Diego. I can't speak to the rest of the country. I can only speak to San Diego. And it has been one person's full-time job to talk companies into taking our students. And they don't have the time, the patience, and the culture for that. They don't have the broad-based onboarding processes in place. They don't know how to take a student and know kind of what to do with them at a basic skill level. They'll take them when we've finish, and then maybe. So this is a tough nut to crack. And if you own a business or if you have an organization, think about how you could acculturate your organization. What is your model for training? Because tell you what, this is the next developmental stage for the United States, is to do work and learn and work and learn and work and learn and work and learn, and we never stop. So get on board.
I think that's an excellent note to end on. Linda, thank you. I hope you will all take this discussion to heart. I think there's a lot more work to be done, and together we are much better at doing that as collaborators. So I hope these discussions continue during lunch, and thank you very much for being here and attending this session, and thank you so much to our panel members for excellent presentations and discussion. Thank you.
Thank you. All right, folks, as your master of ceremonies, I'm going to give you back 7 minutes that I was supposed to speak after lunch. So, seriously, we were supposed to... quite make 1:08, so I have 0 minutes for this presentation. Raise your hand if you've not heard an integrated ocean observing system talk before. Okay, there's one hand, there's another shy hand or two. Okay. I've been out for this week and last week in-person meetings, back-to-back travel. I had a chance to be with all of the Integrated Ocean Observing System office directors from across the country last week, and it was really good. I'm throwing talking points out the window every time I speak now. I'm getting positive feedback for that, so I'm doing that again. My objective is to tell you a little bit about me and what I'm up to with respect to the new blue economy and ocean observing technologies. And my objective was to do that within the context of BlueTech Week. So I'm going to do that in about 5 minutes and give you a quick flyby and not cover everything in detail in my slides. I'll click through them quickly. In NOAA, one of the top 3 priorities of the head of the agency right now, Dr. Spinrad, is the new blue economy. And what we mean by that is ocean and data and information that help people make decisions. From those decisions come economic benefits. Some of them are non-market value, some of them are market value. So we want it to be a sustainable and equitable coastal economy that optimizes and advances S&T to create value-added data-driven economic opportunities to pressing societal needs. So all sorts of needs. And the ocean data and information that I was just describing that leads to decisions leads to economic benefits that are often separate and bigger and broader than the oceans themselves. So the farmer in Iowa making a decision on planting or not planting based on a 2-week or month precipitation prediction, getting that data from what you heard earlier this morning from the Global Ocean Observing System data set that's helping to produce those long-range forecasts. So everything from public health to marine commerce to offshore wind energy to fishing, sea level rise risks, and safety from storms and things like that. Within the United States, we have a program within NOAA that is yours, taxpayers, that is said to, we're supposed to dedicate our work to integrating all ocean coastal Great Lake data from the head of tide to the EEZ, take that data and transform it into information for societal benefit. And we do that by observing, we integrate that data and create products and services. We communicate those products and services and information products for decisions to others. We've got 11 non-federal regional partners within the US that do this. Clarissa Anderson, Dr. Clarissa Anderson is here as the executive director for the Southern Coastal Ocean Observing System, Southern California Coastal Ocean Observing System. We have many acronyms within this network. The acronyms are all on the slide, but it's a regional approach because the ocean and coastal issues are different in each region. The types of harmful algal blooms you have, the types of fisheries issues, the boundary currents, the surface currents, and the shorelines are all different. So having a regional approach that bring in local, regional, state, county, other agency data in from that geography and nested into a national system is what we all do. This is 11 collaboratoriums with scientists and technologists working together to meet needs. Each of the regions pulls in and understands the stakeholder needs from their region. We meet with the national office within NOAA. We meet with the regions at least twice a year to try to understand the requirements across the system and work with all the other programs in the federal family who do this type of work. So if you want to work with IUS and you talk to me in the hallway today, I might say, do you know Regional Director X or Regional Director Y? Because the folks on the ground doing the work that my office funds are mostly in one of the IUS regions. Then there's other offices across NOAA and Army Corps and USGS and other federal agencies, and I try to work with those programs to integrate their activities with ours. Some of the technologies that we deal with include underwater gliders, high-frequency radar. We have a marine biodiversity observation network. We have a tagging network where animals are carrying tags that tell us about their life cycle, but also sometimes give us oceanographic data as well, often in places where we don't have other sensors. We've got a couple of programs at the bottom right that are research and development on the applied side. So we have ocean technology transition projects that we fund. We've got coastal ocean modeling testbed projects where we're trying to advance modeling capabilities and improve operational capability with those models. And we also work on harmful algal blooms and, as I mentioned earlier, data management. So a whole suite of things, that whole value chain that you heard about earlier today on some of your slides. And the broad array of mission areas makes it complex. The broad array of programs makes it complex. And it's a labor of love in terms of the amount of resources we've been able to apply to this. And you heard that from Clarissa earlier today in terms of the amount of funding that we're able to dedicate it. But we've learned that understanding the needs of the stakeholders, delivering oceanographic data and information for decisions, that value chain is true. And also, it's a commitment. Once you have that data and services in place, you've got to be attentive to the fact that you can't just move things around. You've got stakeholders that rely on it. And so we've got to be careful about how we apply the resources we have, make sure we're meeting the most needs as we can. And then on that workforce development talk that we just had, I didn't get to speak up there. I've got 3 years of experiential education in my background where I taught kids in the marshes of the Chesapeake, and the mission was behavior change. And I got to take kids who had never been on the water before and have that aha moment. And I really liked that session, and the things we need to do that you heard about there are absolutely true for the new blue economy and the blue economy overall. So that's a final plug for me on that. And so with that, I'm going to stop my presentation and not let you ask me any questions, because I'm going to use MC prerogative on that, and switch over to our featured speaker. I think I have that title correct, giving people the wrong titles at different times today. And so my note says, thank the audience for their applause. Our featured speaker for the afternoon is Dr. Amanda Netburn, Deputy Division Chief for Science and Technology at NOAA's Office of Ocean Exploration and Research. She just completed a 2-year assignment as the Assistant Director for Ocean Science and Technology at the White House Office of Science and Technology Policy. Dr. Netburn is a Scripps alumna, and she received her PhD in oceanography and a master's in marine conservation and biodiversity from Scripps Institution of Oceanography. So without further ado, welcome Amanda. Yeah, you're going to drive that.
That's the, okay. All right. All right. Well, thank you so much for the introduction, Carl, and thank you so much to the organizers and to everyone for being here today. The last time I stood at this podium and gave a talk was at my dissertation defense, so it's exciting to be back with hopefully lower stakes than that was. So the talk I'm going to give today is it's kind of a two-part talk. I'm going to start with a bit of a tour of the ocean through the lens of ocean exploration, a little bit of a pick-me-up after lunch, and then I'm going to transition into some of the policy direction that is currently underway, which relates both to ocean exploration but also kind of bigger picture ocean science and technology. So I always like to start my talks off with this image. And, you know, I know that with this group, I don't need to convince you all that the ocean is important, but I always find looking at this is just such a good reminder that the Earth is an ocean planet. You know, when we think about the connection between people and the ocean, we're often thinking about the coastlines because, you know, of course, that's where we physically meet the ocean. And they are very important. But, you know, as you can see here, most of the ocean, most of the globe is open ocean, deep ocean. And, you know, that is similarly very important for the services that they provide, like food, shipping, recreation, a heat and carbon sink, and home to most of the world's biodiversity.
So this is usually the part of the talk where I kind of go through all the features of the ocean. You know, the ocean is deep, the ocean is cold, da da da. I think this group is pretty familiar with that. So, you know, the piece that I will emphasize is that the deep sea is a place of extremes. So it is very cold, except we have things like hydrothermal vents that are 400 degrees Celsius. You know, it's a harsh environment, and yet most of the world's biodiversity is found there. So it's kind of this area of contrast and extremes, and understanding that is really critical to being able to soundly manage the ocean, soundly manage our planet for sustainability. All right, so, you know, one of the most basic things we need to study the ocean and explore any place, including the ocean, is a map. They facilitate not only safe navigation, but can reveal features and processes that are fundamental to our planet. The images on this slide show the evolution of maps of the Mid-Atlantic Ridge from the early 1900s to now, from, you know, literally dropping a rope off the side of the boat to the evolution of single beam echo sounders and now multi-beam echo sounders. As this technology has evolved, so has our understanding of the way the world works, right? So we've discovered the Mid-Atlantic Ridge and seafloor spreading, critical key to developing and substantiating the theory of plate tectonics. You know, similar evolution of technologies is and will be essential to further exploration of the seafloor and water column, and to addressing the dual crises of climate change and biodiversity loss in the ocean. Incredibly, we now have the ability to map the ocean floor from space. This is work that's taken place here at Scripps, and this image shows satellite-derived bathymetry with resolution on the order of about 5 to 10 kilometers. So really helpful for getting, you know, a big picture perspective of the seafloor, but, you know, probably not as helpful for things like safe navigation, right? Because you can miss important features like seamounts. So this image is a close-up view. It gives us a sense of comparison between resolutions. The background, that kind of fuzzy blue, is the satellite-derived bathymetry, while the center portion was collected through multi-beam echo sounders. This difference in resolution could be the difference between a submarine grounding on an unmapped seamount, or closer to shore, a ship getting stuck in harbor. From a scientific standpoint, this level of resolution can provide invaluable information to quite accurately predict where fisheries, species, deep sea corals and sponges, and other critical habitats, critical minerals, and other resources can be found that allows us to make good sound management decisions. So this map here, everything that's kind of in color, shows a compilation of seafloor data collected with shipboard multi-beam echo sounders. The resolution here is from 100 to 800 meters, depending on the depth. And these data were compiled and collected through an effort called Seabed 2030, an effort to map all of the global ocean by 2030. It's a slow, expensive, and labor-intensive process to do this from ships. Yet the progression has been rapid. In 2018, less than 7% of the seafloor was mapped, or at least we had the data to show it. And now we are at about 21% of the ocean that has been mapped. So it's, you know, incredible progress that I think really demonstrates what we can do when we come together as an international community, come together across sectors to tackle grand challenges in our environment. In order to, you know, continue to shade out all the rest of those portions that haven't been mapped yet is going to require new innovations and mass operationalization of novel technologies, like autonomous systems that can reduce costs and labor requirements of shipboard operations. I don't think I have to convince this group here of that, but we have some big challenges still ahead of us. So with so much progress still to go on simply mapping the seafloor, so much less of the ocean remains explored and characterized for the biological, geological, chemical, and physical properties. The deep sea is chronically underexplored. So I'm going to hone in a little bit on the biology to highlight this point. The plot on the left here shows the drastic drop in the number of observations of organisms with depth. So we have depth on the y-axis there, number of records on the x-axis. And that's a log scale. So it is significant how much less we know about the biology in the deep ocean. The chart on the right-hand side is the proportion of records of the total records we have of organisms in the ocean, and the x-axis proportion of ocean area. I'll draw your attention to that red point, which is 0 to 200 meters, and see how high above parity it is. So again, emphasizing that we know so much more in the surface ocean than in the deep. Because of this lack of observations and the challenges of making them, an estimated 90% of marine biodiversity remains undescribed. Again, technology can hopefully get us into these places to be able to make these kinds of observations, figure out ways to automate observations, collect biological observations using different tools like eDNA, and how to actually process and share those data in ways that are useful and helpful. So one of the, certainly not the only methods used to conduct ocean exploration and characterization is using remotely operated vehicles, or ROVs. They're typically equipped with high-definition cameras, and they're uniquely suited to observe behaviors, fine-scale distribution, and interaction between animals, to also make observations of the substrate of the seafloor, collect sensor-based measurements throughout the water column. Many scientific ROVs are also equipped with capabilities to collect specimens. So that's organisms, water, rocks, sediment. And through telepresence, these vehicles can send video from the bottom of the ocean to your laptop or phone in mere seconds, which helps both to facilitate the science. You can bring in scientists who aren't out on the ship with you to help you understand what you're seeing and direct operations in real time. But it also serves as a compelling method for outreach, engagement, and education about the ocean. Truly an opportunity to invite everybody into the deep sea with you. So what can ocean exploration data tell us? There's a mantra in the seafloor mapping community of map once, use many times. And I think this really applies to all sorts of data in the ocean environment. Mapping, video surveys, sensor-based measurements, and samples can inform decision-making related to renewable energy siting, distribution of critical minerals, drug discovery, populations of managed marine species, and biodiversity surveys and conservation. Ocean exploration drives innovation of new technologies, and it inspires people. So now I'm going to take you on a little bit of a virtual tour of the deep ocean. So if you go down there, and remember it's dark, so you have to shine a light to see anything, first of all. What you're most likely to see at first is this: darkness with a constant rain of organic material slowly falling down from the surface. We call this rain of particles marine snow for obvious reasons. And it's made up of decaying animals and excrement, various animal parts that are shed naturally throughout the course of their lives. It kind of slowly starts falling down through the water column. If you travel down a little further, you might see something more like this. In all of the ocean, there's a deep aggregation of animals, typically between 200 to 1,000 meters. The reason why these fishes and other animals as well live at these depths is to avoid predation by predators in the well-lit surface waters. These layers are commonly referred to as deep scattering layers because they can be detected by acoustic echo sounders, like the systems used to measure seafloor depth. Many of the animals that comprise those layers migrate into surface waters at night to feed. Through this daily migration, which is the greatest migration on the planet, these animals actively transport carbon from the surface to the deep, where it's more likely to be sequestered and help mitigate climate change. There's a huge abundance and diversity of animals living in the deep water column. And they have some unique properties, as you can see. Many species, from fish to jellyfish, shrimp, and squid, are bioluminescent. They can produce their own light. This bioluminescence can be used for a range of communications. Bioluminescent ink can serve as a decoy when an animal is under attack. Some species have very specific bioluminescent patterns that help them to find each other, to find their mates. Some shine light from their eyes like a flashlight to search for their prey in that dark environment. Many of these deep water column animals, which are tremendously abundant, though you probably don't really think about them very much, are prey to economically important fisheries species like tuna and swordfish, as well as sharks, marine mammals, and even seabirds. And yet the water column, and the deep water column in particular, remains perhaps the least explored environment on our planet. And it's thought that there is significant undiscovered biodiversity in these areas. So if you can, for just a moment, ignore that really spectacular sea cucumber and look at the, mud behind it. So we've now followed that marine snow down to the seafloor, to the abyssal plains. The marine snow that we saw before creates sediment, this layer of organic, nutrient-rich sediment that animals, like the spectacular sea cucumber, you can look now, can feed on. That sediment ultimately can be buried and thus sequestered, and that is a really important mechanism for carbon to get trapped on the seafloor, ultimately pulling it out of the atmosphere. Without this so-called carbon pump, carbon dioxide levels in the atmosphere would be much higher than they are. I'm going to talk a little bit more about this in a bit and show some data, but I do always think it really helps to actually visualize the environment before you start jumping into charts and numbers and things. And of course, the whole ocean is not flat like that scene we just saw. There's structure. So this is a series of canyons here, seamounts like in this chain here from the Pacific. Areas with relief like the canyons and seamounts have are often well suited to harbor diverse assemblages of sponges and corals, which provide critical habitat for fisheries and many other species. There are also sparse chemosynthetic environments like this hydrothermal vent, where chemical reactions using hydrogen sulfide or methane, which would be absolutely toxic to us, are used as the foundational energy source. And yet these spots are teeming with life, as you can see here, with mussels, crabs, shrimp, worms that are specialized with symbiotic bacteria that allow them to thrive in these really extreme environments. Through ocean exploration, we've learned that hydrothermal vents release significant amounts of iron into the ocean, which is a limiting nutrient for primary productivity throughout the ocean. So it turns out that these, kind of crazy, bizarre environments that are, found in the deep sea are actually really important even for primary productivity, normal sun-based energy production up at the surface throughout the ocean, and important for oceanic food webs. But as you surely know, the ocean is unfortunately not on the best trajectory right now due to climate change, biodiversity loss, and other impacts. The ocean takes up over 90% of the excess heat caused by greenhouse gas emissions. So the image on the left here shows increase of several degrees Fahrenheit sea surface temperature across the global ocean over the last about 120 years. The ocean also absorbs about a quarter of anthropogenic carbon dioxide, leading to ocean acidification and loss of oxygen. Some of the excess carbon, as we saw, is ultimately buried into the seafloor sediments. However, that process too is vulnerable to climate change, as we'll see in a moment. And the deep sea, unfortunately, is not immune to these climate change impacts either. Much of the absorption of carbon and heat ultimately does take place below 200 meters. So these maps here show modeled changes at the deep sea floor in the year 2100. So temperature in the upper left is predicted to increase. Oxygen on the upper right to decrease. And again, this is seafloor, but it's actually much more significant up in the water column at deep depths. Ocean acidification, the pH will decrease, as we see on the lower left, and then also predicted to have a decrease in carbon flux to the seafloor, which is a little scary because that's a positive feedback loop where the more carbon dioxide in the atmosphere, the less potentially is making it to the seafloor. Biodiversity is also threatened by a number of other factors. Pollution, such as marine plastics, make their way to all parts of the ocean and have been found in the guts of many deep sea animals. Oil spills contaminate the environment from the surface to the seafloor. The emerging seabed mining industry has huge potential impacts on deep habitats, and overfishing and bycatch continue to be threats to many fisheries species. So this map here shows a score of cumulative impacts on the ocean from a range of stressors: fishing, oil and gas, pollution, heat, acidification, shipping. And as you can see, almost the whole global ocean, so everywhere shaded in that red or yellow, is heavily impacted by human influences. So it's all a bit depressing to palate, and also probably not news to most of the folks in this room. But there is some good news. The ocean is also a powerful source of solutions to climate change. So a recent scientific analysis commissioned by the High-Level Panel for a Sustainable Ocean Economy investigated opportunities in ocean management that can draw down carbon, which are illustrated here. These methods include renewable energy, such as wind, wave, and tidal, transitioning ocean shipping to more efficient and lower zero carbon fuels, changes in ocean food demand and production, such as changes in feed source for aquaculture and shifting market demand to sustainable fisheries species. Finally, natural ocean systems like coastal mangrove forests, salt marshes, seagrasses, and the deep sea sediments that we looked at already do a heavy lift in naturally storing carbon, and protecting and restoring these systems can help keep carbon out of the atmosphere. Together, these ocean-based climate solutions might provide as much as 1/5 of the greenhouse gas emission reductions needed to get us to the 1.5-degree Paris target by 2050. And then, again, I keep emphasizing throughout this talk, because of this audience, that, technological advancements like those that you are all working on here are really critical to getting us to accelerate implementation of all these solutions and really see that to fruition. Fully protected marine protected areas provide vast benefits that help to preserve biodiversity and habitats. And networks must be designed in smart ways to ensure a range of representative habitats are protected and that they're resilient to climate change. Again, you heard me talk about the deep sea. It's sometimes out of sight, out of mind, but it's really important that we protect, not just the coastal systems, but also these different types of systems that are further offshore and further out of sight. The U.S., through its America the Beautiful initiative, is working towards conserving 30% of land and water by 2030. So now I'm going to shift a little bit to some of the ways that you can get involved, with a focus on U.S. environmental policy and a few select international efforts. I'm going to apologize, these slides are not as fun as the deep sea video, but wanted to make sure I had an opportunity to share this with you as well. So in June of 2020, the U.S. launched a new strategy to map, explore, and characterize our waters, with the high-level goals of working across government and across sectors to map all of the U.S. exclusive economic zone by 2040, and exploring and characterizing priority areas. To develop and operationalize new technologies that will help us to actually meet those ambitious goals, and to share the science and data broadly. The shorthand for this strategy is NOMAC, which stands for National Ocean Mapping, Exploration, and Characterization. There are a number of existing and new regional campaigns across the U.S. to implement the NOMAC strategy. So locally here, we have the Express campaign, which is expanding Pacific research and exploration of submerged systems. Just a couple weeks ago, the White House released a report identifying strategic priorities for ocean exploration and characterization to help move this effort forward. These priority areas include informing potential protections and management of poorly studied marine environments through the study of sensitive seafloor ecosystems like deep sea corals, fish habitats, chemosynthetic environments. Second, elevating the rich history of ocean use, including by indigenous peoples, through the study of ocean cultural heritage. Third, informing decisions on the sustainable use of our natural resources by exploring and characterizing marine resources such as fish habitat, aquaculture, renewable energy, critical minerals, deep sand and gravel, and natural products. Fourth, improving and forecasting and community awareness by filling knowledge gaps on seafloor hazards like earthquakes, tsunamis, and underwater volcanic eruptions. And finally, better understanding of the ocean's role in transporting heat, sequestering carbon, and supporting a range of biodiversity through studying the vast and unexplored water column. Stepping out a little bit more broadly across the ocean science and technology space, the White House, in coordination with a range of ocean agencies, released a report last year highlighting priorities for ocean science and technology over the coming years, with emphasis on the ocean climate connection, resilient ocean science and technology infrastructure, and building a diverse and inclusive workforce. Some of the areas of immediate opportunity relate to wind energy, coastal resilience, conservation, blue carbon solutions, ocean exploration, and international collaboration. It's really great to see that so many of these topics are on the agenda for this very meeting and really align with what's coming down from the White House. At the start of this talk, I talked about that connection between people and the ocean. And ultimately, this connection is, really the point of everything we do, right? It needs to benefit the people. Involvement of local communities is critical to sound decision-making and science. The U.S. ocean science and technology community has, over the past year, committed to environmental justice in all of our work, to the fair treatment and meaningful involvement of all people, regardless of race, color, national origin, or income, with respect to the development, implementation, and enforcement of environmental laws, regulations, and policies. To this end, the agencies have collectively committed to incorporating environmental justice in our ocean science and technology work and to continuing to educate ourselves on environmental justice topics and approaches. So a few other kind of current opportunities that are out there. So the White House, again, with the agencies, is developing an ocean climate action plan. It is currently open for public comment. Unfortunately, it's closing in a few days. But there, if you are interested in, kind of helping to inform that, feel free to put in public comment. The U.S. is starting a national nature assessment. This was announced on Earth Day this past year, and they just put out a roadmap for this as part of the COP27 announcements, and really looking to model this on the national climate assessment and really evaluate nature across, land and ocean and across the spectrum to understand what we have, how it's being impacted, and be able to start tracking it over time. And related to this is an effort to incorporate natural capital accounting, so to actually make decisions that include the value of nature, the inherent value of nature, and place economic value to that so that we're making more sound decisions that take into account our resources. The National Climate Assessment recently went out for public comment. And that will be open until January. And then, of course, the two big bills that were passed recently, the Bipartisan Infrastructure Law and Inflation Reduction Act, have funds in them related to the work that we're all doing. And I actually just realized that NOAA has put out this really nice website that links to all the different activities that are connected to the bipartisan infrastructure law funds. So just wanted to make sure everyone here was aware of all those opportunities. On the international stage, the U.S. last year joined the high-level panel for a sustainable ocean economy. There are now 17 members. They're all heads of state are the members, representing a geographically diverse set of nations shown on this map, with a headline commitment to aim to sustainably manage 100% of ocean area under national jurisdiction. And between those 17 countries, they're now at 50% of global coastlines that are participating in this. And then finally, and I know I'm probably going over time here, so I won't dig into this, but the UN Decade of Ocean Science is currently underway. This is just a small selection of projects that relate to ocean exploration, as I had started with, but there's topics all across the board of ocean science and technology that are still looking for people to participate in. And that's it. So I hope that this gave you a good sense of exploration and the work that we're doing to respond to climate and protect biodiversity. So thank you so much.
Wait, let's take a... Thank you very much. Let's take a question or two if anyone has them. 7, 6. There's one in the back.
Sure. Hey, thanks a bunch. Great talk. Great introduction to what NOAA is doing. I'm a systems engineer here at Scripps, but my most important job is as a scout leader, and I'm in the midst of rewriting the Oceanography Merit Badge pamphlet, which is a 96-page kind of thesis. And one of the requirements that we've asked the scouts to do in the new set, the rewrite, is to look at data sets that are publicly available. And like, for example, we're taking the Cal Coffee data set and we're asking the scouts to take a data set from 2 research station locations, the year that they were born, and then 5 years later, and comparing the differences. So I've looked at, I haven't looked at all of the data that you've presented, but how accessible do you think the data sets are? What tools may exist that are under development for, I'm going to say, scout age youth from 11 to 18? There's a lot of data sets out there, but some of them are like trying to translate Proto-Hittite. So thanks.
Yeah, thanks for that question. We certainly struggle with some of the data archival and access challenges that I think everyone does who's collecting a lot of data. All of these video are publicly available, as are all the kind of sensor-based measurements, the seafloor mapping data. They are probably, I think, more ahead of than the ocean exploration side of things, because there's been a really big effort over a decade to try and consolidate data sets and make them more interoperable. So yes, the data are available. Yes, we still have some challenges, but certain pieces I think are really findable and could be really fun for the scouts to work with.
Thank you. One that comes to mind is NOAA recently released another one that comes to mind is a sea level rise report and projections moving forward, but the National Water Level Observation Network has some data sets that go back over 100 years, and so it might fit as something that age could understand, at least understanding water levels, but you might have to suggest a 20 or 30 or 40 year comparison rather than 5 to get much change. All right, next panel. I'm surprised that mic didn't squeal at me. Not supposed to put it next to this one. So we're moving on to our next panel. It's called Reducing Risk and Increasing Resilience with Environmental Monitoring Data Solutions. We will be discussing reducing risk and increasing resilience, I just said those words, in the face of extreme weather conditions, climatic changes, and sea level rise. This panel includes a mix of speakers from industry and from academia. Again, I'll introduce our panelists. You will get to hear from each of them, and then we'll have some time for Q&A at the end if they don't run over their time. First up, I'm going to have Dr. Clarissa Anderson, Executive Director of SCOOS. Come on up, and I'll see if I can get the talks.
I've given them mine in Google Slides. Do you want to take
He's got them in the folders.
Okay.
That bottom one.
Yeah. I don't have my glasses on. This could be disastrous. I should probably get them.
Do you want to get them?
Yeah. Yeah, so there we are in Puerto Rico. last week. Carl, are you in any of those big photos? No, you're not, unfortunately. But this is just a nice way to show you a little bit of who we are as a network and that we are a close-knit group. But I'm going to dive into how our organization, Scoos, works to increase resilience, reduce risk, et cetera, across a range of sectors and needs that we have in the community. I'll start with this slide, which shows who we are. We are really a small group. I know, there's a lot of people on this upper panel, but kind of on the day-to-day, in terms of the operations of the office at Scoos, I really want to say it's myself and Megan. So I have to acknowledge her because my right-hand woman here just does the yeoman's job of so much at Scoos, and it's great to have her here. Thank you, Megan. You don't get enough accolades. So, but we do have a huge team that makes everything happen, and I don't want to. I'm be remiss if I did not point out that we support an incredible breadth of researchers and folks that cross academia, industry, a number of sectors, and we have other folks who really help us think through how we use the money, like the two on the upper right here. And the reason I bring that up is I want it to be clear that we're kind of a consortium of scientists and oceanographers in the region who come together, take the funding that comes to us from the USIS program, and then decide how to best use it to meet the needs of the stakeholder community. It might not be obvious, but we have these a very elaborate kind of governance structure in order to do that. So as director, I'm not making decisions as an autocracy and just deciding who should do what. We really do all come together as a community through a number of different networks to decide how to do this and how to meet those needs. And as you already heard from Carl, there is this integrated network. There's 11 of us. We're all unique snowflakes, as Carl can attest. We all have our needs, our regional needs, but we're also really different structurally, and I won't go into that in too much detail, but it does matter for kind of how we approach the needs of our local communities. We here, as you know, are at Scripps. We're part of UC San Diego. Some of the other groups are also very academically anchored. For instance, NANUS is a big part of University of Washington system. Some of us are nonprofits. Some of us are hybrid nonprofit academics. And so we're not federal, we're not part of the federal structure per se. We are part of this grander IUS enterprise, and we all approach things a little bit differently. At Scoos, it's really quite an honor to be part of Scripps because this broadens our reach into a lot of different places and how we engage with the academic community to do all the things that you're seeing here, ocean observing, data management. This really is an end-to-end system of putting instruments in the water, doing the engineering, pulling those data in real time and sending them off to all the different repositories where they need to go. Some of those are places where data go to die. Some of those are places where data goes to really live on in products and services that we develop, and the outreach and the education, which I don't have a huge amount of time to go into today because I want to give you a nice holistic overview of what we are as a system. California is lucky to have 2 of these regional associations, and not because we are such a big state with so many needs. We're the only such state in the union that has that. Sencoos is in the north. They're the Scoos of the north. And they are stands for Central and Northern California Ocean Observing System. Even I can't say them. It's ridiculous. But you can see what we have going on. And a lot of this is kind of obscured at the scales at which this map is drawn by the Cal Coffee lines, because we do collaborate so strongly with Cal Coffee, and a number of our operational gliders run on those lines 24/7 through the California Underwater Glider Network. But along the shore, and really as you get into those scales that most of our global ocean observing system cannot get to, we're doing a ton of work near shore with moorings, buoys, real-time sensors at pretty much all the municipal and even private piers in California, a lot of models. We have a little picture, graphical illustration of what this looks like just for Southern California. I won't touch on all of these, but you can imagine if you're just thinking about something like essential ocean variables, there's a lot of them coming out of this. We set up our website to have multiple access points depending on whether you're a modeler and you just need all of the sea surface temperature in our network, or if you really need to know something about a specific question or a specific project. But we are really trying to move from the origin of Scoos, which is physics, things like radar, gliders, and push that boundary on the ecosystem predictability that is inherent in a lot of the measurements that we make if we can co-locate the biology and the biogeochemistry at all of these sites where we have physical measurements. We can start to, I think, get to a place where we meet a lot of different societal needs and think about resilience in an extremely broad way, broader than what we're doing now. And to do that, we have an incredible network of stakeholders and partners. This does look like a lot, but all of these groups have written letters of support for us, for our funding. We try to engage with them as much as is humanly possible, with just two of us doing a lot of the engagement. But it really is important to us that we engage with this network because we cannot create the products from the data that we're generating unless we know what is needed by the community, whether that's local, state, federal, and even international. So I'm going to give a little bit of a random walk through our portfolio. Many of you may be aware of the very large high-frequency radar network that we have. It is the largest in the world. If you combine California and Northern California, we have over 64 radar, and these give us the real-time surface current measurements that feed into just myriad models and real-time systems, as well as science process studies. We work pretty closely with U.S. Coast Guard to ensure that these data go into real time and are assimilated into the SAROPS short-term prediction system. We also, for search and rescue, we work with California oil spill response, so that's CalOSPR as well as federal, to make sure that these are also assimilated into NOAA. When there's an oil spill, we worked pretty intensely on the Huntington spill when that happened to make sure that while those systems were in place already, there was actually quite a lot that needed to be done to fill in the gaps where there were no wind data, and we were able to not only back calculate wind from radar, which is used for the surface currents, but also deploy other instruments that we had, like the wave glider, to get out there and fill some of the gaps that were crucial in that instance. And that's what you're seeing here on the left, where this eddy was kind of was resolved by the radar, and it was important to show why the patch of oil in that event was not moving into San Diego. Everyone was kind of waiting for it, and it wasn't happening, in part because it was being kind of held and sequestered just north of San Diego County by this eddy that, once the winds picked up, kind of broke down and the oil moved. But we work really closely with Coast Guard. We also have, a number of stakeholders within the marine ecology community, because, as you can imagine, these data are essential for looking at larval connectivity, doing a lot of Lagrangian particle tracking of all of the biological particles that are basically at the whims of the currents. And then we have the California Underwater Glider Network, and this is primarily run by Dan Rudnick here at Scripps, where he builds these spray gliders in-house. We heard a lot about Slocum gliders earlier. This is a homegrown technology. These spray gliders are now quite ubiquitous worldwide. He works with a number of partners, including groups like SOSIB in the Mediterranean, and does a lot of the end-to-end work from the engineering all the way to the data management, and then does pass some of that off onto us. But we really are lucky to work with him on the products that are generated, like this Hufmuller diagram here, which is giving you a sense of what is the state of the ecosystem here in Southern California from these operational subsurface gliders, telling us heat content, and what does that look like over time when we have something like a massive marine heat wave, like the Pacific Warm Anomaly, or the blob, as we like to call it, passing through the system and then leaving its mark for years and years and years. So there was kind of this sense that it came and went, I think, in a lot of the media, but these things don't come and go, and they do tend to kind of shift us into a slightly new regime. We look at our connectivity with what's happening at the equatorial Pacific in relation to things like El Nino. What is happening in Southern California with respect to the temperature and the variability at the equator? Well, prior to that marine heat wave, so prior to 2014, you can see the tight coupling of all of the glider line temperature time series with what's happening with the oceanic Nino index, a real decoupling during the marine heat wave, and then those things merge back together again. But it took a while for that to happen, and there was almost a new regime that was set for many years prior, and we're starting to see them coalesce, but at an offset now that we didn't have. So without this kind of glider time series, we wouldn't be able to inform
models that need this kind of subsurface heat content. And when I talk about these models, these are used heavily by Southwest Fisheries Science Center, Environmental Research Division, to think about how to forecast myriad fisheries populations in the face of things like the low frequency variability that is so important for California current studies. We also work within this space of coastal resilience and flooding and inundation with the California Coastal Flood Network. So this is a tight collaboration with Mark Merrifield and colleagues here at Scripps to think about total water. So really think about run up, run off, sea level rise, the combination of those. At the beach level, we're working with municipalities up and down the coast, starting with a very old and I would say kind of foundational collaboration with Imperial Beach, where some of the initial investment in the high frequency radar came from Imperial Beach and it kind of established SCOOS for what it is many decades ago. And that investment and that relationship endures, but now more focused on thinking about inundation in Imperial Beach. How do we take that model of our daily forecasts, push that up to every single beach in California? We can produce these forecasts of inundation, but the validation and then calibrating that coastal model takes more on-the-ground effort, which requires this myriad of sensors and even LiDAR that you're seeing on the left. And so we're kind of slowly working our way up the coast with this level of inquiry so that we can validate the kind of map that you're seeing on the right. And this is essential for road and parking lot flooding. So we've got we go to the lifeguard meetings and kind of engage with them. They're highly interested in this for the obvious reasons. You heard a little bit from Carl earlier about the Coastal Ocean Modeling Testbed. We are engaged in that through an IUCE West Coast COMT, as we like to call it. And this one is about evaluating a real-time data assimilative model. It's a ROMS-based, called the West Coast Ocean Forecast System, WCOFS. This is now an operational product at NOAA. But for a long time, we were supporting and still do support a lot of academic models coming out of our various institutions that are ROMS-based. And we're kind of transitioning into this space of, if we're going to have WCOFS in existence, and it does and will supplant some of these other models, what are the ramifications for the ecological forecasts that we already have in place that are crucial for our communities when it comes to ocean acidification and hypoxia and harmful algal blooms? And so the one on the right is one near and dear to my heart because I've worked on this for decades, getting spatially explicit probabilistic maps that go out 3 days or more of toxins in the water. In this particular case, it's domoic acid because that is a very important neurotoxin for our region, important for fisheries, important for Dungeness crab, important for the marine mammal populations. As well as us, we want to stay alive too. And so we've done a lot in this space. I won't go into too much detail, but I want to point out that we have a California HAB bulletin. This is a public listserv, goes out monthly, pulls together all of the HAB monitoring that we're doing, that the state is doing, some federal labs, marine mammal rescue groups, combines it with the model output and gives it a translation. So in the end, what we have found is that handing these models off to something like Coast Watch is not the end of the line. The translation and synthesis really is critical. And so we're not doing this with every one of our products. I would love to have the time because we pull this together ourselves, but to have the time to sit down and explain the interconnection and the story and the narrative for what each one of these data sets means relative to one another is really important for our stakeholders to calibrate the model, because they can look at something like 60% probability of a toxin, but it means nothing to them until they know what that means relative to the resource of interest that they care about, just like a weather model for us. And we're putting in these imaging flow cytobots. We have 12 of them now. That's the biggest network of these in the world. They're robotic microscopes, and they tell us in real time, every 30 minutes, the entire phytoplankton community, they give us the images, we do the machine learning to tell us what those images are, and then we're putting this into a national repository with all the interoperability that you can imagine and also the struggles that go with that. But I'm going to close out. We've got 2 more slides. This is the integrated ocean observing system sort of approach to thinking about MPAs. SENCOOS and SCOOS came together and applied for this funding from California Ocean Protection Council. I should note they also funded half of that imaging flow cytobot network. And what we're seeing here is that we've got incredible inventory and catalog of models and data, and we can work with the marine ecologists in California to pull all their data off their desktops and create tools that are of real value for the assessment, ongoing decadal assessment of the California MPA network. Are these marine protected areas doing what they're supposed to be doing? If you want to make those assessments, you need a lot of contextual data, a lot of baseline data. And so we've put together these tools, and we're continuing to push the boundary on what those tools can do. And it includes climate projections, and it includes a lot of real-time data. So I'm not going to go into this red tide because we don't have a lot of time, but I think this gets to the outreach part of this. We had a really big event that happened right at the beginning of the pandemic. It was hard to get the sensors out there. You heard about wire walkers earlier. That's some really cool wire walker data that we've moved mountains to get at the time that this happened. But we captured this really pretty historic event, a 2-month-long red tide of a dinoflagellate. Had kind of devastating to the marine ecosystem. We had a lot of marine animal mortality, inverts, finfish. And this became, and still is, a major event for us for outreach in terms of getting some of these data into the hands of teachers in the community to tell these narratives, but also even work with groups like NASA Develop, which we've done to push forward the remote sensing component of this story. And that is a really cool program, if you don't know about it, that brings together undergrads over 2 or 3 month long period to answer really important societal questions. So this was my last slide. It goes into depth here. These are beautiful events, bioluminescence, et cetera, but they also can have devastating consequences. And I would love to talk more about diversity work that we're doing, but we don't have time. So I'm going to leave it there with this beautiful picture of Scripps Pier and this Lingulodinium bloom from 2020. And I'll take questions later, I guess, once we're on the panel. Exactly.
Thank you very much, Clarissa. Our next speaker, John Gorlasco, account executive from Jupiter Intel. Come on up. Even I might be able to make this thing work.
Not the most technologically advanced, so get that up. The afternoon event, very exciting. Thank you for the introduction. I'm happy to be here today. First, I have to do a shameless plug for San Diego Green Drinks. So I volunteer with the environmental group based here in San Diego. For anyone that's local, we usually meet on the 3rd Thursday of every month and have some beers and discuss an environmental topic. But why I'm actually here today is to discuss climate risk. So by way of background, John Gorlasco, and I'm account executive here at Jupiter. For those of you that don't know, account executive is slang for sales. So it's how we usually do our outbound messaging when we're spamming people. The sales logo in the bottom doesn't allow for people to respond as fast. But one of the real reasons I joined Jupiter Intelligence and what we do is we quantify climate risk across the globe. So we try to standardize processes for more of the commercial sector, also working with the public sector to quantify the short-term and long-term impacts related to climate change. Well, the real reason I joined Jupiter is really the caliber of the science and scientists. So based in San Mateo, we raised about $100 million. And then initial capital allocation, we focused predominantly on the science. So some of my esteemed colleagues that I really get to brag about on a consistent basis and builds credibility to our organization is, first off, is Betsy Weatherhead. So she's a Nobel laureate for her work on the IPCC. Just recently came back from a stint at the White House working on the National Climate Assessment. Pat Haar was a senior executive at the National Science Foundation Atmospheric Research Division. He's also our expert on hurricanes and cyclones. Alan Bloomberg is an oceanographer, predominantly on our coastal flooding methodology. And then our chief science officer is a San Diego native, but came from the National Center for Atmospheric Research. So these colleagues utilize the global climate models, and then really what our secret sauce is downscaling that information down to a 90-meter resolution. So this is a high-level overview of what we do. So Jupiter operationalizes the best client science and converts that information to economic impacts. So we utilize the phrasing peril metrics, which comes from the insurance industry, thinking of things like flood, wildfire, wind, extreme cold, and heat events. And then what we do is a comprehensive portfolio analysis for locations around the world. So any corporation that wants to understand the complexities of their assets, we're able to run it through what we call as our Climate Score Global tool, and then run that down to a 90-meter resolution. We operate in 3 planning scenarios. I know someone mentioned the Paris Accord earlier, which is at 1.5 degree. From our perspective, we see it more as a 1.8 degree scenario. We also do the 2.7 degree scenario with the shared socioeconomic pathways, and then the business as usual, which would be that 4.4 degree scenario. So running that through all of the peril metrics, you're really able to understand comprehensively what your threat profile would be, and then how you can integrate those resiliency decisions. We do this in 5-year increments all the way to 2100. So some of the sectors we work in, insurance, banking, real estate, asset management. I'm going to get to our clients in a moment, but that's how we really identify the overall risk profile across different verticals. My focus area predominantly is on the West Coast in Canada, but transitioning more to the energy and real estate in the coming new year. So who does Jupiter work with? So during the initial foundation of our organization, we were predominantly focused on clients that had capital-intensive projects, specifically the utility sector, so Hawaiian Electric, BP. Then as we grew the organization and focused on scaling more of the business, we transitioned into financial services, public sector, working with organizations like Broward County on flood maps, and then the distribution, which is where I really like to emphasize our collaboration with organizations, civil engineering firms like AECOM, BCG and Bain, more for organizations in the financial services, so thinking credit risk. The officer, the comptroller of the currency, the OCC right now, is requiring 6 big banks to go through a climate stress test to test their liquidity. And then organizations like Guidehouse. The one that's not publicly named that I really like to emphasize when discussing Jupiter is a large investment bank that we actually evaluate their mortgage book to see what their risk profile is from climate-related risk. So if you're looking at a 30-year risk premium, is that large enough for if capital reserves became an issue? So what do we need to run through Climate Score Global to evaluate assets? Ideally, we like to have the latitude, longitude. We don't do an Antarctica. I haven't come across any organization that wants to do that so far. And then the financial value of the asset. And the reason we need the financial value of the asset is we utilize the HAZIS model from FEMA to convert that information to economic loss. So should a 1 in 500-year flood event occur, a 1 in 500-year wind event, we're able to take that information and looking at previous insurance claims, convert that information to economic loss, whether it being damage to the asset or loss of building inventory. So we run that through our climate materiality assessment, which you'll see in a moment, and then further down is that vulnerability and loss estimation. So as you can see here, we're looking at, it looks like a lot of assets across an energy data set. So on the top right, we're looking at the portfolio summary, different types of assets across the world, where now we have in the middle of the peril metrics. So intuitively, like a street light, those peril metrics, red is bad, green is good. And then on the left, you're able to decide between different scenarios. So referring to that earlier, that optimistic 1.8 degree scenario, the less optimistic, that 2.7 degree scenario, and then the more scary 4.4 degree scenario. As you change it in 5-year increments, you're able to see that threat profile either expand or reduce, contingent on the peril metric. And then you could break it apart based on whether it be fuel type, asset owner, really have a diverse way to ingest this information and make more strategic resiliency decisions. Now, as we do a deep dive into an individual peril metric, what we're looking at here is a 1 in 200-year flood event under the business as usual scenario, that 4.4 degree scenario, looking at the year 2020. So this specific use case was a utility that invested a significant amount of money in their asset. And should this event occur, what our forecast would say is that 2 meters of flooding would occur in the southeast. Should you take the opportunity to allocate capital to build maybe like a seawall or sea level, our data set would be able to provide that offset, so we'd expect 0 at the end of it, which gives organizations the opportunity to really understand the overall financial impact of reducing the resiliency. or reducing the impact. But that is Jupiter at a high level. I'd love to answer any questions after this. Yes. Thank you.
Thank you, John. Next up, Carlos Gaitan. Did I say that right? Excellent. Let's see if my advanced file management. Have to see the mouse. Which one of those two is yours? Benchmark Labs? Take it away.
Thank you. Welcome, everybody. I'm Dr. Carlos Gaitan, CEO and co-founder of Benchmark Labs. We are a software as a service company based in San Diego. Before we were in the Bay Area. Greetings to our colleagues there of Jupiter in San Mateo. We decided to move to San Diego in many reasons, because we believe on the strong ecosystem that we have and to give opportunities to the great number of graduates in the biological sciences, physical sciences, machine learning and engineering that the region provides. Benchmark Labs, in a nutshell, what we do is environmental forecasting tailored to a specific IoT sensors. An IoT sensor is an Internet of Things device. It could be an anemometer, a pyranometer measuring solar radiation, could be thermometers, you name it. So we identified, based on my previous experience working at GFDL and with different users at the National Weather Service, that there is a significant group of users where the information from the National Weather Services, NOAA, NASA, European Center of Medium Weather Range Forecast, Environment Canada, the gridded models are just not accurate enough, because they are interested in subgrid processes that are often not resolved by those models. And they need to manage, as they mentioned in insurance, assets. We work on refining the publicly available information from, thanks to the Freedom of Information Act. Thank you, US. We use information from leading numerical weather models. We refine them, and we use these IoT sensors as ground truth. As we are now in a panel focusing on the value of observations, and here in San Diego, in this great campus, I wanted to give you not necessarily the sales speech of what we do, but also all the avenues that in situ observations can help to validate. We are Benchmark Labs in many ways because we also believe in the value of transparent science, benchmarking against public and private sources. And in a nutshell, I just wanted to show you what we're focused on. So in general, Benchmark Labs is focusing now on the agricultural and energy sector. In reality, why we are doing this is because weather affects all of us. However, for users in agriculture, from frost prevention, water and energy balance, labor scheduling, pest and disease control and modeling, and even costly access to insurance, all of them are affected by weather processes. However, because of what they call the spatial basis risk, there are many uncertainties when they try to get information from the nearest weather station that often is at an airport, or at a location that is not the farm or the asset that they are managing. Those inefficiencies get translated into overwatering, pesticides waste, fertilizer waste, OSHA regulations, and lack of compliance for exposure of labor over hazardous conditions. It could be 95 degrees Fahrenheit, for example. Labor cannot be performed. And all of those situations occur at the more operational weather scale. So those are the problems that we are tracking. In terms of like the labs in our name, we are supporting, thanks to the Economic Development Council here in San Diego, a group of interns that have been hosted in our company in different areas, from business development to science and engineering. And I want to reiterate here that we are in Scripps. If you have like a very interesting postdocs, or graduate students that want to transition into the private sector, but still play around with environmental data sets that have like an impact, we are welcome to receive them, and we receive support from San Diego Economic Development Council. In general, what you can see here is that there are many problems in ag. They are translated also to fisheries in many ways: food access, food utilization, safety, nutrients, climate-related perils. All of them can be improved with better observations. And sometimes this lack of in situ observations are the ones that cause these uncertainties that propagate through the value chain. Typical problems that we had tackled in our domain from pest detection and classification. This comes from observations. They can be tackled using satellite data from NOAA, from NASA, different hyperspectral bands. We are very interested in the novel technologies that are being released in the new generation of satellites that will allow us to get a better chlorophyll content and understand pests and disease before it's visible to the human eye. We know that it can be forecasted in advance, and this is a typical example of a classification model detected using machine learning and in situ observations monitoring from a phone. Example here, knowledge discovery using genetic programming, exciting projects that interns had performed in the past. In this case, you can see how a data stream collected from one of the sensors and with a machine learning engine based on genetic programming starts to find the optimal nonlinear fitting to create a regression model that fits the data and can be used for forecasting. Another opportunity here is, for example, knowledge discovery. We had done it to replicate the open flow of Manning's equation, for example, just based on pure observations. We are in an observational-based topic here. So I wanted to also showcase why it's important that we keep collecting observations. Not everything could be remote. Nothing can be modeled. There are so many areas that need to have observations. And when you have observations, there are now machine learning algorithms, like in this case, this genetic programming equation that based on pure observations was capable of recreating Manning's flow equation that is highly nonlinear, just pure in observations, which is very interesting for new processes, parametrization models that are happening at subgrid scale that we know that are running in biological models at NOAA and NASA. I wanted to also showcase one study that we did also with Barbara Mulling, that is now here, that working at NOS Fisheries when I was at GFDL. Again, to showcase the value of observations, spatial disaggregation using regression trees, machine learning to improve salinity, temperature, and in this case, Vibrio forecasts to understand the exposure of these hazardous conditions. And that research can be translated into shorter time scales that are of interest of our constituency in benchmark labs. And I just want to finalize here by showcasing how our in situ technology has real impact in day-to-day operations. This is a recent testimony that we got in ABC News in LA, where our machine learning-based forecasting that corrects NOAA's environmental data sets were used for farm managers here in Northern California, for avocado growers, to save 10% of water. This is the fourth year that we are here in San Diego suffering a drought, and we managed to save 10% of water, which is huge for California. We recently got a California Energy Commission grant award to improve our evapotranspiration forecasts based on that technology. But not only we save water, what is more important is that the farm manager was able to maximize their yield at their fields between 50 and 100%. So not only water reductions that we can go and discuss in terms of policy, the real cost of water, and if it should be that heavily subsidized in the state, but they saw basically a decrease on their inputs and an increase on their outputs. And that's why it's so exciting what we are building here. Again, I want to showcase our strong connection with San Diego. We were voted a San Diego Cool Company 2 years in a row. Thank you to the San Diego Economic Development Council, to the BlueTech Incubator, and to the World Trade Center that supported us for commercialization and export assistance. Thank you very much, and I'm open for questions.
Thank you very much. All right, Frederic Leroudier. Was that close?
Nope.
Frederic
That was pretty close.
Leroudier?
Yeah.
De rien.
Thanks for the
All right. It's one of the only languages I can try. They let me control it. It was a bad idea. Almost. Which button here?
This is a PDF.
It's beyond my pay grade. Okay. Try not to take too long because we have to do some questions.
Sure. So you can have to only for PDFs, you can only see it on that screen.
So how does the advance use the arrows? Okay.
Arrows.
Take it away.
Hi. Thank you. And so I'm going to be talking today about how we at Oceanography tackle the problem of climate change and how we contribute our technology and our expertise to a number of actors in the sector. Specifically on anything having to do with water quality, because that's really our focus as a company. As we know, the problem of climate change is actually, it exacerbates a lot of the problems that were faced by aquaculture farmers, environmental companies, and a lot of other actors out there, in that it puts more pressure on the environment and like I said, exacerbates those problems that were already present. Also, as we are growing, as for example, the domain of aquaculture is growing in importance. It's a relatively newcomer in the food industry worldwide. Those problems become more and more important and create also a kind of a problem on the environment as well. So it's a cyclic problem. What we're seeing is that there is a beginning of collection of data throughout the world, but also as the data becomes more and more available, it becomes more and more evident that the interpretation or the use of this data is not as clear or not as straightforward as it would seem, which leads to kind of a disillusionment on the use of this data. So how does one proceed in that case? The approach we've taken is basically to combine expertise in the domain of water quality, aquaculture, oceanography, marine biology on one side, and on the other side, data processing, which is kind of a unique combination of talents and expertise. Oceanography is a company based in France, near the Mediterranean southeastern French coast. And what we've put together is a number of systems and algorithms and expertise tackled to the problem of exploiting the latest advances in those technologies to predict and offer services to the industry. We work with many different partners, in particular in the research academic. So IFREMER is kind of the equivalent, is a French government research institute for maritime studies. Also with water companies, water treatment and water companies throughout the world, in particular in France, of course. Sensor companies like In Situ. Aerospace companies, so we work in particular with CNES. They made it possible for us to do this presentation here, so we want to take this opportunity to thank them. Research institutes throughout the world, such as CSIRO in Australia and others around the world. What we've developed in many different phases is a number of systems. First of all, we developed an IoT system, Internet of Things, basically which makes it possible to use sensors
and basically to send all this data that's being collected on a real-time basis to the cloud. And in the cloud, we developed this tool, which we called AquaReal, which is a visualization platform that merges with our machine learning algorithms to provide not only visualization of the data, but also forecasting. Today, what we can do, for example, is to provide 48 hours advanced forecast for dissolved oxygen with an accuracy of typically 4 to 6%. We've demonstrated that in several different environments. For example, in southeastern France, again, in a part that was suffering from a lot of oxygen depletion, anoxia events. But also in the US here, Lake Erie is one example where we've demonstrated our ability to predict oxygen levels. As you know, this is a problem that's affecting a lot of areas today, oxygen levels. We've developed other systems to predict phenomena. So one of the ones that's also very popular these days is HABs, harmful algae blooms. It is a much more complex phenomenon, which is at the same time a higher challenge and also a bigger opportunity, because it allows us, with our expertise and knowledge of machine learning algorithms, to develop the algorithms to predict those complex phenomena. So this is something that we are very actively involved with. Again, Lake Erie and southeastern France, but also in other environments, as I will explain. To do this, so I've talked about our IoT platform, but this is not the only thing that we use for data. We also use common public information that we can gather, for example, from NOAA sites, and also aerospace data. So it's becoming increasingly important, especially as we talk about HABs, to use satellite imagery, multispectral and hyperspectral data that's coming from those new satellites in order for us to be able to correlate that with the in situ information we're getting from the sensors, the network of sensors. We found, for example, in the case of harmful algae blooms, that you need to have a fairly dense and rich network of sensors in addition to the satellite imagery that you can get in order to come up with a reliable forecast. Today, we are at around 60 to 70% accuracy on HABs in those areas I talked about, which is, we think, just the start of it, and we expect to get increasingly good results in the next few months and years. The way we interact with the different players is we've kind of separated that in different phases. Today, and that reflects a little bit the maturity of for example, the aquaculture industry. Like I said, this is something fairly new. Farming has been around for millennia. Aquaculture has been around for dozens of years, let's say. And similarly, the adoption of high-tech and digitalization is also more recent under the sea than on land. So the first area that we've looked at is typically shellfish, oysters, not to name it. There's a lot of that in France. Anybody that's been to Paris knows that when you go to a restaurant, there's a lot of oysters everywhere, which is good. And we've focused on that and developed. That's where we developed our networks of sensors and equipped those companies, those small farmers, with those sensors because they did not have that capability, and started to deploy it and get them the information that they are now using. So basically, it gives them a snapshot of what's going on underwater. Things like temperature, oxygen, pH level, salinity, they can get that at different levels, at different depth, as well as different locations throughout the environment. So those companies benefit from not only the availability of data, but also the expertise that Bioceanol provides. So for example, looking at the dashboard that we've implemented for them, we can tell them, hey, something is going on there, you should be doing lowering or taking your oysters out, moving them, and so on. Because they have a lot of experience, obviously, doing what they do, but they don't know how to even get the data or interpret it. So having this capability of centralizing the information in the cloud and using our expertise and our algorithms to help them and develop a more data-oriented strategy for managing their business, which is something completely new to them and very helpful. So that's kind of step one. Obviously, there is a step two, there's a step one. And now that's targeting the higher, literally, figuratively in the food chain, the bigger corporations, typically the salmon industry. That's a much bigger fish to fry, so to speak.
And in this case, we're talking about companies that have already invested a lot in gathering data, so they don't need typically the sensors and the IoT equipment to gather the data, but they are sitting on gigabits, terabits of information that they really don't know how to exploit. So sure, they know that something is going on with the temperature or the oxygen levels or things like that, but they lack the digital and computer savviness required to interpret this data and make predictions or useful correlations. So typically, for example, when we talk about the salmon industry, it's very important for them to know what's going on in terms of oxygen so as to optimize their feeding cycles. If you feed too much when the oxygen is too low, the fish won't eat because it's focused on getting oxygen. And therefore, that results in a lot of waste and also mortality. And if you follow a little bit what's going on with the salmon industry, it's an industry that's more and more targeted by the environmental press in that they are wasteful, polluting, so nobody wants to have a salmon farm anymore near their house. So anything that improves their ability to operate efficiently and in an environmentally sound way is welcomed by them. Ironically, the one thing that the public loves about salmon companies is their use of high technology. So that's where we come in and are able to help them. So we work with a lot of those large companies, typically in Norway, Canada, Chile, and we see a lot of opportunities also developing there and the ability to help with creating a more sustainable aquaculture industry. We also work a lot with water companies in monitoring their activities and environmental impacts. Typically, that's controlling and monitoring and predicting pollution in the sea near where these companies operate. Also, we worked a lot with some of the water companies in the Great Lakes area because they also depend on being able to predict low oxygen events or waves of HAB, which happens now more and more regularly due to global warming. And being able to predict means they can take actions, better use their manpower or equipment to pump water, do things that they could do ahead of time and results in a better operation and a lower environmental impact. So this is also an area where we see a lot of potential, and we've partnered with some of those companies that you see there, especially in France and around the world, in order to give them the best solution possible there. So I am the representative for North America, like the other speaker was saying. That means a sales guy also, which means that we are, after conquering France, of course, now we turn our eyes to the new world. And especially, of course, Canada with the salmon industry, but the US, we have a few deployments already in Southeast, and we're looking for partners to help us do all these things that I mentioned here. And that's about it. Thank you.
My other panelists, could you come on up? I've somehow got to pull up questions in 1 minute. I'm going to take more than 1 minute. So, audience, you should know the drill. If you've got questions, raise your hand. If you don't, I'll make some.
Well, 20 of us left.
One of these is flashing. Anyone?
I'm Takashi Gojibori from Marine Open Innovation Institute at Shizuoka in Japan. Thank you so much for very significant and wonderful talks. I would like to ask all of you about data policy, particularly international data sharing. Actually, as you mentioned, the data acquisition will be very important. Also, data sharing could be important because no borderline on weather or like environment. But to obtain acquisition of data itself, very much costly and technology oriented. In the case of human genome information, I think a human genome sequence data shared internationally. Then digging out for disease-causing genes. But some countries are not disclosing the genome information because it's very, in terms of national security to some extent. But in the case of COVID-19, like SARS-CoV-2 genome sequence hugely accumulated, and under the initiative WHO, I think shared the sequence data, then distributed, then I think, as a human being, digging out important information has been obtained. But in the case of those marine data, it's very important. Therefore, international sharing could be crucial, but still it will be related deeply to national security or like a costly. And also even spinning out or like a venture company may rely on those data. So therefore, I think in the kind of contradictory to protecting data or protecting like a new business models. On the other hand, sharing data is quite important. How do you consider the data policy internationally, or sharing or not sharing, particularly in the coming years? It will be quite crucial. I would like to know your comments.
Thank you for your... Good. I can project my voice. Yeah, so in regards to that, so we are a for-profit business, but Jupyter has something called the Jupyter Promise, where we collaborate with nonprofits to satisfy that specific requirement, international cooperation. So right now we're working with the Nature Conservancy on a project based in Colombia, where we're providing the access to our data set for free to help them drive some resiliency for a project they're specifically working on.
Yeah, thanks for the question. It's actually, as a small company, we rely a lot on getting data for free because we've seen how difficult it is to gather data and deploy equipment. When you get into hardware deployment, it becomes pretty gory, pretty fast. So availability of data is important for everyone. Now, as more and more sensors are deployed, the likelihood is that the data is going to become more and more heterogeneous, not the same as if it's provided by one government. So maybe one idea is, and to us, obviously, and I think for a lot of companies, data is more important than money, is worth more than money. So at some point, maybe why not consider a marketplace for data, and with a sharing and exchange, and make it beneficial for companies to share data, mutually beneficial.
Goes on. Now, there we go. Thank you. So as a federally funded program, we're absolutely committed and must be committed to fair data practices. We do everything open source, all of our code, all of our data. We ensure that it goes not only into these national data clearinghouses, but into international data clearinghouses. This is a commitment we make. We fully recognize that the private sector can then take those free data and add value. I think that conversations Carl and I have had, which is maybe not germane to this discussion, is just what is the return on investment from industry back to the private sector, where to the public sector, where these taxpayer dollars are ultimately fueling these industries. Separate conversation, I think. But I'm glad you brought up the Human Genome Project example, because one of the things we're doing with these robotic microscopes is trying to generate libraries of images that are publicly accessible to anyone in the world to then slice and dice, create their own classifiers, their own machine learning algorithms, and that this would be interoperable with similar efforts going on in France and elsewhere, such that we get the power from the increase in size of these libraries, just like you do from the Human Genome Project, so that anybody can go in and start to understand whether you're interested in harmful algae or whether you're interested in creating just an incredible ecosystem model that is end-to-end with a million state variables. You can do all of that. And so these are the commitments we've made, but it's in part enforced because the federal government tells us it has to be. and I think that that's important.
Hi. Yeah, great question. So from our perspective, in Benchmark Labs in particular, we give the option to each of our users to opt in if they want to share the data or they want their data to be used to improve the forecast of their neighbors, let's say. However, we are cognizant that especially in the energy sector and in agricultural sector, the value of these unique data sets, it's almost something that they don't want to share. Because in agriculture, in particular, they believe on the value of the terroir. That's the unique characteristics that make their winery better than the neighbor, or like the notes, the intangibles of the fruits that make that wine have like a special note. In energy, on the other hand, some of the contracts explicitly say that their data cannot be used to help other companies because, of course, there is leverage, and once they lose what is called the alpha, then they don't have any economic incentive to do it. However, we work also with non-for-profit organizations like the Nature Conservancy, and they very openly say, like, use our data, share our data, and help anybody that can benefit from these data sets. Another aspect that I think that's important to highlight is that not only is important to share data, but it's also to have a source that can quantify and qualify the data, because not necessarily because it's public, it means that you can trust the source of the data. And I had experienced that while doing forecasting for yield, especially in Asia. Some numbers are provided by the government, but do not necessarily reflect what the physics or the biology said that they should be producing in a specific region. So I think that that's an interesting level that needs to be also addressed, because you cannot necessarily start building models once you have the data.
Thank you so much. Thank you. We've got just these next two, and we've got to keep them somewhat brief so we can have a break.
So my question is directed to Clarissa. I work for the U.S. Department of Commerce up in the San Francisco Bay Area. But my question is relating to me as a kayaker and fisherman in the San Francisco Bay. We just had one of the worst algae blooms up there that I have seen in recent memory. And I was just amazed at how slow it was for people to assess what was going on, to telegraph what was going on. We had a huge fish die off, and then me just through my interaction with the bay as a fisherman and a kayaker, saw all kinds of other terrible shellfish die off, shrimp die off, and there just seemed to be an ambivalence in the general community about it, and it lasted for quite some time. And then in terms of mitigation, what do we do about that, building in resiliency in these kind of bodies of water that are heavily stressed but valued? I mean, I know this is not your geographic jurisdiction, but I'm just like kind of outraged a little bit.
I mean, it used to be. A lot to be said here. That was a bloom of something called heterosigma. It's a type of flagellate. They do respond heavily to nutrient loading. However, that kind of flagellate has not bloomed like that in decades in San Francisco Bay. We deal with this kind of low-frequency variability that makes it really hard to understand what a particular organism is responding to, a particular event at that event scale. Hard to connect that back to what's happening in terms of trends and how we mitigate that without the ability to have a really dynamic time series that would help you build a model that would help you mitigate through forecasts. Now, I will say in terms of the response, I'm not sure you're talking about this apathy. I know on the side of NOAA and on the side of the academics who were in the region, there wasn't apathy per se. They were pulling down the Sentinel-2 and 3 data from European Space Agency, really digging into following and mapping the progression of that bloom, looking at the very long time series of imaging flow cytobot and other water quality data that they have from the region to understand how anomalous it was. Now, on the side of the local jurisdictions and how they were responding, I can't say. I know that I personally got calls early on from water quality people about that bloom. So I know people were alarmed. I know they were trying to respond, but I think that there aren't a lot of things you can do post facto with a bloom like that in terms of mitigation. You can try to be prepared to clean up the beach. You can't stop the animals, prevent the animals from dying. It's a combination of factors, mostly hypoxia, because as that bloom degrades, the bacteria are degrading it, they're heterotrophic, they're respiring. And that's what we saw with the red tide here as well. So I get your concern. I think the problem we have facing us with harmful algal blooms is how unique each event is. There isn't always it's hard to get, the theory behind it is tricky. Some of these things we're kind of in an era of flagellate blooms right now, as opposed to, say, diatom blooms. This is highly connected to decadal cycles and the oceanography in the region. And some of this is, we have to realize, connected to natural oscillations that we have now with our long time series been seeing for decades as we move from eras of dinoflagellate blooms to eras of diatom blooms. And so it's an interesting thing to how do you take the secular rise in greenhouse gas emissions and put and overlay that with decadal oscillations in the environment. I think this is for all of us a struggle. But I appreciate your question. Did I answer that? Is there more I could say? I don't know about the apathy.
Maybe at the break.
We could. There's no model yet for heterosigma. It's too rare of an event. I mean, I showed you models for other ones, but that's because we know they're just constantly hammering us. With this one, it really did sneak up on everybody. Yeah.
Is yours quick?
That will be the last question. I'm Pierre Alves, the chairman of the Biomarine Organization. We're working on some major seaweed projects around the world. And
so I imagine you're familiar with the TNFD, which is coming out, Task Force on Natural Financial Disclosure and Nature Financial Disclosure, which aligns investors and regulatory requirements coming from TCFD, which is the Task Force on Financial Disclosure. But aligning with what you're saying, we are starting to see those specific requirements in the monetization of biodiversity. We don't hear them as often as you hear TCFD aligning with things like the EU taxonomy and the SEC regulations, but it does come up more in conversation just at a high level from my business development work.
Thank you. So from our perspective, I think that it's important to understand the impact of biodiversity, and of course we relate it with extreme weather events and what is happening now. The situation of monetizing it, of course, at the end depends on like who is your stakeholder, who is funding your project. And there are different ways that you can get support for those kind of initiatives. They can not necessarily come from the private sector. It could be government organizations, NGOs. We have worked with the World Bank. We have worked with international development organizations over the world. And those ones are also interested in understanding the value of ecological services. And biodiversity is key to understand how healthy an ecosystem is. We're talking about marine ecosystems or land ecosystems. That's a key component that you can find a way from different organizations, maybe that are not necessarily oriented on creating a venture-backed business that will scale to billions of dollars, but definitely you could definitely get funding to support those initiatives.
I only know this conversation from the perspective of protecting biodiversity, so I'm not 100% sure where to take this, except to say that all of the programs that we work with in the United States that are creating and procuring biodiversity data are all committed to making sure that those data go into repositories like OBIS, Ocean Biogeographic Information System. We try to give them the full treatment, which is things like Darwin Core and these fancy transformations that may or may not be useful to the private sector. But for us on the academic side, we get a lot of excitement thinking about how to transform data into other formats, and then just sort of leave it at that. And then we feel like, job done, check that box off. What happens to it afterwards is a whole another set of questions, and I don't even know that we've even begun to ask those on our side at IUS.
Yeah, from our perspective, we've seen a number of those initiatives, private initiatives, so typically kelp forests, growing kelp forest, and using that to sequester carbon. And most of these efforts are just starting, and they're just starting to think about data collection, even less what to do with the data and how to use it, how to make it useful for their purposes. So I think, the best answer we can give at this point is stay tuned. It's something that's probably going to develop over the next few years. And how to monetize that is also another question, another riddle that will need to be answered. But I trust that that will be the case soon.
I just want to add one extra comment to that question. I remember, probably 5 years ago, things like that, there was some interest to look at the lesser prairie chicken in Oklahoma and Texas. I was at that time working at Princeton, and they asked me, can you help us with better forecasts for the nesting habitat of the lesser prairie chicken? It's very sensitive at 40 centimeters. So my academic mind said, of course we can do it, we are NOAA. The reality was that, of course, we produce only surface temperature or 2-meter temperature, 10-meter temperature, but not at 40 centimeters. But nevertheless, there was an interest to save that species. And they are we can go in a separate conversation and discuss why they are interested in saving those species. But that's a very clear way that biodiversity can be used for good, monitoring how healthy an ecosystem could be. And it could be for endangered act species here in the United States or globally. And also those kind of activities could prevent, for example, extraction activities in different ecosystems. So having awareness of how these species interact with the environment, depending on how protected they are, could determine the direction of many government decisions. And I will leave it there.
So I'm going to wrap up. I've got notes to try to cover the themes that we've talked about in this session, and the overall topic of reducing risk and increasing resilience and using environmental data solutions. I think we've definitely seen that on display. What happens to me in all of these discussions, specifically I think around BlueTech Week, because we're bringing what Michael Jones likes to call the triple helix or the quadruple helix in terms of government, nonprofit, private sector, and academia together, is that there are greater challenges every day, and finding the solutions means it's a sort of an all hands on deck. And then the thing to figure out is how do we work together with our different ways of measuring success in this regard. And I don't have a clear answer to that, so I'm sending you to the network break to try to figure that out. And so, but I have, one of the answers is we keep having these discussions, and don't be afraid of these questions, and try to sort them out and identify where we can find the joint solutions together. So let's give our panelists a round of applause and thank them very much. And we are to have a break that is supposed to start a few minutes ago, and it goes until 3:30 p.m. And come back here after that for the next panel. Thank you, everyone. because it's about that time. As an experienced BlueTech Week Scripps Forum attendee, I've asked us to try to figure out if we could see sunset today. And so sunset, I hear, is at 4:47. We're going to try to beat that by at least 3 to 5 minutes so we can get out and watch the last rays of the sun hit the horizon on the ocean. And so building the capacities for BlueTech innovation is our fourth and final panel of the day, and we have someone other than me moderating, which I love. And without further ado, I'm going to hand it off to Alex Kopelian. You can tell me how to say it right, and give us a little background, and then hit the show. Thank you.
Hey everyone, my name's Alex. I'm one of the partners at IndieBio. We're a part of SOSV, which is a global venture capital firm, and IndieBio focuses on accelerating pre-seed companies across life sciences, material science, chemistry, and other difficult technologies in the real world. We kind of do anything across kind of the world of climate change, but oceans and BlueTech has been definitely one of those sectors, an area we want to do more in. So Vanessa, thank you for inviting me. Very happy to be here. And after all 5 panelists present, I want to open up to questions. If no one has a question, I'll lob some stuff out, but I'd rather have the audience drive. And with that, I will hand it off to Jim Cooper, who is one of the co-founders of Braid Theory, who will give a quick intro on what he's working on.
Hi everyone, I'm Jim. I am a co-founder at Braid Theory. Anne and I run our accelerator programs, and I'm going to kind of give you a bit of an overview of what we're up to at the moment. I do have an accent, so stop me if you are confused by what I'm telling you, or if I use the wrong word or pronounce it incorrectly. Do I just advance by pressing the arrow key? This is an old-looking machine here, so this one here. Yep. Oh, look at that! Terrific. All right, so we like to essentially link our startups, our entrepreneurs, with the market, and we see the market as being kind of a 3-pronged system of adopters, investors, and influencers. We have high domain expertise within our team. We have about 9 people now working on our staff. We have a hybrid model of services, including strategic consulting. We do that for government and other corporates. So we have a consulting practice as well as some of the other commercialization support. We're located at LTC at the Port of Los Angeles, so we have an incubation campus. It's rather large, so we can fit a lot of startups in there. We do a lot of what I call our unique pedagogy. So some accelerator programming as well as events, access to capital, some grant writing assistance and some other value add stuff. We have a small biolab and some prototyping that we can do as well, but our main focus is commercialization, so our pathway to get there is through pilot projects, and I'll explain a couple of those a little bit later on. So again, we have a vertically integrated model. We have facilities. We're finishing, hopefully closing our fund in January so that we can start deploying that capital out to startups that need it. We have a large event every year called Ignite 22. If you haven't been, please let me know. You should show up and go. We had about 70 companies that had exhibited this year, and it's on May the 4th, which is really handy because we can always say, May the 4th be with you to everyone, so we can kind of nerd out to that. We have a number of programs which I'll go over shortly, and that includes our accelerator programs as well as our pre-accelerator and our accelerator as a service that we provide to government. We do some business development and strategic consulting for our startups and some of our scale-ups as well, of which we have probably about a dozen at the moment. So we like the integration model, the vertical integration model. We think it adds additional value. So I talked to you about our pedagogy. What is that? That's a big nasty word, pedagogy. It sounds like something that happens to your feet and you need to get it cut off or scraped off, right? It's essentially building out capability, capacity, intellectual capital, and working capital. We don't always say it's venture capital, because sometimes it's undiluted funds, sometimes it's pilot projects that are funded, sometimes it's other things as well. We like the idea of reducing risk and time to market, so kind of compressing that latency, translating that discovery to the marketplace. So we always look for the demand phase before we start accepting companies that come into our accelerator. There's no use funding them if there's no market, or if they're building something that no one wants. We like to pride ourselves in the fact that we've got rigor and methodology. So I unfortunately have the task of being the task master and kind of whip our startup teams into shape. And we have a deep mentor bench, including our advisors. And that's across, right now, that's across about a dozen areas. So from energy to synthetic biology, and I'll get to those in a minute too. Our strategic focus for the next couple of years has been kind of determined by the demand in the market. These are our areas that we're focusing on. Take a good look. I'm not going to go through all of them, but I will focus in on one area, one aspect of the market shortly. Our programs, our current programs, we have the LA Blue program, Blue Plus Celsius, which is our synthetic biology, and Springboard Venture Studio. We have an open innovation platform as well, which allows us to do some work with university teams that have been sent to us, care of the Department of Energy. A little bit more on that. We have some core programming for two Department of Energy programs, the Ocean Observing Prize and the Waves to Water Prize, in conjunction with NOAA. And we also do some work with the Canadian government, and we've run several startup programs with them as well. One that is in particular around market readiness for export. So using Southern California as kind of the export market and seeing what value exists there. That usually runs around kind of looking at creative destruction, how we build teams that have across various partners, that might be in multiple universities, how we use the teams more effectively, and then some virtual incubation as well as some commercialization workshops. So we like to do it this way. We think that it's a more efficient way of driving commercialization. Some program descriptions. I'm obviously not going to go through this entire wow, geez, that is a lot of information. I didn't realize I'd put that much in. It didn't seem that much when I was actually doing the typing. I was just like listening to the music and typing away. But essentially, we do have 4 basic kinds of programs. We are developing a landing pad program as well. So as we open our and expand our offices overseas to Sydney and Barcelona, hopefully in the new year, we will have kind of a landing pad effect so companies can go back and forth to those various cities as needed. Some example pilot projects. We did some work with FredSense. They ultimately got some work at the Port of San Diego to do some work around their fantastic little biosensors that they have. Afenco was or is still a company that is from Canada. They do a stop-to-start technology for hybrid vehicles and yard tractors at ports. And Frog Creek Partners, this is by no means the only companies that we have, but these are some examples, pilot projects. And then we had a non-paid pilot project with Frog Creek Partners, say that 10 times fast. And that's it. I did have some stuff, I thought I did have some stuff here on our synthetic biology stuff, but it appears that it has disappeared. I think it might have disappeared because of the... Yeah, it's disappeared because of the different formats on this computer against the... Doesn't matter. You can talk to me later about our synthetic biology work. I'd be happy to chat to you about it because I thought it was really cool. It's, I think, a unique area which very few people in the blue technology space are focusing on. So with that, I will hand it back to Alex.
Very strategic way to have people come find you afterwards. You leave the hook, the sinker of synthetic biology as a topic. Cool. Next up, let me just find your slide deck here. We have Josh Carter from Washington Maritime Blue coming to us from Seattle. And do we have your slides? Yes, we do. All right, go ahead.
Perfect. Thank you. First of all, thanks, Matt, for having us and inviting us here. We were part of the workforce, or not the workforce, the small group yesterday, and had a great conversation. So I appreciate you inviting us again this year. My name is Josh Carter. I'm the director of Blue Ventures for Washington Maritime Blue. That essentially means I oversee all of our entrepreneurial programs. And I'm going to start a little bit about our origin story and how we got started. Governor Inslee in Washington State wanted to make the blue economy and propping up the blue economy a priority. And so he commissioned this report, the Washington State Strategy for the Blue Economy. And out of that report came various ways that we can do this work to prop up the blue economy in the state of Washington by way of these other clusters that exist all over the place, but they just don't simply exist in the U.S. So using sort of the cluster model as a benchmark, we created Maritime Blue. And we were the first cluster organization in the state. Now there are 9 others, ranging from biotech to aerospace to even there's a 5G edge cluster now. And so Maritime Blue is sort of the template that they used. We have a number of goals that were part of that report that we use to align our work: deep carbonization, blue innovation, working waterfronts, workforce development, and cluster coordination. And we talked a little bit about these multifaceted groups, that these touch points to get the work done. And so we kind of affectionately call this our quadruple helix approach, where we bring together academia and research and workforce, community works, government and public sector, and industry and business. And what that looks like is basically a logo farm of lots of really fancy logos. It's a little cleaner than Dr. Fu was earlier today, but nonetheless, still a lot of really interesting folks in this slide. Some of these in the top slide are large enterprise companies like Gloston or Kongsberg is also a member of Maritime Blue, was here earlier. But public partners, private partners, even folks from Scripps here. We just had a really cool collaborative summit up in Seattle last month, and Vanessa joined us. There was a representative for braid theory as well, so it was a lot of fun to do that collaborative work. I won't go through all of these in the interest of seeing the sunset. We could be here all day with all these various things that we do. I'll touch on a few things, but obviously the Blue Ventures is more relevant to the work that I do. We also do equity engagement, and that looks like workforce development. We go into underrepresented communities and put them on a path to career development in places they normally don't see themselves in. So not just the engineering spaces of a ship, but up in the pilot house. And then we have joint innovation projects. I'll share that in a second. And then strategic initiatives. Quiet Sound is a new project. We act sort of like a project manager, where we facilitate programs so that the shipping industry that goes through the Puget Sound voluntarily slow down so they don't impact the very fragile orca population in the Puget Sound. So we have a whale alert system. We let them know, and then they're able to better navigate where they can go around. Yeah, there's a whale. Absolutely. And then the Blue Hub, which is amazing. I wish I would have added some renderings here. We are actually taking the Port of Seattle's oldest building, gutting it, keeping the old growth beams, and putting the world's most energy efficient building in its place. And so that will act as our Maritime Innovation Center in the Port of Seattle. Some of the joint innovation projects, things like bringing back the mosquito fleet up in the San Juans in the form of zero-emission fast foil ferries. They're carbon-hulled, electric-powered, just carry passengers, and the first route will be between Bremerton and Seattle. So we're really excited that project's moving ahead. The Tacoma Tide Flats 5G network is the first believe it or not, 5G network for the use of port operations on the Western Hemisphere. These are very common in places like Singapore and other, but we just don't have them here. So I'm really excited that project's going forward. Green hydrogen shore power for ship-to-shore power for green energy. The COVID-19 detection and planning literally kept the fishing fleet in Seattle afloat, doing vaccinations for all the sailors and folks in the fishing industry. So that was a huge win for us as well. And then now we're looking at offshore wind in collaboration with folks here in California. We talked a little bit about the youth or the workforce development, so I won't spend a lot of time here. I just wanted to show that this is really important work that we do. I'm really proud of this team. It's a really small, dynamic team, but they literally take kids from senior year. We were talking about it just a little bit ago about the need, and he was saying, you got to do this, you got to do that. You have to check in all those boxes. We do all of that, which is great. We get them in high school level. We've tracked them through their college years, and we pay them an internship as interns. And most of the time, the companies match what we pay, so it's great. And these are the programs that are part of that. And so we're really excited that these programs are actually expanding, which is really exciting. And then, back to Blue Ventures, we have actually 4 programs. I'll talk about 3 of them today. Our Washington Maritime Innovation Accelerators, our sort of marquee program. We've done 3 of these programs, and historically, they've been free to go through. The companies go through them. We don't do a warrant. We don't ask for equity. It's just come and be part of this amazing program. We're changing that with our 4th cohort. We're actually creating a fund, which I'm really excited about. It's a $10 million fund, and that will be used as a vehicle to invest in the companies going forward. And so with that, we'll create an incubator, so there's an off-ramp for companies that are venture scale and companies that are not. I'll go through that later. But we're really excited about that. And then the Tacoma Incubator, the middle logo there, is our 1-year free program that is very geographical focused. It's in Tacoma. It's built by folks in Tacoma. I'm saying Tacoma multiple times so you get the process here. Like it's a very deliberate program. And we hope that companies stay in Tacoma and build their companies there. And that is in a building called the Center for Urban Waters. It's a collaboration between the city and the University of Washington, Tacoma, where they get access to a wet lab, which is one of the only wet labs in the area. So we've had companies like Aquaga, who eliminate PFAS or forever chemicals, go through that program and use the wet lab to test their technology. And then our new program, which is our One Ocean Innovation Accelerator, is where we bring our international companies and run them through a 12-week program. It's a brand new program. We had been getting a lot of inbound applications from international companies. We took CanScan from Canada in year 2. We took Weave Air from Singapore in year 3. So we knew we were getting a lot of folks that wanted to go through our program, but we just needed a more deliberate place to put them. So this program is for later stage companies looking to expand in the U.S., and we use the One Ocean program to do that, and we spend time with the Department of Commerce to help them off-ramp into Washington State. And so these are the companies that have gone through some of the programs that are in this room. Probably recognize a few of the logos because we've had multiple companies go through other programs. For example, Algeon on the bottom left has gone through Vanessa's Scripps program. So, and I know Ecosphere has gone through a few programs. So there's a lot of collaboration here, and we really pride ourselves on having a really good mentor-based program. I think that's part of our secret sauce, is that we have this amazing breadth of experience to come through and help these founders with their startups. And they're everybody from, well, last year or this year we had Meta World Peace, who was famously with the Lakers, won a ring with Kobe, came and talked about mental health, if you can imagine that. And but it was a great, amazing, very vulnerable conversation, and the founders learned a lot. Our programs have had impact over the few years that we've run the program. You know, collectively they've raised over $450 million, and I'm proud to say that the jobs they've created is actually over 500 now. It's a little bit old, but I think it goes to the way we approach our programs. We don't just build a curriculum and run them through a standard sort of cookie cutter program. We get to know the founders first, and then we build the program around those deficiencies. And I think that's why the program has a bit more impact. Is I don't want to have a bunch of founders come in and they're great at marketing. I'm not going to put some subject matter expert at marketing in front of them, because it's going to be lost on everybody. So the things that we're looking forward to 2023 and beyond, again, focusing on our venture scale companies with this new Blue Ventures Fund 1, establishing an incubator program for Seattle, which we've done, starting the One Ocean Accelerator for 2023, the West Coast Blue Ecosystem Collaboration, which we kicked off in October, and hopefully we're back here very soon, because I love the Pacific Northwest, but I like the sun as well. And then our Blue Ventures Alumni Summit. What we do is every year we bring together, and we haven't had very many alumni, but this year we got to do it, bring all the founders together again to further that impact, to sit down and figure out what else can we be doing to be helpful. So we bring all the alumni back for a few days to learn more about how they can raise more money or find more businesses or find more partnerships or even collaborate amongst themselves. Last year we had Silverback Marine, their aluminum boat builder, and Pure Watercraft, they're an electric outboard motor company, won a grant with the Port of Lopez to build the first ever all-electric pump-out vessel. And so we're getting a lot of collaboration, and we know that magic happens when our founders are all together. We're a small but mighty team, and it's we really do punch above our weight. We only have 2 people on the venture side, myself and Karina, and then just 3 people that run our workforce development stuff. And then just 2 people run all our projects. So we're really, really busy, but in the most amazing, thrilling, and fun way. So my email's here. I'm leaving tomorrow morning, and I have a dinner thing at 6. So please take my email down, because I want to meet all of you and talk to all of you. But I unfortunately have to bounce after the sun goes down and hang out with you a bit more. But thank you very much.
Awesome. Thank you, Josh. And those panels, mostly ecosystem builders. We do have one founder here. Is Jack Pan around? No? Cool. I haven't met you yet, so I'm glad you're here. Jack is going to tell you about his startup, which I think is actually came out of Scripps. Go ahead.
Thank you. Thanks, Alex. Nice to meet you too, and thanks everyone for having me again at BlueTech Week. So, what is a weird interface? My name is Jack. I received my training as an oceanographer here at Scripps, and currently I am a MPP fellow at NASA's Jet Propulsion Laboratory, working on various remote sensing projects. And I think Matt asked me to serve on this panel to provide the entrepreneur perspective on blue tech innovation, the role clusters play in the blue economy. So I'm with a startup company called Ocean Motion Technologies, and we make a small-scale ocean wave energy device. And this device was specifically designed with ocean observation and ocean monitoring in mind. And so we're particularly targeting a wide range of off-grid, low-power applications in the blue economy. And our power solutions to pave the way for building up this ocean of things, or this big data infrastructure for the ocean, like what we have been talking about throughout the day. So this new paradigm will enable key stakeholder to enable it will enable key stakeholders and policymakers to have the capability to quickly respond to changing ocean conditions. So whether if it's monitoring for overfishing, predicting harmful algal blooms and ocean acidification, weather prediction, long-term monitoring for climate change, and etc. And there are lots of very capable companies and individuals who are contributing to the build-up of this ocean of things paradigm, and many are right here at Scripps and in the San Diego region. And most work done so far are focused on the autonomy and network amongst these autonomous platforms, and we have been more exclusively focused on working on the power component to support the technologies in the first 2 categories of this diagram. Another thing is this artists update this figure every year, so every year when I check this figure, it gets just more and more complex. And also another thing I want to mention is this project, this wave-powered ocean of things, platform systems is mostly funded by the U.S. Department of Energy and a little bit from the National Science Foundation. We're not trying to sell you anything, but what we're really interested in is to speak with more end users and stakeholders so that we're not just doing another random technology demonstration, but actually work towards the end goal and serve impacted stakeholders. So now I think this might be something that's more relevant to this panel. Through our conversation with fellow entrepreneurs and folks who help organize clusters and accelerators, we realized that there's something that's not clearly articulated in the BlueTech sector, and that is what's the driving force and coordination mechanism behind our sector. And I didn't want to use those words, but really what the pedagogy is getting to at the end. I think this is fairly simple for the traditional tech sector, which is, we probably all know this already, it revolves around selling goods and services to collect more user data in order to sell more goods and services. And I think another growing sector that's sort of like the BlueTech sector is the space industry, which also has a presence here at BlueTech Week. And for many years, their entire industry is somewhat scattered, just like BlueTech today. But what's really different is then SpaceX came along and sort of provided this model to really make everything revolve around their launch events. And all the goods and services in that sector then become for the sole purpose of launching payloads, essentially. And that became the driving force and the coordination mechanism. And then the launch is mapped to all sorts of applications and use cases. So with all of that said, maybe this is the way to think about BlueTech and the ocean technology sector in general. So our thesis is that the driving force and this coordination mechanism for the entire sector is about collecting more and more data in the ocean. And all of these three categories of ocean technologies are mostly there to support this effort, and then the collected data can be used to support all sorts of use cases and activities in the ocean, which then loops back to stimulate the advancement and progress in the three categories of technologies in BlueTech. And our company was really founded to support this framework, and it's based on our experience working in the field, seeing the need for more power to support more instruments and sensors and kind of tap into this underutilized power source for big data applications. And it looks more glamorous than it actually is. I was throwing up right afterwards. We have received a lot of help along the way to get us this far. And I think in light of this sea change of ocean data requirements and then the user needs for big data, BlueTech sectors and accelerator programs will play an ever-increasingly pivotal role for driving this conversation. And as we continue to define the driving force and the coordination mechanism behind our entire sector, the organizations represented by our fellow panelists will continue to be very critical to leading these dialogues. And that's all I have so far. Thank you very much.
Awesome. Thank you, Jack. Coming on the home stretch close, we have Margaret Polero from the Port of San Diego next. And
something fancy has to happen.
Oh, we have to PDF issues.
Is that? Don't come into Carl's sunset. Thank you very much for having me here today to talk about some exciting things that the Port of San Diego is doing and how we're all together supporting this blue economy ecosystem. I'm a project manager with the port, and I just started in February, so I may make up some answers if you give me tough questions. So just scroll down. Okay. So the Port is a public benefit corporation that was established in 1962, and we're the fourth largest port in California. The district spans over 5 member cities, and we promote commerce, navigation, recreation, fisheries, environmental stewardship throughout that entire jurisdiction, which includes approximately 34 miles of waterfront and just over 14,000 acres of tidelands and submerged tidelands in and around San Diego Bay. The ports are uniquely positioned to act as a catalyst for the blue economy and to take advantage of the future business opportunities in this realm. Our unique role as landlord, regulator, operator, and environmental steward enable us to provide permit-ready infrastructure and assist with project entitlements. As a catalyst of the region's traditional blue economy, the port continues to be committed to fostering these sustainable development of these traditional uses, as well as new opportunities in order to diversify our portfolio and strengthen our collective impact. We've been hearing a lot today and yesterday, and certainly the things that drive TMA is that San Diego is home to a diverse and growing blue economy ecosystem. San Diego's existing port infrastructure, burgeoning scientific community, growing tech economy, geographic location, all contribute to the region's blue economy and have created a unique hub for blue technology innovation. The natural synergies among our unique perspectives and expertise are based on our collective desire to support sustainable ocean uses, which further fuels collaboration within this tech cluster. In 2015, the Port of San Diego established the Aquaculture and Blue Tech program with the primary goal to reduce barriers to entry and facilitate development of emerging sustainable aquaculture and port-related blue technology innovation. A year later, in 2016, the port established our Blue Economy Incubator, which seeks innovative proposals to address unique port environmental challenges and inform future blue economy opportunities. The success of our incubator is based on our core value proposition, combined with port-wide collaborative process which facilitates deployment of pilot projects for early-stage companies through entitlements, assistance, and even funding to test technology in real-world conditions. This combination sets us apart from similar incubators and accelerators. To date, the port has given $1.6 million in funding to support the launch of sustainable and blue technology pilot projects and has received about $160,000 in royalty payments that can be reinvested into supporting new pilot projects. We've just issued our third edition highlights report, which is available on our website. This is our current suite of our portfolio of incubator projects. We've got 9 of them currently, and they provide multiple co-benefits, including shoreline infrastructure, aquaculture, monitoring, and water and sediment remediation. Since its inception, we've received over 250 inquiries, and I will note that we did take a pretty big chunk of time off during the pandemic, just like most other entities. But we currently have about 25 proposals in the queue, half of which are advancing through our four-step process. We receive inquiries through a rolling basis, and companies come to us through many channels, including from some of you in this room. And a successful proposal tends to come from a right-staged company that are ready to test prototypes in real-world port settings. I'm going to just introduce you to a couple of our companies now. EcoSpheres is demonstrating a cost-effective technology to extract contaminants from marine sediment in port environments and may be an alternative to dredging or capping, especially in areas that are difficult to access, such as around piers and wharves. 9 units containing over 460 spears were deployed within Harbor Island's East Basin and America's Cup Harbor in order to evaluate the reduction of total PCBs relative to starting baseline concentration over a 2-year period. The spears are all actually going to be removed later on, well, in the end of the year, so next month, for final data analysis, and so we'll see how that went. Second project to highlight is a 2-year project demonstrating innovative bioenhancing shoreline armoring technology called E-Concrete, which may serve as a replacement for traditional rip-wrap along shorelines. In March 2021, 74 interlocking coastal lock units were installed in 2 locations on Harbor Island shoreline. These units are made from low-carbon concrete mixture that was tailored specifically for San Diego Bay. Thoughtfully placed, the units can create unique habitats such as tide pools, caves, and overhangs, which mimic different natural habitats often missing from artificial structures. Now, our latest monitoring event, which was about 14 months post-deployment, Over 50 different species were found living in the units. The species composition continues to grow towards a richer, more diverse and natural community with lower ratio of invasive to native species compared to nearby control sites. While the final report including structural and general condition of the units has not yet been completed, the project was the recipient of the 2022 Outstanding Airports and Ports Project Award given by the San Diego section of the American Civil Engineers. The third project, here's Sunken Seaweed. It was a San Diego company started by 2 marine biologists. They're testing 6 different algae species to support food production, restoration, and exploring use in bioremediation, carbon sequestration, biofuels, and bioplastics. The company was ready to scale up this successful operation, and last week was approved for a second round of funding and continued support of our project of the pilot. This further work will specifically focus on scaling for culinary markets. So thanks to our collaborative approach, the Blue Economy Incubator is providing a unique value proposition to accelerate innovation. From due diligence to installation, the successful launch of pilot projects involves various port departments and subject matter experts. The port engages with Blue Economy ecosystem and with spirit of collaboration and cross-pollination, not competition. That approach so far seems to be universally accepted and applied within our ecosystem. So together, we all can accomplish great things. So thank you very much for including me here today.
You have to do some magic on here. All right. All right, and last up we have Vanessa Scott from Scripps Oceanography, and be thinking about questions. Otherwise, when they're done, it's going to selfishly be all my own, and it's just going to be self-serving. So, please, Vanessa, go ahead.
Thanks, Alex. All right, I'm setting the timer, so I'm not going to be standing between all of us. A sunset with a green flash, I'm thinking, and some good beer. So with that, I will share with you a little bit of an overview about some of the awesome things I get to do at Scripps to help support our companies and spin-out companies, our students and scientists as entrepreneurs, and connecting them with companies like many of you for research collaboration, licensing, talent recruitment, etc. So here's a snapshot of some of the programs I support at Scripps. Really what we've tried to do in my role is to connect scientists and students to companies for research collaboration, for our unique testing facilities, for talent recruitment, and we do a lot of things through the Scripps Corporate Alliance, which many of you guys are a member of. We have about 35 companies that are members that engage annually, and we kind of help support connecting them to many different scientists and lab groups at Scripps to have these conversations. And then I also get to lead entrepreneurship and startup support, which we have many different programs to help support our scientists and give them the skills that they need to explore potential commercialization of their technologies. So some of examples of our spin-outs is Jack here with Ocean Motion Technologies. Also, I think both of these other companies were already referenced today. Del Mar Oceanographic has the Wire Walker, which is a great sensor platform powered by wave energy. And then MRV Systems, who help support and make the Argo floats, which you heard about earlier from Natalie. So this is just a few of many different companies and spin-outs that we get the opportunity to work with here at Scripps. Some other things in kind of the synthetic biology space. We had a compound called selenosporamide A that is now in phase 3 clinical trials that's licensed by Bristol Myers Squibb to cure glioblastoma. So that's just a small example of a different type of technology. And then some of the different programs and resources that we kind of tee up here at Scripps to help support our students and scientists. We've got our newsletter, that's not so glamorous, but we also have our accelerator program that we've run for a few years now to really help kind of be the bridge for getting all the technologies out of the lab and into the market, which I'll talk about more. And then the Triton Innovation Challenge, which I know Jack has participated in. A lot of our other startups that actually came through the Start Blue Accelerator took advantage of this. And it's a great example of kind of the opportunities that we get to leverage as being part of greater UC San Diego, because we do this in partnership with Rady School of Management the Institute for the Global Entrepreneur, which is part of the Jacobs School of Engineering. So we really get to kind of build interdisciplinary teams across campus, connect our entrepreneurs with maybe someone from the business school to provide different types of support, and create interesting startups. So Start Blue is an accelerator, again, led by Rady School of Management and Scripps, to kind of marry the business and blue tech expertise and give our startups the opportunities to build companies and explore commercialization. It was born out of this greater Start Our Accelerator Series program that's led by Rady School of Management. It was started back in 2012, and I think there's about 100 companies that have come out now, received over 100 million in funding. The great thing is we didn't have to start at scratch to really develop the program and methodology. We kind of built off the Start Our series and obviously tweaked it to make it very much more focused to blue tech and doubled the time to make it much more time intensive for all of us. But it's good. So overall goals of Start Blue is really to support early stage ocean focused startups. So new business formation, connecting them with non-dilutive funded since they're still pretty early stage, and then really get them to the point to be able to take advantage of later stage accelerator programs like the Port of San Diego, where they can test their prototypes. And as you can see from all of our conversations today, we have so many great partners, many of who are in the room today. And I think take-home message from today overall for me too is people, programs, and partners that we all can work together to really increase and expand the workforce development opportunities and startups in the blue tech space. So we're really grateful for our partners who help us in many different ways to help support our entrepreneurs. Here's kind of the pillars that Start Blue is built on. We do a 6-week training kind of business boot camp in the fall, which we're nearing the end of for cohort 2. And that's led by instructor by the Rady School of Management, really focus on the NSF I-Core curriculum to really give them their go-to-market strategy, talk to customers, kind of flesh out their business plans. Then from January to June, we really connect them into kind of the regional blue tech industry with site visits to the Port of San Diego, to local companies like Teledyne, to really have deeper conversations and workshops on funding and SBIRs. We can connect them to maker spaces. Our mentors, similar to Maritime Blue, is really one of our hugest value adds to our entrepreneurs, which I'll talk about a little bit more. And then opportunities for fundraising like the Triton Innovation Challenge. So we are not limited to people from UC San Diego. So we have applications and accept teams from across the San Diego region. But since we are funded by the EDA grant, we do have a regional focus to build out the workforce team here in San Diego. Again, our niche is really new form startups and early stage ocean focused teams. And we obviously want to prioritize equity, diversity, and inclusion. So we're really looking for a diverse set of applicants. We also have a small and mighty team with a good combination, power-packed from Rady and Scripps. You can see here that really supports our entrepreneurs in many different ways. John York is our lead instructor for the fall programming, and Chris Ward leads our mentor program. So our mentors are very important and integral to the success of our entrepreneurs. We do several interviews when we accept teams into the program to really do a deep dive on what their needs are and match them up with mentors accordingly. And sometimes even when the program changes from the fall to the winter to the spring, we'll reevaluate and find out if they kind of need new areas of expertise to continue to grow. So they have primary mentors and teams of mentors to really support them throughout the program. And we're very grateful for these volunteers and their time. And we also have a great depth and breadth of program advisors, some of which are in here today as well, that we really appreciate to help inform our curriculum and also the application process and who we select for our cohorts and our accelerator. So just a brief overview of kind of our first cohort that finished, God, was that May? These guys were virtual the whole time pretty much, and we had our first in-person event besides the few site visits we had in the spring for the final demo day. So some people actually didn't even meet in person until then. But there was a really great group of entrepreneurs, very different technologies and sectors, as you can see. Most, I would say, had an affiliation with UC San Diego in some capacity. Half of them were founded by women, so we were able to get at least some diversity in our cohort. and just a high-level overview of some of their successes. They, raised a lot of money. They won a lot of prize money, over $400,000, and then also a lot of SBIR grants of $7.5 million. CalWave successfully completed their first pilot demonstration of a wave energy generator here off Scripps Pier, which was really cool. It was run concurrent with the program, and they're actually going off to PacWave in next year, I think it is, which is going to be operated by DOE. Algeon was also part of Washington Maritime Blue. They went into a later stage accelerator program, and Kaipono has successfully finished a pilot test in Maui, which you can't read. And here is our second cohort of startups that just started in October. Again, a very diverse set of technologies and solutions at different stages kind of in their maturity as well, but we're really excited to see what they're going to do. Again, we have, I think, 1/3 of them are female founders. The majority do have an affiliation with UC San Diego. And a great group. So they've a few of our startups have been over at the table throughout the day. I know some are here right now and will be part of the networking reception. So definitely encourage you all to say hello. I know that they're really interested and keen to connect with all of you and learn more about the industry and potential applications and ways that they can partner with you. And that is kind of sums up what I have. That's just the QR code for Start Blue. I highly encourage, we would love to talk to you, whether you have a startup that you're thinking about starting in this space, whether you want to be a mentor in some capacity, whether you just want to sign up for updates and be invited to our programming, which we're doing a lot more in person. And also if you just want to become part of our community, I highly encourage you to do so. I'm very grateful to our funders and supporters. So with that, I think I'm okay on my 10 minutes. And I look forward to answering questions on the panel.
All right, yeah, so everyone come on up. And do we have any questions that want to kick it off from the audience? Go ahead.
Wondering if you could comment a little bit about the balance among the innovators, the incubators, and the investors. So do you feel like there are not enough innovators? Is there too much investment money around there? Are the incubators the bottleneck? Maybe you can talk a little bit about that and where you think this entire space should end up eventually.
So I don't think you can hear me. There you go. When I first started at Maritime Blue 2 years ago, there were maybe, I could count on one hand the amount of investors that are focusing on the blue economy. Now it's just kind of exploded. And I think one of the reasons is certainly the supply chain issues that we had throughout COVID, and we're still trying to really get through that. The other is I think there's been a lot of apprehension in the space to invest in the blue economy. We don't have historical data around big exits in the maritime industry, so that's another mitigating factor as well. I think there are more and more people looking at the maritime space as a place to really put some attention. And Maritime Blue, we're taking all of our founders to South by Southwest in March to really kind of plant our flag and say, hey, we belong in the startup space just like everybody else. And that's our way to really usher that in. So I think to your question, there's more appetite, and it's happening at an accelerated pace, faster than I think, I'm biased obviously, but I think faster than any other industry. Maybe Jim, do you have any?
I do.
Jim always has thoughts.
I don't think, is this on?
Yeah.
Okay, because I can't really hear, there's like no fold back. It's not like a studio or something. Right? So I don't think we have a shortage of investors. I certainly don't think we have a shortage of innovators. What I think we have a shortage of is product market fit. And I think that if we could solve that problem, if we're not like a whole bunch of technologies that are going out there and just looking for some problems to solve in the marketplace. So we certainly need to have some kind of demand effect. And I think that's kind of around the point when startups get funded anyway. So I think we need to determine what the needs are from the latency point of view. So from lab to actual market. And we need not just use cases, but we actually need real demand, like actual people saying, "Hey, I need this product." And I think it's beyond just the concepts of customer discovery, blah blah blah, right? I went through iCore, that kind of thing, right? We need more than that. We need to actually physically go there and demonstrate. We need to knock on doors. We need to maybe even tear down some doors. And I think that we've got to become a bit more iconoclastic, really. I mean, we're kind of cross-disciplinary, so people don't trust us, right? Because we can't be pigeonholed very easily. So I think we've got to do more, and we've already got more stuff. And I think investors are already investing in those areas that are either adjacent to what we're doing, or they don't even know that they're investing in BlueTech, but they're probably investing in BlueTech, right? So I think that's part of the problem. So, yeah.
Oh, go ahead. Yeah.
So I joined the port from the aquaculture world, and I will admit I have a lot of scar tissue from dealing with permitting, and I think that might be a bottleneck that we may come across. I showed those great pictures of e-concrete, and in order for us to put those in, we had to agree that if they weren't really right, we had to pull it all out and put riprap back. So, which seems really counter to what we all want to do. So I think that when we look at the regulatory environment and permitting and how much comfort there might be in that space, we're going to have to do a lot of work to bring them along with us, because that, I think, is going to could be a real sinkhole.
Go ahead.
I agree with everyone else. I just would add that I think we need more faces and more people in this space. I mean, obviously working at Scripps, we have a lot of people here that have expertise here, but we're, open to the whole region, and I'd like to see more of an influx of applications. I think it's along the thread of trying to reach out to communities that aren't adjacent to the ocean, that have an interest, and how do we create that interest? And how do we need to create the demand so that people are interested because they know that these are companies that can make money. So I think it's all kind of a threaded conversation, but yeah, that's where I would love to see more of, and creating those partnerships inland and kind of further out branching to be able to connect with different audiences.
Totally. Sure, I'll add to it. So basically, from a startup founder, entrepreneur perspective, I feel like the BlueTech sector is lacking kind of a unicorn model. Yes, there are small businesses. There are definitely a lot of enterprises people can invest in. There, like you mentioned earlier, there's enough founders, there are enough innovators and investors. But really, what's the thing that would drive the innovation system, the innovation ecosystem? I think that thing is missing that we often see in the tech sector, and we really need a model to go forward. And it's programs like yours would help facilitate that process and discovery. What's the thing that would drive everything?
So there's, just to put that in perspective, Jack, right? So there's, I think, more than enough dry powder in the investment community to deploy to BlueTech. We've seen about a 430% growth since 2016 in the BlueTech sector. From a investment point of view, that translates to probably double that amount. So I think it's that we don't have a capacity issue, we don't have a capability issue, so we don't have an investment issue. So then, what is it? And I think the issue, the unpopular opinion of today. I think the issue actually is parochialism. I think we need to actually branch out of just thinking that we're groups of individuals doing work here and there, and I think we need to have, as a unified front, say, maybe it's not just BlueTech, but maybe it's, I don't know, we can accept a couple of ag tech teams as well, because they're doing stuff that's upstream that could maybe affect stuff that comes downstream to the oceans. Or maybe there's a use case that's in a I don't know, biomedical field that, oh wow, that's a really cool software as a service. Maybe we can use it to drive throughput at the ports. I think that there's pilot projects that are yet to be uncovered, and I think that those are probably out there and just kind of in this undiscovered country. And I think we wrestle with this as a sector if we call ourselves, as if we call the blue economy a sector.
I want to jump in and ask a question. Sorry, Pierre, I know I'm interrupting you.
No, go ahead.
Is it trying to boil the ocean, so to speak, by being blue tech? Like, I'll look at us. We have we have a company doing cell-based tuna fish.
Yeah.
We have a company and they're considered food tech. They're invested in by food tech investors. We have one using coccolithophores to make carbon-negative cement. They are in built environment. We have one doing CO2 into protein, and they are carbon capture utilization. It's not blue tech in the minds of people outside of who are interested in ocean.
Alex, we're boiling the ocean.
Okay.
Yeah.
It's interesting. Okay. If anyone disagrees, please jump in. Though.
Yeah, please.
I mean, I think everybody has a different. Well, I think we all have a pretty standardized definition of the blue economy, blue tech, yada yada. And I mean, TMA is a perfect example of that, right? It's everything that touches water. So it's not just ocean tech. It's not just this. And if we had a really great company that was tangential, I'm sure, like we had Kaipona Solutions, that was a stormwater drain to clean water that was going to the ocean. It's helping the ocean, right? But it's not in the ocean. So. I don't know, but maybe it's confusing to the investor community, or maybe it's just confusing to the outside community in general. And I think to everybody's point, and Jim, your point, if we have a bit more united messaging externally, I think that could help advance all of us to kind of the broader world. Because everybody knows SaaS and everybody knows deep tech and clean energy, but if we could have maybe a more unified messaging externally, that would help.
Okay. Want to go ahead, Pierre?
Yeah. So first, I'm going to have a comment. When I started, in 2008, the Biomarine network, it was in Scripps, and we had this type of conversation with Tony Emmett, the former director. He said, "Yeah, what you want to do?" I say, "I want, to break down the silos of the industry." And the blue economy is really a service provider for all the type of silos that we have: food, health, space, industry. And what you guys have done, in California and here, I see, Josh, I've been talking with Jim and Scripps. It's really unique because in Europe we have tons of incubators, tons of accelerators, but it's pure communication. Most of, the startups that are going outside this incubator accelerator, they're coming to us, say, well, we need money. So what's the point of accelerating if you don't fund the companies? Because this is the missing point. And most of the companies, they can't find the seed funding, which is where you guys have mastered, the vision and accomplished something that is much better than what we have in the rest of the world. Now the question is, when you arrive at, the end of the seed funding stage, how are you going to bridge, with Series A, private equity, VC, and how do you envisage that, and how are you going to structure, the next step? Because this is very important also for the startups to look into the future and to exit, the seed investor towards, more non-dilutive or dilutive. That's a conversation we had with Jim, investor type. Thank you.
Well, first of all, I just want to address the fact that sometimes, Pierre, some of our startups don't even know how to calculate price elasticity of demand, and they don't even know what a cap table is. So we need to get them past that point before we start really making any kind of headway into funding thesis. But yeah.
One of the things that we're doing at Maritime Blue is building an infrastructure by which we could support founders at every stage. So we can't expect that we're going to keep filling the accelerator with new startups if we don't have a vehicle to help them at the very early stage when they're just coming up with an idea. And so one of the things that we do is we're coming up with hackathons and challenges on top of the accelerator, on top of the incubator work. And then when we talked about the summit sort of being that post support, but we have other things that we do to help companies post-program, whether it's putting them in front of our joint innovation projects or where they collaborate with each other. And the other thing I will say is our program's a bit unique where we do sort of take companies that don't really fit the model of like BlueTech. I mentioned earlier we took an aluminum shipbuilder. We took a company called Sea Potential, these amazing women that were marine biologists that decided they didn't see enough people of color in the industry and created a consultancy firm where they go to Maersk and Tote Maritime and create programs by which they can hire a more diverse workforce. I mean, that's not a venture scale business, but certainly belongs in the maritime blue space. So we have to create these programs and entities and things and off-ramps where we can support companies at every stage. And at least at Maritime Blue, we're trying to do as much as we can to support that.
Hi, I'm Roy Robinson. I'm with Excipio Energy. I'll be talking tomorrow, but you guys, very interesting panel and love what all of you guys are doing. I love to see the integration because that's our whole company is built around integrating all of the offshore systems together. One of the things I'm curious about, though, is all of the stuff I've been hearing up there, at least so far, was, by my definition, very small scale. Do you guys have anything you're working on that's going to be a large-scale deployment or any plans to try to develop into that, or are you just trying to get the startups out the door and then let them try to figure it out on their own?
Define large scale.
Yeah. Okay. $200-300 million, 10-year runway.
Sure. I mean, Pure Watercraft went through our first program.
But I'm saying, but that's
sure.
to build anything of any size and any utility offshore. That's what it costs.
Yeah. No, we're studying offshore wind right now, but I mean, Pure Watercraft took 125 from GE and is now building outboard electric motors for the pleasure craft. But I mean, to your point, I think what I said earlier is like we don't have, unless you're Flexport, you're not a billion-dollar company, and there's just I could count on maybe one or two hands how many billion-dollar unicorns there are in the startup space. That's part of the problem. Is to Jim's point, we need to build better quality founders, make them more agile, make them more adapt, give them better education, and we're all up here trying to do that, right? I certainly spend the first 2 months teaching them a financial model and then also using it. So we spend an awful lot of time just boosting up the quality of the founders, not just the quality of the companies.
And the other thing this was addressed to you. You said you were going down to Texas for South by Southwest.
Yeah.
I think you'd be better served going down for the OTC in May in Houston.
Good point.
So offshore technology.
If there's no question, I'll jump in with one. So one thing I spend a lot of time with my startups thinking about is working at the speed of venture capital. And not every business is a venture capital business. That's very true as well. But I'm wondering if we focus on that, thinking about startups, like how do you all think about it as a program? Because when I see pilots that are 18 months, 2 years, honestly for us, we would see a dead company because that is like the runway of 1.5 rounds of funding in the typical venture capital model. So how are you thinking of working with companies on doing rigorous testing, which is needed for sure, but also moving at a speed that a startup often has to do?
I mean, we spend a lot of time working with folks like Naval X. I know Jim spends a lot of time, and Scripps spends some time with DoD partners, or not DoD partners, but other three-letter agencies. And I think that's a great way to, I mean, they're flush with cash right now. So it's a great way to get non-dilutive funding to get your idea off the ground. Aquaga spent, I don't know, first 3 years of their life getting grants from NSF and NOAA and others to do their, PFAS forever chemical stuff. But that could also be a hindrance too, right? I think you and I talked about this before of like, if they're spending all this time getting grants, well, how are they finding customers, right? So we spend a lot of time doing both and trying to focus on both.
Not all companies are going to be venture companies, like you said, Alex, but I think that we need to focus more on stage appropriateness. So if they're at a stage when they're not ready to move at the speed of venture capital, then they're probably not ready for venture capital. So we need to probably get them to that point. And I think that the only way to get them to that point is, any kind of service value additions that we can provide as accelerators. If it's paid pilot projects, great. But, we have to get them to a point where they're making enough revenue to attract venture capital. And sometimes that might be some patient money, sometimes it might be some impatient money, but then maybe there might be a diamond in the rough and we can see something that maybe other venture capitalists don't see and we take that bet. But I think we do need to get companies to a stage where they're thinking about their own appropriateness to that stage of development in their business. And I think that there's too many startups that want to race to venture capital before they need to actually raise venture capital money.
Vanessa,
Yeah,
Margaret?
I was gonna say, I mean, in this space, I think we're all aware that the ocean is a really hard place to do testing. There's a lot of money that needed to do R&D, for feasibility studies, environmental impact assessments. I mean, CalWave, they started their company in 2015 and they just finished their first demonstration, right? So it takes a long time and a lot of money to get up to speed to get to that point. And, people do want to see viability, and I think most companies in the blue tech space want to do it in a sustainable way. The UN Decade of Ocean Science is about sustainable development. So not to say that, being speedy about things, can't do things sustainably, but I think there is a lot of science that informs, are we making bad impacts into the ocean? How do we do this in a way that isn't making a bad impact to the ocean? And when you're looking at big technologies in the ocean, you do need to do pilot demonstrations that sometimes take multiple years to get the kind of information that you need to take the next step. So I don't know that we don't have companies in this sector that we can do in a way to get to the speed of venture capital, but I think venture capital has to look at us a little bit differently. Not that we have any less value. I think we have more value, especially in the context of all climate change, of everything going on at COP right now, everything going on in everything that we know. But how do they look at us in a way that's like a longer investment return?
Is it sunset time?
We have 5 minutes till sunset, guys. Burning questions, go ahead.
Yeah, it looks like a lot of focus is put on venture-funded efforts or startups. But my observation is that there's a lot of there's an ecosystem already in place. Small farmers, mom and pops that are already participating in the blue economy without having access to the technology. And they're really struggling to get to that stage, whether it's a matter of money or wherewithal, or technological wherewithal. So what can you say about helping this whole ecosystem get to the next stage without necessarily starting a company to do it?
Yeah, I mean, we've taken a couple of food startup companies in our programs, and it's a heavier lift for them, admittedly, right? There's not a lot of appetite, pun intended, to fund food companies in the maritime space. We've helped to mitigate that. We've done more, I think, with those companies. For example, we have a company that went through our last program called Blue Dot Kitchen. They make something called Cicerons, or kelp puffed snacks. They're so good. We ended up getting them into the arena where the Seahawks play and the Sounders play, and we ended up getting them in where the Mariners play. And that was our way of fast tracking them into market. What better way than a bunch of hungry fans drinking beer to eat kelp snacks, right? So as a result, they're growing at a clip that's just ridiculous. So that's how we're able to sort of go around that, is help prop them up in different ways.
I'll also plug one of our other incubator groups is a shellfish nursery. And so one of the things that we're finding on the West Coast for shellfish availability is that there's a seed shortage. And so San Diego is a great place to grow that. There's plenty of food, and the climate is that they grow really quickly to get to farms. So it's filling a niche that the small farmers certainly do need and must have in order to be successful. But it's just finding a different way to do it. And if you think about, do I want to eat shellfish from the Port of San Diego? Don't worry about it, because oysters filter 40 gallons of water a day, and so by the time they get to their final farm, the systems from what they picked up in San Diego are not there. And although we do have pretty clean water, so I just want to put that out there.
Last question. Okay, I'll throw it out. Oh, go ahead.
Here, and then I'm working with them on getting them into the international marketplace.
You don't need to do that. But thank you.
Because I do view that as the model that we should adopt. He's doing it right.
We're going to be opening up 2 more offices, one in Sydney and one in Barcelona, over the coming 12 months or so. So I think that having things like landing pad opportunities for startups is going to be kind of crucial for companies that are going in any direction. So they can go from Sydney to Australia to the United States, or to Barcelona, or to from Europe to the United States, and we can take advantage of that, and we will have pilot projects available all over the world. So I think that for the sake of scaling, I think that we have the potential, at least, to do very well with companies, and we're familiar with CalWave too. So if they want to have those opportunities, just let me know. I think all of our programs have something very, very unique to bring to the table, and I don't think that we do have an opportunity to be a unified front, and I kind of said that earlier in my opening remarks to the initial question. We have to provide this heavy lift, otherwise we're going to atrophy. We're going to have startup companies that are going to go, geez, well, there's Y Combinator. Why can't I just go to Y Combinator instead of going to accelerators which have domain expertise and understand the blue space? I can aggregate a dozen investors at Y Combinator. Why shouldn't I do that? So we have this unique opportunity, and we have a unique approach, and I think we need to move together to do that.
All right. Last comment.
I was just say, when I grow up, I want to be like Jim. So.
All right, everyone. We are 5 minutes before sunset. We have hit our target goal. Thank you to the panel. I appreciate you so much for giving all your insights.
All right, real quick. Getting you outside. Tomorrow, Thursday's programming with BlueTech Week. BlueTech Summit and Expo will take place at Building 177 at Liberty Station. And for those who have registered, look at the WOVA app. Finally, attendees and speakers, let's join the hosted networking event outside. Let's open the doors and go. Good job getting us out the door by sunset.